Good day, everyone. Welcome to the third colloquium on power and clean energy with the theme IECEP Power Electronics Society bringing forth advances in energies and, and towards a sustainable future. This event is a collaboration effort of IECEP Power Electronics Society, Bulacan chapter, Cavite chapter, KSA-ERC chapter, Manila chapter, and Mindoro chapter. Good morning, Sec Tony.
Good morning, partner Alvin.
How's your day, Sec?
It's great, partner, and good morning, everyone.
That's good. I'd like to ask you a question, Sec. What do you expect from this webinar?
Okay, thank you, partner Alvin, for the question. Happy to be with you all virtually, and I'm excited to listen to all the presentation of the speakers to learn more about the advances in power and energy sector. How about you, partner?
Oh, I am very much, thank you for asking, Sec Tony. I am very much thrilled to know that we will be having this kind of webinar. And I think this webinar would be sufficient enough for us to learn more on the field of power and clean energy. Nowadays, yeah, it is essential. Now, how about, I would like to know where the participants at right now. To the participants, can everyone type in the chat box? Where are you at right now? Let's see who are on the other side of the room. Yes, we see from Bulacan, Baguio City. That's good. Pampanga, Quezon City, Baguio City. Shout out from Mindoro. Good morning, batch. From Legazpi, yes, thank you. From Paco, Manila, Pangasinan, Antique, and so many more. We have so many participants today, Sectoni.
Yes, I'm happy to see everyone.
Now, moving on, for to have us a brief walkthrough on this morning session, it is expected that we will start from 7:30 and expected to end by 12:45. All right. So let me introduce myself first. I am Alvin Lester de la Cruz, a member of Power Electronic Society. And I have my partner, Secretary Antonio Jr. from Secretary from Power Electronic Society. And we are, to start with, let me give you the house rules, reminders, and qualifications for e-certificates. Now, for the house rules, to keep doors open for better communication, greater mutual respect, and greater efficiency, please mute your device audio and turn off your webcam during the presentation. Turn it on only when needed. Respect the speakers on the floor. Now that you have allowed to ask questions via Q&A mechanism of the webinar, we will not be entertaining questions via the chat box. No spamming on the chat box, please. Create a discussion or ask questions during the discussion period, as mentioned by the speaker related to the topic. Do not close your session or log out during the seminar. You may leave anytime in between, but your login may not be connected as it may interrupt the system. You can log out after the event finishes. And lastly, don't forget to fill out the attendance and evaluation form later. The link will be posted at the chat box after the webinar. Now, for you to qualify for the e-certificates, you should be registered and confirmed participant at myicep.net. For non-ICEP members, a Google form has been sent to you for your registration. Make sense of the session. Sign the attendance form, pass the evaluation test, and last survey. Now, at this moment, we would like to request for we would like to request a moment of silence for the invocation to be followed by the national anthem and the IECEP hymn.
Dear God, thank you for the opportunity to meet together. Please help us to come together to make this institution reflect your kingdom. Breathe life into our ideas and decisions. Help us build a team that has love and respect at its heart. Give us the strength to continue working for your kingdom in this time of pandemic. Lord, come give us the inspiration to be the best we can be. May we be a shining example of your goodness and truth within, wherever we are. Inspire our thoughts, discussions, and ideas, and continue to remind us that all that we do here today, all that we accomplish, is for the pursuit of truth for the greater glory of you. We ask these things in your name. Amen.
Mga kababayan, ang pambansang awit ng Pilipinas.
Kayang magiliw, telas ng sinakalan, alam ng puso, sa dikit mo'y buhay. Lupang hinirang, tuyag ka ng magiting, sa manlulupin, di ka pasisingil, sa ganagang tutok sa simoy at sa langit mo pagaw, ay hinagang tulakaw. about creating value for society, recognizing electronics for our economy, purpose driven. That's who we are. We work with ingenuity for nation building and the ever evolving industry. Dynamic, globally competitive is our institute. Excellence is what we aim. Yes, humanity a root. Professionalism and prestige is our root. For our country and the world, all of us are resolute. Engineering solutions that have led to many changes. Creativity, intelligence have been our tool for ages. Marching forward for the country, leading it to progress, making sure that you and me are part of all success. One organization, or many chapters, or one profession, walking hand in hand in the same direction. With the help above, we'll do our mission. One organization, or many chapters, or one profession. We are family, guided by our vision, IECEP. Easy is let's build a nation. Leadership and unity and progress and development, camaraderie and ethics and meaningful engagement. Members have the chance for growth and involvement, new opportunities, inspiring lives moment. Engineering solutions that have led to many changes. Creativity, intelligence have been our tools for ages. Marching forward for the country, leading it to progress, making sure that you and me are part of all success. One organization, or many chapters, or one profession, walking hand in hand in the same direction. With the help above, we'll do our mission. One organization, or many chapters, or one profession. We are family, guided by our vision, IECEP. Easy is let's build a nation. Marching to the future for the next generation, always open to innovation, innovation. One organization, or many chapters, or one profession, walking hand in hand in the same direction. With the help of all, we'll do our mission. One organization, or many chapters, or one profession. We are family, guided by our vision, IECEP. Easy is let's build a nation.
Thank you very much. At this juncture, we have the chairman of IECEP Power Electronic Society, Engineer Mark Philip G. Fernandez, to give us the welcome message. Engineer MP, over to you.
Okay, thank you very much, Alvin and team. No? So, good morning, everyone. Okay, so on behalf of the IECEP Power Electronics Society and the executive committees, the committee chairmans, no, and IECEP members, no. So to our beloved Board of Electronics Engineers, IECEP National President, to my fellow IECEP Electronics Society members, no, it is my distinct honor and great pleasure to welcome you all to our third colloquium on power and clean energy with the theme bringing forth advances in energies and breakthrough technologies towards a sustainable future. So let's give ourselves a big virtual round of applause. Okay. So it's been 2 consecutive colloquiums had passed by, no, mga ka-IECEP. And here we are again, giving you a bigger, bolder colloquium that has never been seen before. Okay. So again, we are now in the third colloquium this year, no? So it's 2023, and we are very excited to showcase once again our third colloquium. And this time, we are now going international, mga ka-IECEP, no? So meaning, majority of our speakers and even one of our members as well are unemployed in a multinational company, no? And we have also from the government. And we welcome them this morning, no, in our third colloquium. So since May of 2021, no, there are lots of milestones that we have been accomplished, no, but still we are lots of things that we need to do. But before we accomplish this, no, there are lots of sacrifices that have endured, lots of dedications have shared by each stakeholders, lots of time had been allotted. But at the end of the day, a lot of joys and very good lessons that we have been experienced so far, no? So mga ka-IECEP. So napaka-exciting po ng ating mga darating ng mga panahon ng mga events sa ating organization, no? So alam niyo mga ka-IECEP, no, kami ay nagagalak. We are very happy na makita kayo muli at makita namin kayo dito ngayon sa third colloquium. Kung nung nakaraan, no, sabi ko nga nagsisimula pa lang ang mas exciting part ng ating journey. But right now, there's no doubt nasa gitna na po tayo ng exciting part, mga ka-IECEP. And lastly, I'd like to thank the men and women, the organizers, the partner chapter collaborators, and all the volunteers behind the scenes who gave their untiring support in order to make this event a reality, mga ka-IECEP. So palakpakan po natin sila. Okay? Kaya mga ka-IECEP, walang bibitaw at tutok lamang po kayo sa isa na namang magandang colloquium na handog namin sa inyo sa tulong ng ating mga kasamang IECEP collaborators and partners. Again, hashtag #OneIECEP, hashtag IECEP 2023, hashtag IECEP Puso. Again, welcome at mabuhay po tayong lahat. And I declare this third colloquium on power and clean energy open. Okay? Thank you very much. And back to you, moderators.
Thank you very much, Chairman MP. A round of virtual applause po, Chairman MP. We have another welcome message to be given to us by the Director of IECEP Manila Chapter and Chairperson for Research and Development Committee of IECEP Power Electronics Society, Dr. Angelo Beltran Jr. Dr. Angelo, over to you.
Thank you, Engineer Antonio Diccion Jr. and Engineer Alvin Lester de la Cruz. I would like also to acknowledge the welcome message of our chairperson in IECEP PELS, Chairman MP Fernandez. Now to deliver my keynote talk, welcome message. Gentlemen, ladies, and fellow electronics engineers, good morning. It is an honor and substantial pleasure for me to deliver a keynote remark at the opening ceremony of third IECEP Colloquium on Power and Clean Energy 2023. The sense for this colloquium was the consideration for establishing a common ground for power and energy region, wherein electronics engineers will integrate in a single umbrella from different divisions, such as academe, industry, government, private sectors, among others, both in local and abroad. This occurrence that we have organized is highly suitable for that special purpose. The theme for today's event is IECEP PELS bringing forth advances in energies and breakthrough technologies towards a sustainable future. The primary generator of our economy is power and energy. We, electronics engineers, have an important role to play in energy and power section, most especially in this advent of digital technologies. And to ensure the best quality of our occasion for today, we invited outstanding speakers, both local and abroad, and may conceive a moment for us to determine the recent advances and developments. As with the previous successful colloquiums, we deeply express our gratitude to all co-organizers for today's event, the IECEP National, IECEP Bulacan, IECEP Manila, IECEP Mindoro, IECEP Cavite, and IECEP KSA-ERC, who volunteered and allocated their time for the accomplishment of today's event. I also personally highly appreciate the impressive works of the Secretariat of IECEP Power Electronics Society, Engineer Antonio Diccion Jr., who worked very hard, helped us prepare the materials needed, and his absolute commitment for the progress of this colloquium. On behalf of IECEP Power Electronics Society, we would like to recognize our important visitors from Professional Regulation Commission, PRC Honorable Dr. Alnar Detalya, our IECEP National Board of Directors, with a special mention to our IECEP National President, Engineer Lyle Anthony Joel Villas, and of course to our VIP resource speakers for their acceptance. Furthermore, we are highly appreciative to the sponsors, ABB Inc., Advanced Energy Inc., Adamson University, Philippine Space Agency, and of course to all our dear participants attending for today's event. #OneICEP, #OneOrganization, and #OneFamily. Mabuhay electronics engineers, mabuhay IECEP, mabuhay tayong lahat. Happy Valentine's, everyone. Thank you. Back to you, moderator.
Thank you very much, Doc Angelo. Last but not least, let's have Dr. Alnar Detalya, Chairperson of the Professional Regulatory Board of Electronics Engineering, for his welcome message. Chairman Detalya, over to you.
Well, good morning, everyone. How's my audio coming, moderator? How's my audio
Loud and
coming?
clear, Chairman. Loud and
Yeah.
clear. Loud and clear po.
Thank you. I'm in a location where my internet connectivity is not that stable, but please bear with me. I hope that my audio is clear to everybody. Clear ba?
Very clear,
Very clear po.
Dr. Detalya.
Yeah, thank you very much. Thank you for inviting me. And I'd like to commend the society for coming up this kind of webinar that gives awareness and updating for our electronics professionals related to power electronics. No? So it's commendable. This already your third activity, and I'd like to encourage to have more of this kind of activity. But more than that, more than this commendable undertakings, may I post these recommendations and encouragement to the society. No? Let me clear on this, no? The specific mandate of the society. No? First, on membership of the society. It is a fact that not all members of IECEP are qualified as member of the society. Okay? I hope this is clear to all of us. No? Hindi lahat ng members of IECEP are qualified to be members of this society. Why? Because this is a specialized society. Okay? A certain qualification must be earned by a professional, by an electronics professional, before he becomes a member or expert in the field of power electronics. I hope everyone will agree on this. So we have to earn some qualifications for us to be considered as expert on this field. And thus, yun yung maging qualification to be a member of the society. And so with this concept, with this idea, the officers and members of the society being classified as expert, kasi member na kayo, so we can classify you as expert on electronics, power electronics field, So being classified as expert in the field, I encourage you to develop or offer program or module to be taken by the professional for him to be qualified as member of the society. Okay? So dapat module siya with a clear evaluation system. Okay? So yun yung deeper sense of your functions as society. Of course, this kind of undertakings, itong mga webinar, this very commendable as what I mentioned earlier. It provides awareness and updating to our updating the knowledge of our members. But the question is, if I religiously attend this kind of undertakings, would it makes me expert in the field of power electronics? That's the main question. Of course, it probably will be, But as what I've said, there must be a basic qualification that should be offered by the society. Parang module siya na iti-take ng isang licensed electronics professional. And then ipasa niya yung mga evaluation system, evaluation, and then he can be classified as expert. Okay? And then after that, the society can certify that this professional is an expert in the field. And then, of course, the society, through the IECEP, will endorse it to PRC, and PRC will officially certify the professional as expert in the field by granting PQF level. Okay? So yun yung direction, future direction natin as a power electronic society. Of course, one of the mandate is provide general knowledge about this field through this kind of webinar. But more than that is we should offer or develop, being an expert, you as member of the society classified as expert in the field, we need to develop a program or module to be taken by a licensed electronics professional in order for him to become expert really of the field. So yun yung direction natin in the future. But for now, as what I've said, it is commendable, and I really appreciate the IECEP also for initiating this move. So this is way forward as we in PRC will implement the career progression and specialization. We need to establish and enhance the capability of every society, specialized society. Again, let me emphasize, hindi lahat ng members of IECEP are qualified to be members of the power electronics society, because this is a specialized society. No? There has to be a module or program that should be taken by a professional so that he can be classified as expert in power electronics. So yun yung encouragement ko sa society and also for IECEP na yun yung maging direction natin. Na? But let's not also forget to initiate measures or undertakings that will provide the general membership a generic overview about power electronics. That's also one of our functions. But as what I've said, I'd like to encourage the society to go deeper by developing modules with clear evaluation system. So with that, thank you very much, and thank you for your time listening to this particular message. Maraming salamat and good morning to all of us.
Thank you very much, Chairman Vitalia. All right, so I'd like to share the message made by our chairman also, Chairman MP. He said on the chat box that IECEP, Power Electronics Society, will help aspiring IECEP members to become level 8 experts in power electronics. Now, at this juncture, let's proceed with the overview of the colloquium to be presented to us by the Secretary of IECEP Power Electronics Society, Engineer Antonio L. Dixon Jr. Secretary, over to you.
Thank you, partner. Once again, good morning, colleagues, students, practitioners, resource speakers, Board of Electronics Engineering, IECEP National Boards, collaborating chapters, and guests. The theme today is IECEP Power Electronics Society, bringing forth advances in energies and breakthrough technologies towards a sustainable future. Indeed, the Colloquium series of Power Electronics Society aims to uphold the vital scientific, state-of-the-art developments and educational aspects of power electronics and its applications towards sustainable nation building. Next slide, please. Partner, can you share this slide?
There you go, partner.
Okay, thank you. The colloquium is composed of two parts, the AM session and PM session. We have 5 technical sessions from local and foreign professionals. For the AM session, we have the professor from Cal Poly State University, USA, with the talk entitled Hybrid AC-DC House, Paving a Pathway for Future Sustainable Homes, to be followed by the talk of the associate scientist from DOST entitled Nuclear Energy, Sustainable, Secure, and Equitable Power Source. Next slide, please. Okay, thank you, partner. For the PM session, we have the associate professor from Nanyang Technological University, Singapore, with the talk entitled Coordinated Control, Operation, and Planning of Distributed Energy Resources in Microgrids, to be followed by the talk of the Applications Market Developer from ABB Inc. entitled Power Continuity in Critical Infrastructure. And our last speaker will be the professor from Aalborg University, Denmark, with the talk entitled Neuroscience-Inspired Artificial Intelligence and Large-Scale Brain Models for Space Microgrids. So I think we're all excited to listen to all the presentations today. Let's sit back and learn. Thank you for the attention. Partner, over to you.
Thank you very much, Sec Tony, for the overview of the colloquium. Now, We will have a wonderful day and informative day ahead. So let's keep this ball rolling. I hope everyone is excited. To introduce our first speaker, let's call the Governor of IECEP Bulacan, Chapter Engineer Christian Enoval. Gov Ian, over to you.
Good morning, everyone. To Honorable Detalia and to all our PELS members, also to all our participants for today. It is my privilege to introduce to you our first speaker. All right. So our first speaker received his Bachelor of Science in Electrical Engineering with minor in Computer Science from Northern Arizona University. He earned his Master of Science in Electrical Engineering from University of Illinois, Chicago, and Doctor of Engineering from Cleveland State University. He joined the Electrical Engineering Department at Cal Poly State University in 1999, where he is currently a tenured full professor and the director of Electric Power Institute. He received numerous teaching awards, most notably the 2012 Outstanding Teacher Award from the American Society of Engineering Education, Pacific Southwest Section, and he is a senior member of IEEE. So he's actually a fellow senior member of IEEE, the Institute of Electrical and Electronics Engineers, and has industry experience with several companies, including Capstone Microturbine, Rockwell Automation, Picker International, San Diego Gas and Electric, APD Semiconductor, Diodes Incorporated, Enerpro, Renewable Power Conversion, and Sempra Energy. His areas of research include power electronics, power systems, rural electrification, energy harvesting, renewable energy, and smart grid. He has published over 200 technical papers in journals, reports, books, course readers, and served on the editorial review boards of several journals. Ladies and gentlemen, let's please welcome Professor Taufik.
All right. Good morning. Can you all hear me?
Yes, loud and clear, Professor.
Loud and clear, Professor.
All right. All right. It's a great honor to be here. I also want to first congratulate IECEP for having this series of events, educate future engineers as well as current engineers. Great job, keep it up, and I wish you all the best and continuing success with the organizations. And again, this is again a great honor for me to be here, invited to be able to share what I've started to look into since 2010. The topic of my talk actually relates to a research that I have done with actually university in the Philippines way back in 2015. The title of my presentation today is on hybrid AC/DC house, paving a pathway for future sustainable homes. And again, my name is Taufik, and thank you so much for the very detailed introduction earlier. I currently teach at Cal Poly State University, which is a Cal State University in the state of California, USA. I'm going to share the screen. Let's see. Can I share the screen?
Sure, Professor.
All right. Let's try. Okay. There it is. All right, let's before I go into the presentation, I'd like to introduce my institution here. Perhaps majority of you do not know what Cal Poly is. There's so many schools in the US. As I said earlier, we are one of the Cal State University campuses. There are a total of 23 campuses throughout the state under the Cal State flag. and we are one of the 23, and we are non-PhD granting university with a population of students of about 22,000, and we are actually the second largest campus in California after UC Berkeley. And these are a list of the colleges that we have at Cal Poly. So you can see engineering is actually the largest college among all of the other colleges in the university, with about 6,000 undergrad students and about 250 grad students. If you're not familiar with California, this is, first of all, this is the US, starting from the upper right. Let me use a laser pointer here. All right, right there, upper right corner, we have the map of the US. If you go to the west, right there is California, which is a long state. And then here's the zoom in version of the state. And you can see that San Luis Obispo, which is our campus, right at the central coast of California, which is right here. Right, so it's close to the beach along the coastal line of the central coast. Beautiful place, you know, it's a basically tourist place. So I would invite you to come visit us someday. Here's the picture of the campus, surrounded by rolling hills, not too far from the ocean, just gorgeous, place. So hopefully you get to visit us one day. Well, there's been a lot of past, students as well as visitors to come into Cal Poly to do a research with me. These are just a few of them that I can list on this slide. Actually, the first ones were a group of students from Philippines, and then we have more students from Indonesia, Malaysia, Thailand. Actually, that's a duplicate right there, and then another Fulbright scholar. So again, if you get a chance, if you happen to visit the US and California, give me a buzz, and I'll be more than happy to give you a tour to our campus. All right, so that's a brief intro to our university. In terms of the outline of my presentations, the first one, I'm going to touch base on future sustainable net zero energy homes, which hopefully by looking at that, you'll understand problems with AC. And then once we see the problems in AC, then hopefully it'll convince us that we need to complement AC with DC. And once we understand the problems and perhaps potential solution, then we could propose a solution. In this case, in this presentation, I'm proposing hybrid AC-DC house, and continue on with what we've done so far in terms of challenges and opportunities. And I'm going to close the presentation with a summary. All right. So starting with future sustainable net zero energy homes. If we talk about future homes, we often hear these abbreviations, right? This term NZEH, which stands for net zero energy homes. Basically, it is a grid height energy efficient homes that produce as much renewable energy as they consume over the course of a year, resulting in a net zero energy bill and a carbon-free home. And this house, as an example on the picture on the right here, just an illustration of a NZEH. It incorporates different technologies to make the house more sustainable. Now, of course, for this presentation, I would focus only on the electrical side of the technology. Now, that's my background, electrical engineering. I don't think I would want to touch on the other aspects of the design of the house to make it sustainable. And related to the electrical aspect of the house, this house currently, as we speak, would mostly rely on solar panels as the source of the energy for the house. There might be more in the future, depending on how we can advance renewable energy for its adaptability into this house. I will actually show that later. All right. Along with net zero energy homes, I said earlier about different technologies that are being incorporated into the house. Again, related to the electrical aspect of it, this house, in order for us to be able to reduce energy consumption of the house, it would require making it smart, basically, right? Putting sensors here and there. And as you already know, sensors are mainly operating with DC. Right? So imagine if we want to have a house in the future that has so many sensors in the house, and yet we are sticking with the legacy AC system in the house. That would make it harder to implement, right? It would be better if you could somehow make the house DC or any mix of DC and AC, so that the DC portion of the house could conveniently incorporate these sensor technologies, right? So that's one of the things I would like us to take notes on, is that sensors runs on DC, and it'll be easier for us in the future to be able to achieve or target these net zero energy homes by having some kind of a DC DC bus inside the house. All right. So that's basically future homes. I'm setting the stage, particularly on the net zero energy homes. And so I kind of mentioned already, or hinting a little bit about AC becoming a challenging system if we were to achieve NZEA. So what other problems are associated with AC? I think most of you are power electronics or know something about power electronics. So the main problem with AC is that if our loads are DC, right, and our source is AC, then of course we're going to have to be able to convert from AC to DC using this converter, right? So there's a mismatch between the signals, which is a sine wave, into a flat DC. And in the process, if you convert from AC to DC, there could be as much as between 17 and 35% loss. And that's something that hopefully we would be able to avoid having in the future, right? Now, another problem with AC, besides the fact that if the loads are DC, we're going to have to convert from AC to DC, which has some level of losses. Another problem with AC is that it is hard to control, right? DC, since it's flat, it's only one polarity, is much easier to control than AC. Now, AC, on the other hand, if you recall, has different type of power, right? It's not just one. In DC, there's only one, which is called watts, right? In AC, you got several types of power. You have instantaneous power, you have average power, you have reactive power, you have complex power, and you also have apparent power. So each single one of these type of power requires close attention. Otherwise, the system is not going to operate in the most optimal manner. So because of that, you can see clearly, one type of power versus five. Of course, less complication with DC because it has only one type, as opposed to AC that has five types. Right? And then another thing about AC is that due to the inductive and capacitive effects in AC system, then in AC system we'll run into what we call reactive compensation, right? If the load is mostly inductive, then you're going to have to be able to compensate that with some kind of a reactive source, right? And in the process, then you're going to have to install more components, costly, right? And then more loss as well. So again, these are more problems associated with AC. Okay. Now, I hope that I convince you of the problems with AC. It is a legacy system, right? We've used it for a long time. We take it for granted, right? This is a system that Tesla and Westinghouse implemented a long time ago, and infrastructure is already here. But unfortunately, if we want to move toward the future of houses, we're going to have to be able to revisit, if you will, the electrical systems that go into our houses, right? To make it again more sustainable. All right. So now that we hopefully understand the problem with AC, then I'm trying to present right now is what can we do? What can we do if there's a problem with AC? What can we do? Well, one thing that we can do is to complement with DC, right? Several reasons why I believe this would be a good strategy, right? To complement with DC. Number one, if you look at these examples I have on the screen, I have left figure and right figure. Let's look at left figure first. On the left figure, we have this graph that shows the number of smartphones globally all the way to 2021. You can see the increase, right, of the number of smartphones in the world, right, numbering total of 2 billions smartphones in 2021. Right, so that's a lot of us smartphones. Now, if you do just a simple math, right, as we know, a smartphone is a DC load, right? And let's say you're charging a smartphone with a USB, let's say a USB is 5 volts, and uh, let's just assume that the current is going to be 1 amp, and we charge it for 1 hour. And if you multiply, these numbers with 2 billion around the world, then you can see the humongous amount of energy that is being provided into DC, right? One cell phone may not represent a good portion of the DC load, but then if you think globally, like 2 billions times all of these numbers, you get a huge number of energy, again, being processed through DC. So that emphasizes the importance of DC there. Another example would be LED lights on the right-hand side right there. We all know that nowadays more and more houses are using LED light bulbs. In fact, you should actually replace your light bulbs with LED because that would save energy costs monthly, right? Because they're so efficient in terms of consuming energy. So again, as you can see, the number of LED usage throughout the years until 2015, it's kind of like exponential increase, right? So that's another proof, and as you know, LED is DC. This is another proof that DC load has been increasing significantly in the past few years, recently, right? While the cost is going down right there. All right. Now, another reason why I believe complementing with DC would be a good strategy would be technology, the technology for DC, not just on the load side, but also the way we would be able to connect or interface electrical system into a DC load. In particular, I'm talking about USB Type-C. Everybody's here familiar with USB Type-C. And when it came out, the target wattage was 100 watts, right? But now it has been upgraded to 240 watts. Can you imagine if you have a USB-C that can actually deliver 240 watts? That means in your house, you can have USB-C plugs that can power so many DC loads, right? But that means you don't really need, AC to DC anymore if you can somehow be able to have or provide a DC bus in your house, right? So again, this is a technological development, just came out recently, which is wonderful because now we can start thinking about what can we do with these 240 watts coming out of these USB-C. It's going to be a lot of loads in the house, right? Before it was just limited to charging smartphones, charging tablets, but now with 240 watts, you can power so many other things in your house. Okay, another reason why I believe complementing with DC would be good is that I ran kind of a quick statistic. This is in the US. Is that back in year 2000, the mixture of DC loads versus AC loads, you can see is around 20% DC, while 80% are mostly AC loads. That's back in year 2000. But then fast forward into 2018, you'll see that this percentage increases to 30%. Now, this is in the US. I would suppose that in the developing countries, the percentage of DC loads will be even higher. Why? Well, because in the US, I don't know if you're familiar with the typical residential in the US. Here in the US, a typical house would have, big washing machines, right? And then big refrigerator, right? Air conditioning, heater, and these are all big ones. These are all AC type of loads. Whereas in developing countries, a typical house would also have refrigerator. It's not gonna be as big as the one we have here in the US. It's just a different way of culture in terms of storing food. So I would argue that in developing countries, the percentage load of DC nowadays will be much higher than what you see here. Perhaps I'm guessing maybe about 40% or so. So that shows you the increasing significance of DC in our house. What else is another reason for complementing with DC? Well, more and more houses, especially in California here, utilize rooftop solar panels. In fact, any new house built in California, that would have to actually have rooftop solar panels. Right? So that means, as you know, solar panels, they output DC, right? That means you actually have a DC source right at your fingertips, right? And if that's the case, then why is it that if you have a source that is DC and you have increasing loads that are DC, you would have to go from DC to AC and back to DC? Doesn't make sense to me, right? So it's basically what I'm trying to say from the previous slide is that if you have a DC source, then this is if you look at the bottom diagram, this is practically what we are having now, right? Is that you have a DC source PV and then you convert it into AC with some losses, and then you convert it back into DC because we have DC loads. And you cannot just do AC to DC, you have to follow it up with another DC to DC to regulate the proper voltage for the DC loads. So in the process, as you can see, we have series of losses, right? And that means, or that implies cost, right? Increased cost of energy. Compared to, for example, if we're able to do this, right? If you have a DC source such as PV and then DC load, then it would make sense to me to just go straight from DC to DC, right? Regulated DC outputs right here, right? Some loss, but not as much as the bottom diagram right here, which is what we are currently doing. Okay. Another reason, so I've already given you lots of reasons why I believe it is a good strategy for DC to complement AC in the future, right? Hopefully near future. And then we also realize about, we observe about, the increased usage of smart home devices, right? Such as smart cameras, smart locks, what else is out there? Smart speakers, right? And so on and so forth. And these are all, operating with DC. And imagine if we have a DC bus running in our house, then we can just basically, tap into this DC bus into our smart devices rather than having AC to DC and then back DC to DC again, right? Oh, another reason. I thought I was done, but actually no. There's actually another reason. Yeah. So then this is kind of aligned with the solar panels that I talked about earlier, right? As you may know, there is a mismatch between energy produced by the solar panels throughout the day with the consumption of the house, right? Basically, mismatching between source and load. During daytime, where the house is not really demanding energy, the solar panel is actually producing highest, right? So there's a mismatch there. Whereas at night, no more sunlight, so solar panel is not going to produce any, but then the house will demand energy, another mismatch. So in order to kind of match the two, not really matching, but in order to be able to interface the two, connect the two, what can we do in order to be able to absorb, now store basically, right? Store the excess energy during daytime so that at night we can deliver that energy back to the house so that motivates, the use of energy storage right here. And as we all know, energy storage is also DC operated, right? They're not AC, but they're DC. All right. Now, so many reasons, as I've already presented to you, about why I believe DC will be a good strategy. Now, what about proposed solution? As I said at the beginning, this topic actually I started in 2010. I started as a DC house project. I'll show you a picture later on. That's a project that was um, um, that aims for improving access to electricity for rural areas. In fact, I had actually visited Philippines Technological Institute of the Philippines in 2015. I worked with faculty and staff there back in December 2015 to build a prototype or a demo DC house on their campus. But then as time progresses, anytime or every time I presented a DC house, there's always a question of can we implement the same technology for urban areas? Because the focus was more on the off the grid, right? Off the grid type of solution or rural electrification, but can we use the same technology for urban areas? So that got me thinking. And so I started looking into this problem and then proposed that, yes, we can actually still use the DC house, but now since we are dealing with urban areas, where typically a house will be connected to the grid, why not do something like hybrid AC-DC, some kind of a mix between AC and DC with a crisscrossing path between AC and DC, as you can see from this diagram, right? So let's say this is AC grid right there, right? And then there's the solar panels. Let's just say use one DC source. And inside the house, you see there are two buses, right? AC and DC. And between those two buses, you have the AC loads and DC loads. So if we have power from the utility, then we can supply energy to AC loads straight, direct connection. If there are DC loads and there are sunlight outside, we can also power the DC load straight from the rooftop solar panels. What if one of them is not there? For example, let's say you have a blackout, so AC grid is no longer there, but yet AC load is still asking for energy. Then you can actually power the AC loads through this crisscrossing path right there, right, from DC to AC. And likewise, if let's say during nighttime, no more sunlight, you could still power DC loads from the AC portion of the grid connection, as well as from the battery, right there. And then the box inside this house, which is the DC service panel, this is actually the technology that we developed at Cal Poly to enable us to use DC connection in the house using MISO converter. MISO stands for multiple input, single out. I'll talk more about it later. So yeah, these are basically the simplified diagram of hybrid AC-DC. And what you're looking at is a demo house, if you will, a demo house that we have at Cal Poly that incorporates those two systems. So we have the DC coming out of the solar panels, and then AC coming from the wall, from outside actually. So there's some AC-DC line in this small house. So it's still in progress. This is the latest setup we have. Now we're going to add more features to this house, make it smarter, make it more efficient, what have you. And yeah, we're very excited to proceed with this demo house on our campus. All right, so then I propose a solution. What will be the challenges, right, of doing that? To me, challenges present opportunities for new technological developments, which further on bring in innovations, right? So it's actually good to have challenges. In fact, I received so many ideas, like new ideas, while doing this project. You know, so many things that turn out to be, hey, nobody has developed this yet, and it's our chance. It's our chance to advance opportunity to advance the technology, right, on DC. Not many people actually are looking into this yet, but I'm pretty sure more and more people will be, interested in developing the DC technology. Anyhow, several of the challenges would be limited DC sources, and so maximizing the use of renewable energy source. As I mentioned earlier, nowadays we just have solar panels. Why can't we have the other ones, like wind energy, right? What else is there? Water stream, if there's water stream close by, and so on and so forth. Right? And this is especially important where if the house itself is kind of far from the city, right? Making other renewable energy sources adaptable, that's another challenge. And the MISO converter that I mentioned earlier needs further development for commercialization, something that unfortunately is not my forte. I know the technical side of it, but when it comes to how do you actually, what's next, right? What do you do next? How do you introduce this technology into the market and stuff like that? So something that I would need help from many other people, non-engineering people. DC bus and loads are not standardized, unlike AC, right? I don't know in Philippines, what frequency is it, 50 hertz or 60 hertz? I don't recall. But it's also standardized in terms of the voltage, right? Maybe 220 volts AC RMS, right? But in the US, it's 120 volt RMS. So, but the point is they are standardized, right? And for DC, still open. DC is still open. We don't know yet. We don't know yet what voltage should we choose for DC bus, right? So, so still open, and to me that's actually great, because then it would provide opportunities for us to do studies and be at the forefront of the technology. Another challenge would be that DC is more difficult to protect from faults. Reason being, DC is always flat, right? Always high, whereas AC follows sine wave. So at any certain time, the sine wave will have to cross zero. So it's easier to protect AC system than DC. But again, this is actually a good challenge. Doesn't mean that we cannot solve it. There's always some solution to these problems here, but we need to look at the trade-offs, of course. But something that I developed, that I learned from doing this project is to be able to design and construct a good protection system for DC. All right, and then EMS is another challenge. It will be nice to be able to somehow incorporate all of these components in the hybrid AC-DC house. They can talk to each other. That way they know if AC is on, who's going to provide the energy, when the grid is on, whether or not we want to use the battery instead of the AC, right? So that would reduce the cost, and so on and so forth, right? So that's, I believe, going to be a important part of the hybrid AC-DC system. Now, I mentioned earlier about solar panels, right? And currently, solar panels will be the main sources for this DC system. How about the other ones? Right? For example, wind energy. The problem with wind energy is that we have this term called NIMBY, right there on the top left corner. So NIMBY stands for not in my backyard. If you want to do a wind turbine like this, you can see that the wind's going to be relatively big, right? And that would look ugly, right? And aesthetically not pleasing. So not many people like it because of the it's unpleasant to see. It's noisy, right? And maybe can kill birds when it's flying by or things like that. So that's what I meant by adaptability. How can we use a different type of renewable energy sources to provide the DC energy into the DC bus? So a couple of examples that I provided here shows creative ideas on how to use wind energy instead of using big blades like there. Here you see the structure right there, right, with bridges, right, with kind of like a what do you call it, like a ventilation kind of type of a structure. So when the wind blows, it will go in, it will enter those openings, and inside there's actually a generator that would spin, right, and complement the energy from the solar panel. Excuse me. And then, so that's it's already uh, being looked at by this company. It's called Rich Blade. You can Google it if you like. And then there's another creative way of somehow utilizing or not utilizing, capturing, wind energy into a house by using a wind power wall. So right there is a wall that consists of little spinning, structures. Right, so the wind blows, those spinning blades, small blades, will turn, and in the process will generate energy. So it's going to be much less, or I should say, it would be more acceptable, right, than having big wind turbine in the backyard. So I'm sure there are more creative ideas in order to be able to adopt renewable energy. These are just a couple of examples that I've already found while I'm doing the research. And in terms of generation technologies, um, things that we develop at Cal Poly is what we call small scale renewable energy generators. Right. Back in 2010, I had this idea of having a small hydro power generator that you can carry around, and then if you see a water stream, you can just dip it, right, and then it'll create enough energy to for example, charge a battery or something like that. But unfortunately, I was not. I didn't know enough about mechanical systems, so somebody in Europe already did this. You can actually go to this website, waterlilyturbine.com, and their product can actually generate 25 watts. So small, but if you can somehow use multiple of these, then small becomes bigger, right? And then how do you keep the generator for the house, for example, the one that's sitting on top right here, right on top of the ridge right here, inside the ridge right there? How do you keep it less costly? One of the things that we can do is to convert from from cars, used car alternators into a low speed type of a machine, right? So we tried that at Cal Poly, but we um, have not done it for some time now. We were able to actually bring it down to 700 RPM, which is still high. Right? If you can somehow bring it down to about 100 RPM or even less, that'd be awesome. All right, and then what I call, play park generators. This is not my idea. Somebody's done it before, and I think we need to bring back these ideas. Is to have, for example, a swing that can generate energy, seesaw, as well as merry-go-round. They're not big source of energy, but if they can complement existing solar panels, why not, right? Especially with kids, has a lot of energy. They can play at the same time. You can get energy from them out of their playing into electricity. All right. This is the EMS I was talking about. Basically creating a way to coordinate controls, right? Different components in the hybrid AC/DC house. I won't go through this in detail, but you get the idea, right? Every single one of the components um, should be talking to each other, so we know where, when, how, to use the energy, right, inside the hybrid AC/DC house. So this is something that I have not got a chance to develop. I welcome, of course, any of you to look into it if you're interested. Here's the MISO, multiple input, single output. It it sounds easy, right, to do this, but it's actually not. The purpose of this is to be able to um, combine multiple sources into a single DC bus, right, in a most efficient manner. Anyhow, long story short, we were able to find a solution, a very good solution back in 2018, I believe, and then we filed a patent, and we got the patent right there. right? Yeah. The unstandardized DC. So imagine this picture right here on the lower left, right? You have a DC wall plug right there, but then your DC coming out of the wall plug is going to be a fixed DC. Let's say 48 volts, but then your loads, it could be any other DC voltage, right? It could be 12 volts, could be 5 volts, it could be 24, it could be any DC volts, right? So then how do you how can you, right, power different DC loads, DC load voltages coming out of a single DC level voltage, right? So again, this is kind of a challenging problem, but it's actually fun. So what we found out is that, yeah, we can actually do a smart DC wall plug, right? So you have 48 volts coming in, and then if you plug in any DC load, whatever it is, let's say the DC load is requiring 12 volts, then the DC wall plug will be able to detect that voltage and supply the right voltage to that DC loads. So that's what I call a smart DC wall plug right there. And we have several versions of the smart wall plug. Of course, this is a big version of the PCB of the smart wall plug, not optimized, and so that's why it looks big. But in the future, it should be tiny, that it would be able to fit behind, you know, this DC wall plug. All right. And nowadays we also have USB-C PD, which is power delivery. So we also look into this. USB-C is capable to actually do the same kind of thing, you know, detection of voltage, step the voltage through certain levels until it finds the right voltage for the output. So that's another solution that you can look into as well. And another thing that we found out about challenges of using DC is how we can protect them. As I said earlier, when you have DC current, you know, DC current is always high, right? So when do you actually interrupt the energy? It's going to be hard, right? And so this is where solid state technology can come in, right, and help us with the solution of solid state DC breaker or fuse, or even arc fault current. So arc fault current is another beast right here, because what happens is that if, let's say, you have two wires sitting next to each other, if it's an AC wire, then if there's a jump of electricity from one wire to another wire, then the time domain waveform of the current can actually be used to detect this arc fault interrupter. So relatively easier. Whereas for DC, if you have arc fault current between one wire to another wire, it turns out to be the time domain waveform of the DC doesn't look, it's not changing at all. It doesn't look like there's any fault at all. So that's dangerous, because then you won't be able to protect, right, your house if there is any arc fault current, if you are relying on a time domain solution. So what we did was, what if we look at frequency domain? And sure enough, when we look at frequency domain, we can clearly see the shifting of the frequency spectrum when there is a change in the current due to the arc fault. Very interesting, topic. So that's the picture here at the bottom. That's the DC arc fault interrupter that we developed at Capoli. On the right, that's the circuit breaker for DC. All right. Those are opportunities and challenges. Excuse me. And then I'd like to talk more about opportunities here, because I think that would be part of the exciting thing about this research, right? What kind of opportunities can we get from doing this research? Well, number one, I know, I'm from Indonesia, and I know that in many villages in Indonesia, we have, cluster houses like this in many villages, right? These are off the grid, and I'm sure in the Philippines, same way. Many islands, and they're isolated, and you can see like this whole clan has, houses right close to each other. So to me, this is a perfect setting for DC house, right? perfect setting for DC, not only DC house, but also network DC house. And you can also do hybrid, doesn't matter, right? You can do either DC, purely DC, or hybrid AC DC. So this is what I'm talking about. So if you have cluster of houses, then you could network, right? Network houses, DC houses toward higher AC or DC bus locally, right? Just that local network, not connected to outside. So this is something that we have not actually looked into yet. Feel free to look into it, or if you want to start researching this area, I'll be more than happy to to answer any questions you have. Now, another opportunity is to improve rural applications, right, with hybrid AC/DC or just DC house. And I'm not talking bad about the current solution, right? This in which, as you know, when it comes to renewable energy for rural electrifications, we have, for example, hydropower. We have solar farm, right? We have what else? Centralized renewable energy sources, right? Such as this, for example, on the left. So you have a big hydropower, and it's connected to a power station, and then it's connected to network of the houses, right, in that village, right? And as I said, this works very well, but it I'm saying is that one size does not fit all, right? The one on the left might be a great solution if, for example, the village has is located at nearby big river. But what if there's no big rivers, right? What can we do, right? So why not, for example, do something like this, right? So you have the power station still, then you have the smaller sources. You can combine them, and then each of the houses is its own DC house or AC/DC house, independent from the other, right? Rather than the one on the left, right? So you see the difference between the two. The one on the left is centralized. The one on the right is distributed type of setting, right? So if, let's say on the left side, with our existing system, if the hydropower is done or gone, then of course the entire village is black out, right? If the power station is down, and all the houses will be blacked out as well. So you see the less reliability of the system has, right? If the bus from the power station is down to those network, again, all of these houses are done, right? If the bus on the top right there is out, then houses on the top line will be blacked out. So that's kind of what you are getting with existing system, as opposed to, for example, the one that I'm proposing right here. So even without the source to be working. So I notice I got rid of the source, right? So now we have a hybrid AC/DC or hybrid DC, hybrid AC/DC or just DC house, and every single one can actually generate their own power, right? Assuming enough power, then what you have is this, right? And then if, let's say, the top left solar panel is out, then the house would still have energy from the neighboring houses, right? If that bus is out, then the house on top left would still be having electricity because it has solar panel. Right? If that bus is out, then the top houses still are good, right? And so on and so forth. You get the idea, right? So improve reliability of the electrical system for rural electrification. All right. Another opportunity that we can get out of this research would be our chance to do everything, is DC appliances, right? Now there's more and more companies trying to develop, design, and market, DC products. For example, DC freezer, DC air conditioning, right? DC, what else? Storage, the cooler, DC cooler, DC TV, right? You name it. So there's the opportunity, right, for us to be able to what do you call it? Promote the use of DC by helping the industry create all of these DC, everything's DC appliances. Right. These are the DC house prototypes that I've done the past 10 years. The one on the left, right there, that's the DC house on campus at Cal Poly. And the one in the middle, that's the one in Indonesia. And this is where I went to the Philippines, as I said earlier, 2015. Beautiful, traditional house made of bamboo, as you can see. This is on the TIP campus, right? And yeah, this is basically a living lab. That's what they have right now, living lab to demo and for students and staff to continue research on DC house or DC electricity in general. Right. So I welcome you, any of you, if you're interested in working with me on developing a prototype or different aspects of DC house or hybrid AC/DC, please feel free to contact. All right, I'm almost done. As a summary, I would say let's collaborate on hybridizing. That's a tough one to say. Hybridizing electrical systems. The need to explore DC to complement the conventional AC residential electrical system. Right, that's what we've been talking about earlier. And to me, the reason why for urban areas we need to do hybrid AC/DC because I don't think AC will go away. I think AC is going to stay. Right, so the best is to complement AC with DC. And at the same time, by doing so, we actually promote and leverage the use of renewable energy. And maximizing system efficiency when DC loads are continuously growing. That's another challenge that we have. And hopefully by doing so, by going into this research, we can help achieve future sustainable house, right? Net zero energy houses, as I explained toward the beginning or at the beginning of the presentation. And this bullet right here, DC has technical challenges. I'm not gonna lie, there's a lot of challenges. But as I said, challenges present opportunities for new solutions and innovations, and in fact, business opportunities perhaps. And so, yeah, I'll definitely continue, right, looking into this hybrid AC/DC solution to improve access to electricity in rural areas, as well as for the future house. But we need to move fast. And we need to move fast to be the leader in this new field. And as I said, there's a lot to explore from different aspects of the project. It could be technological, economic, environmental, social, etc. References. And with that, I conclude my presentations. If you have any questions, feel free to ask. And that's the DC House website if you'd like to look at what we've done. And that's my contact info as well on the screen. Thank you so much for your time, for listening to my presentation. And again, I really appreciate the time given to me to share my research. Thank you.
All right. Thank you very much. Sorry, hold on. Thank you very much, Professor Tofik, for this wonderful topic on hybrid AC/DC house. I never knew that there is a great opportunity for rural areas if residents convert their houses to hybrid AC/DC setup. It's good, and it is best to complement AC with DC power for residential applications. Thank you very much for the topic. It's for the insights and everything, Professor. And thank you very much. At this moment, we will now have the question and answer forum. You may now write your questions on the chat box. If you have questions, I do believe there are posted questions on the chat box. We will be flashing it to you in a short moment. Again, a round of virtual applause for Professor Taufik.
Thank you.
Partner Alvin, can you see my screen now? So we have the first question here.
Yes, yes, Sec Tony. I can see the question. Shall I read it? For question number one, still not
Yes,
an
please.
expert. Thank you, thank you. So for question number one, still not an expert in solar energy here, but I'm curious, due to elimination of DC cabling, do you think the hybrid AC-DC solution is still applicable on solar arrays with modular inverters, or is it better to just use string or central inverters? Professor?
Yeah, so this question relates to kind of like a higher level of power. Uh, um, if you talk about it's a, somewhere solar arrays, there you go. Solar arrays. If let's say this is a residential level type of solar arrays, then I would say, as I presented earlier, let's eliminate the AC cabling, not the DC cabling, but the AC cables. Right, so stick with the DC coming out of the solar panels. That way you don't need inverters. Right, that would be the proposed solution that I'm suggesting. Right? Now, if you still would like to use AC for the solar panels, that's fine, right? But then it's not going to be optimized. And in terms of whether or not you want to use modular versus, string centralized inverters, I think that will be depending on, what kind of configurations you have, power level you have, right? Um, is there like cost associated or budget associated with the solution? Because it's, as I said earlier, one solution does not fit all. So it's really a question that tricky to answer. I would say it depends on power level, depends on location of the solars, for example, like solar arrays. There's so many factors that can um, impact the decision on whether or not you want to use centralized versus distributed, inverters. But again, I'm not proposing this. I'm proposing all DC. So no inverters, basically. We have solar arrays. Yeah. I hope that
Thank you.
answers.
Uh, yes, thank you very much, Professor, for your answer. Is there a question number two, Sec Tony, partner?
Hello, partner. So I think there's
I
no
do.
more questions for the presentation.
I see. Okay. All right. All right. So, I think there's no question going once,
Maybe,
going
partner, you
twice.
just read the chats on the comment section.
Yes, yes, on the comment section. Yes. I see here one question. Hold on. I've seen this question a while ago. Here's the question. Can I read this on the chat box, Sec Tony?
Yes, partner, go ahead.
Okay. So this question is from Sir Jojo Legasto. What is the voltage of the proposed DC bus for
Mm.
the small house?
Yeah, that's a very good question. So when we started the project back in 2010, that was one of the first things that we wanted to look into, is that what DC level of the voltage on the DC bus that will be the most optimum. right? May not be the most cost efficient, but it's the most optimal in terms of efficiency, in terms of the amount of copper, sort of. So it's not minimizing, but it's optimizing. Now, I had two groups, independent groups back then. They don't work with each other, so they work independently from each other. And the interesting thing is that at the end, they both came up with the same conclusion, is that for residential level, uh, voltage 48 will be the best. Right? 48 will be the best in terms of many factors, like number of energy storages, uh, as I said earlier, efficiency with the different loadings and things like that. So there's actually a report that you can download to look into these studies if you like. Right? These are free to download if you're interested. But that's the voltage that we are using. 48. Now there's a caveat, right? Nowadays, at least in the US, I'm not sure what's going on in the Philippines. Excuse me. In the US, anything below 52 does not have to follow standards. Anything of 52 and above, now they have to follow standards when installing the equipment. So knowing that 48 is kind of close to 52, right? So now we have running into another problem. Based on our studies, 48 is the best, right? It's the most optimal. But then if we pick 48, then it gets too close to the standard, to the regulations, basically, right? What if the voltage fluctuates, it goes into 52, then now we have to deal with all of these regulations. So at this point, it's still a toss, but I would say it seems like industry has converged as well to 48. There is an alliance, I believe it's called Emerge Alliance, organizations that really look into DC. And what I've seen is that they're also looking at 48 volts DC. Now, I don't know if this is a coincidence or not, but future electric vehicles, the DC inside, EV cars would be 48. It's no longer 12. It's going to be 48. So that tells me that we did something right back in 2010. I think 48 would still be the best choice, but I can only hope. But that's kind of a long answer to your question. Okay, but feel free to choose any other voltages, right? Again, you have to do study, right? Do studies based on the size of the house, based on how much power the house demands, how much solar panels. Then you could maybe choose something lower than 48, right? Maybe 24, maybe 36, but I doubt it's going to be 12. 12 is going to be too low, such that you have a lot of current flowing through the wires and you got losses. Anyhow, long answer. Sorry.
No worries, Prof. It's good to hear that there's for the answer 48 volts seem to be appropriate for general applications in DC power systems. Now, thank you very much for that answer, Professor. Another question is given to us by Engineer Sammy Mabanta. Hi, Doc Tofik. I am involved in the DC House in TIP, Technological Institute of the Philippines. What we see as a way to improve then is that it is limited to appliances at 12 volts input for the
Yes.
lights, ref, fan. The idea of a USB-C type of an interface should be a great step to address that issue. However, I think USB-C would be limited in power, so on being max at 24 watts. Should a standard be used for the DC house idea? Is there a push to work on the other issue? In the addition of the storage battery, this had to work in bidirectional so that it can be charged by the renewable sources and discharged through the MISO output. Is your current setup using this approach? Sorry for the follow-up questions, but I think those questions are related.
Yeah,
Professor.
yeah. These are very good questions, and I'm glad that TIP is still doing this. It still has that beautiful DC house that we put together back in 2015. Hopefully, after maybe sooner rather than later, I get to visit Philippines again and visit TIP. It has been a while. 2015 is like that's 8 years ago. That was a long time ago when I visited TIP. But I would love to go back and see what's going on there. But yeah, 12 volts. That's what they chose, I believe, back then. And I said to them, it's really up to you. If, the reason I believe they chose 12 was because the loads are mostly 12, right? But again, there is a trade-off there, right? If you are uh, delivering power, DC power from your source into your loads, like on the walls, with 12 volts, imagine the current that flows through the cables, right? So there's a trade-off. On one hand, you don't really need like a point of load, converters at the wall plug to change from 12 to 12, right? Because it's already 12. But on the other hand, the trade-off would be that you're gonna have, a lot of losses in the house through the cables. So my preference is higher voltage, higher than 12, and that is also aligned with USB-C, right? The key is that USB-C can actually deliver higher power because of what? Because of higher voltage, right? So the regular USB delivers 5 volts, right? But USB-C is going to be around 19 to 20 volts, right? So that's closer to 24, right? Voltage. So I would say maybe 24 would be the better choice in the future. I don't know. I have not done studies, but and 240 watts, that's a lot, right, for USB-C. So imagine you have in your house on the wall, you have USB plugs instead of wall plug, instead of what you have now. Imagine you have that. And USB plug can power so many things in your house, right? And if let's say the DC load requires more than 240 watts, guess what? You can parallel those. You can parallel, the USB-C. That's another challenge that I have not looked into, but I just came up with that today or right now. Is that how do you parallel USB-C, right? If the load is requiring more than 240 watts, right? And keep in mind also that DC loads typically are designed based on power electronics, right? And one of the goals of power electronics is efficiency. So your DC loads most likely is going to be more powerful in the future. It's going to be more powerful, and then it's going to take less power. That's a good match, right? With 240 watts. Doesn't look that much, but it's actually going to be a lot in the future, right? And I don't know about Philippines, for example, in Indonesia, a really small house will have 600 watts limit, right? And probably going to be about the same in the Philippines. So that's easily can be handled by three of USBs, right? Roughly speaking, of course, right? So I think I believe that we have a good potential here with USB-C as well as with increasing the voltage up higher instead of 12 volts. Now, the second part of the questions, MISO. So in addition to the storage battery, you said it has to be bidirectional. So can be charged by okay through the MISO output. Is your current setup using this approach? So MISO is basically a box. Now think about a box. You have a box, and this box has inputs, right? Multiple inputs. And these multiple inputs can come from multiple DC sources, right? And one of them could be battery, right? And if you have a battery, then the connection to the solar panel will be outside of the MISO, not inside of the MISO. So imagine you have connection between solar panels and batteries. And battery has its own output, goes into a MISO input, and solar panel goes into another MISO input. So it's not bidirectional in the MISO, but it's bidirectional within the solar panels and the battery. So hopefully that answers your question.
Thank you very much for this, for the answer, Professor. I think we're through with the question and answer portion. Now let's move on with the next part of the webinar. Um, Moving on, Let me share my screen. Moving on, I would like to call upon the president, the national president of IECEP, uh, for for the opening remarks. Engineer Lyle Anthony Joel Villas, PECE, uh, to give his opening remarks for the event. Um, Engineer Lyle, press, over to you.
Yes, good morning. Good morning, Engineer Alvin. Sorry, ano, na-caught off guard yata ako. I was looking for the, hanapin ko lang yung, sorry, hanapin ko lang yung virtual background. Mabilis lang, nakita ko naman eh. Para lang bago ako mag-open ng...
Sorry.
Yeah, but aren't we supposed to award our speaker first?
We could
Yeah.
we could do that, press.
Yes, please. Oo, para awardan din ang ating speaker before I proceed with whatever I have to say, sir. Sige, thank you.
All right. So moving on, for the awarding of certificate of appreciation for our speaker, I would like to call upon Engineer Marichel Tioganco, the Vice Governor for Internal Affairs of IECEP Cavite. Engineer Marichel, over to you.
Thank you very much for the introduction. So sorry to say that I would not open my camera right now, but it is my honor to present to you the certificate of appreciation. Can I see the slide? Okay. So Institute of Electronics, wait a while. The Institute of Electronics Engineering of the Philippines Incorporated, Power Electronic Society, presents this certificate of appreciation to Professor Dr. Taufik in sincere acknowledgement with his invaluable contribution as a resource speaker for the third Colloquium on Power and Clean Energy with the topic Hybrid AC-DC House, Paving a Pathway for Future Sustainable Homes, given this 11th of February, 2023. Signed by the Governor of IECEP of Bulacan Chapter, Engineer Christian Enoval, the Governor of IECEP Mindoro Chapter, Engineer Gerald Toixon, and the Governor of IECEP KSA-ERC Chapter, Engineer Muhammad Ali Mauna, and Governor of IECEP Cavite Chapter, Dr. Jodelic Sarcilia, Governor of IECEP Manila, Engineer Teofilo Lorenzo Pompico III, and the Chairman of the IECEP Power Electronics Society, Engineer Mark Philip Fernandez. Let us all give Dr. Professor Taufik a round of applause. Thank you very much.
Thank you so much for the certificate. I really appreciate it.
All right. Thank you again. Thank you very much, Dr. Taufik, for giving us an insightful ideas about how to maximize the use of DC power systems in our homes. I hope that sooner or later it would be generally applied in our country. So in the near future. All right. So moving on. Hold on. sorry. Okay. Now moving on, we would like to give the greatest appreciation to our sponsors for this event. We are able to realize this colloquium through their help. Let me read the citation. Here you go. Institute of Electronics Engineers of the Philippines, Incorporated, Power Electronic Society, IECEP Incorporated Society Accreditation Number 2, Certificate of Appreciation. This certificate is hereby presented to Adamson University, represented by hello, excuse me.
Thank you very much to IE
Yes, hold on.
CEP for this appreciation.
Represented by
Richmond Yap po.
yes, sir.
Yes po.
I was lost in the connection. I was reading the citation and I thought it was. Can you hear me now?
Yes,
Can
sir. So yeah, yes, sir.
yes. Sorry for the gap. Adamson University represented by Mr. Richmond Yap. And in sincere acknowledgement with the company's invaluable contribution as a sponsor for the third Colloquium Power and Clean Energy, given this 11th February of 2023, signed Engineer Christian Enoval, Governor IECEP Bulacan Chapter, signed Gerald U. Tocson, Governor IECEP Mindoro Chapter, signed Engineer Muhammad Ali B. Mauna, Governor IECEP KSA-ERC Chapter, signed Dr. Jodelix M. Sarcilia, Governor IECEP Cavite Chapter, and signed Chofilo Lorenzo Conquinco III, Governor IECEP Manila, signed Engineer Mark Philip G. Fernandez, Chair IECEP Power Electronic Society. Sir Yap.
Thank you very much. Thank you very much to all the officers. And we are very much happy to be part of this activity and hope to see you soon, even face to face in Adamson.
Thank you very much, Sir Richmond.
Thank you.
Now, same certificate is hereby given to Philippine Space Agency for their invaluable support for this event. It is represented to be represented by Engineer MP.
Yes,
Engineer Chairman MP, over to you.
Yes, good morning again, Engineer Alvin. Yes, on behalf of the Philippine Space Agency, or PILSA, I'll be receiving the certificate of appreciation for the agency, for the aforementioned agency. Thank you, Engineer Alvin.
Thank you very much, Chairman MP. Now, sorry for the delay. The screen has been stopped. Hold on for a second. Press, Lyle, are you ready yet? For the opening, for the remarks?
Yes, I'm here, and Engineer Alvin.
All right. So hold on a second. I'll be for the opening remarks. It has been skipped a while ago. For our president is quite busy attending to some important meeting a while ago. So let me call upon again our IECEP National President, Engineer Lyle Anthony Joel Villas. Engineer, press, over to you.
Opo, magandang umaga and maraming salamat, Engineer Alvin. I think you are encountering some problems, no, on your connection. Or
yes, sorry for that.
is this also your first time hosting? I'm seeing some minor jitters lang naman. Hindi lang naman. But the most important thing is yung iyo tawag dito, yung smile, kumbaga, no? Kaya this is very pleasant morning for everyone. By the way, to the chair of the board of ECE, Chair Doc Alnar Detalya, and members of the board who are present ng board of ECE, members of the national board who are present as well, and society, the Power Electronic Society, headed by Society Chair Engineer MP Fernandez, and the rest of the society board, as well as the collaborating chapters. Hindi ko maisa-isa, baka may makalimutan ako. Dito pala sa sa taas, pero medyo malabo, hindi ko mabasa. So that is Bulacan, Cavite, ERC, Manila, and Mindoro, who have been a constant, I think, no, since this is a third installment na of the Colloquium ng Power Electronic Society. And syempre to the society members and the general membership of IECEP. Magandang umaga po sa inyong lahat. Magandang gabi o madaling araw doon sa mga kasamahan natin na nasa ibang bansa, most especially those in the Middle East. I don't know if there is someone joining us from Americas region. So, magandang araw din po sa inyo. So it is a pleasure for everyone for the Power Electronic Society. It's a pleasure for me to be here and to join you guys. This is the third installment already. Sabi ko nga, bibilangin nyo ba ito hanggang umabot ng chairman? Bibilangin nyo ba ito, MP, hanggang umabot ng 100 o 200? Because, diba, this is the third already, and Power Electronic Society has been accredited officially. That is last year lang ba? Limutan ko na. That is 2021 ba o 2022? But nevertheless, you have just been in operation officially for around 1 year or 1 year and a half. But the specialization initiatives have been there since second half ng 2020. And the society has come a long way. Marami na po, marami nang nagawa, marami pang ginagawa. In fact, I would like to commend the society most recently, for representing IECEP in particular and our profession doon po sa mga ginanap na hearings sa Congress, related to the KAAP incident. It was well publicized naman. It has been posted on our social media pages, dyan po sa social media page ng IECEP Power Electronic Society. And hindi naman din yun, it's a series of representations na ginawa ng IECEP Power Electronic Society. So with that, it is with our highest appreciation sa IECEP National po, napasalamatan po kayo for a job well done. I think you have very well represented the organization and the profession there. And it is part of the trust ng ating pong 2023 IECEP, that is to reach out to more of our external partners, stakeholders, and engagements rather. At ganun din po ang panawagan namin to each and every member here. That is to go beyond marketing our ECE profession and professionals themselves. If you could see yung mga initiatives namin for the past month dito sa IECEP po, sa national, yun po ang focus namin ngayon. Alam po natin tayo magkakilala na rito, Tayong mga members, we know each other. Alam natin kung ano ang ECE profession, alam natin kung anong mga specialization natin, alam natin kung anong mga dapat nating gawin, but we need to extend outside. Doon po sa mga industries na hindi nakakilala sa atin, or probably hindi tayo lubusang alam kung ano po ang dapat na ginagawa, ano ang role ni ECE sa atin pong community, sa nation po natin ngayon. So yun po ang yun ang ginawa ng Power Electronics Society. At para sa akin po, let's give yourselves a big round of applause, and ganun din po, no, ating mga members. Salamatan natin, and that is the purpose of the societies, no? One of the purpose of the societies. Of course, ang pinaka main purpose nila, kaya nabuo po yan, ulitin ko, no? Because on the directive sa PRC and yung direction na pinapatunguhan po natin is the Career Progression and Specialization Program, which has been initiated way back 2013, 2014, 2015. Yung realization for it to be operationalized, yun po ang tulong ng mga societies ngayon. Later on, ang main objective talaga nila is to be able to help produce the first batch ng mga specialists po natin pagdating po in particular dito sa power electronics. Okay? But other than that, syempre, as a society, they also have their own functions and responsibilities to perform, one of which is be able to represent IECEP, no, as a specialized group. Before kasi pag may mga hearings tayo, representations na kailangan, ang nangyayari po is medyo nagkakabiglaan, no? Naghahanap pa tayo, sino yung mga specialista rito, sino yung mga pwedeng mag-represent sa atin. With the societies here, almost coming into fully operational status, no? Lahat po ng societies. Of course, we only have around half the moment, but inintay pa yung accreditation ng iba, but hopefully, the other half will be in operation ngayong pong taon na ito. So, yun ang main function of society. So, that for the 234 who are here, whether you are a beginner or you are already a practitioner or in the intermediate level, going towards the advanced level ng specialization po na ito, you are very lucky to be here. And yeah, with this colloquium, in fact, sabi ko nga, this is the third installment already. Only IECEP Power Electronics Society is offering this one on the Philippine setting. Ito pong initiative na ito. At magaganda yung mga topic. Very, very much in line with what is really needed for this specialization. So I commend the Power Electronics Society for that. And please do so continue doing such things. Kasi kailangan po kayo ng ating profession. So much for that. I would like to invite everyone later on for the inaugural episode of IECEP Kausap. IECEP Kausap is basically a talk show natin, a virtual talk show that is meant to reach out to the members, no, and discuss everything about yung mga current events, services, any news related to the profession. And the first episode will be tonight. That is from 7 o'clock to 8:30 p.m. It will be broadcasted live via Facebook, our IECEP National Facebook page. Wala naman pong kailangan na Zoom or anything. It will be broadcasted live there. You could input whatever your questions related would be. Doon po, no? And this will be on a monthly theme, no, for 2023. If you remember, yung IECEP Kausap po na segment was instituted first nung ating EAGM 2020, if I'm not mistaken, no? So, lagi po yung ginawa, dinagdag na yearly from there on, but only during AGM. With the same purpose, we talk about all of everything that we could discuss related to the organization and the profession. So for a change this time, dahil alam namin, marami tayong kailangan pag-usapan, marami kaming kailangan sa inyo, no? I-reach out sa inyo, no? Sabihin sa inyo, iparating sa inyo. Hence, we are doing it on a monthly basis. Kaya po ganyan. And yours truly will be gracing the episode later on as the first guest. I will be relaying there the organizational agenda of IECEP for 2023 as well as yung direction and vision. Hindi ko na dito i-hijack kasi alam ko mahaba pa ang oras na kailangan gugulin para dito sa event na ito. If I'm not mistaken, wag lang kayong Baka nga umabot pa sa IECEP kausap na, but I hope the colloquium will be done on or before 7 p.m. So I'll see you there later on. And also, lastly, let me take this opportunity to invite everyone for our annual mid-year conference that will be happening on Puerto Princesa, Palawan. That is on June 1 3. All of the details are already available, posted on our website and social media pages. In particular, yung lahat po ng updates dun sa IECEP AGM 2022 ng na FB page at may parenthesis na nakalagay na national events. The reason behind this, hindi pa namin ma-change yung name ng FB page kasi may restriction na nangyari dahil pinapalit-palitan yung pangalan. But you could see it here. It is you could see it there rather. Naka-share naman po iyon sa IECEP National FB page din. Or you could check our national website, icepnational.com for that. We hope to see you there in Palawan. That is on June 1 to 3. To do it either the usual, face to face. Of course, there's a lot in store for there, nagagawin po natin doon. Something new for the year, and as well as you could also join us online. Andun pa rin naman po yung hybrid setup natin. And for a great change, yung mga gusto mag-online, the rates are significantly down, lower doon sa mga nakasanayan natin. So we hope to have a good audience for this year, a better audience for this year para po sa atin pong mid-year convention. That would be on Puerto Princesa City in Palawan, June 1 to 3. Also, sabay ko na rin pero wala pa itong mga poster na naigawa, pero take this opportunity as well for you to invite everyone to the first leg of the IECEP International Conference this year. The first leg would be happening on Singapore. That would be on March 24, if I'm not mistaken. It's either 24 or 25. Might jumble the dates, pero mga ganun po, So if you happen to be on Singapore, kung sakasakali lang nandun kayo, you might as well join us face-to-face, but it will be offered as well in hybrid setup. Okay? So the first leg of the international conference po ni IECEP, mangyayari po on Singapore this March. So yun po yung sinasabi ko. Ang IECEP po ngayon for this year, mag-iingay po tayo lalo. We will banner the profession, we'll continue bannering the brand, the name of the institute of IECEP. That's why expect a lot more of activities na mangyayari po dyan. Consequently, meron din po tayong magkakaroon ng inaugural Leaders Summit. The IECEP Leaders Summit will be on February 25. This is actually by invitation, but I'm sharing this to you because it will be attended by leaders ng IECEP, Board of Electronics Engineering, the incumbent chapter governors, the society chairs themselves, so si Chair MP Fernandez would surely be there, and then the committee chairs, national, and the former presidents, all of the former living presidents will be there. So there will be something at the Leaders Summit. So basically crafting and meeting of the minds para po sa ating IECEP, not only for this year, and for the years to come. Okay? So, and huling-huli na po, na advertisement dahil dun po ako nanggaling kanina, and I apologize if I was not able to join yung pinaka-main program ko, the opening salvo for this event, because we had a special board meeting sa national po, ngayon po umaga, and I think I could actually pronounce it na ngayon, that there will the national convention for this year, our annual general membership and convention 2023 will be held here in Manila. That will be at Novotel Hotel, and that would be on November. Sorry, tingnan ko lang, mabilis natin. Magkamali ako. That will be on November 23 to 25. So that's Thursday to Saturday. Okay, it will still be in a hybrid setup. Ganun pa rin naman po tayo. But for a change, we are going to a venue that is at the heart and center of NCR. Medyo mas maganda yung magiging accessibility ng everyone. Now we hear you, we hear the comments from the last AGM po na ginawa natin. We are very grateful syempre for PICC, no. Yung grandiose ni PICC would still be there, but we have to hear our members. Now hence we're moving towards the center of the capital, no. Diyan po tayo sa Araneta Center, Cubao, and I hope as early as now, no, could book your seats for there as once na nilabas po natin yung official invitations and registration for that. And syempre kung meron din po mga gusto mag-participate as an institutional member, as an institutional partner, as a sponsor for that. So we are aiming for it to be one of our biggest AGMs in most recent memory. So we hope to see you there. So again, that is November 23 to 25. That's a final date na po. That will be on Cubao Novotel in Quezon City. Okay, so maraming salamat po and congratulations again. IECEP Power Electronics Society and all of the collaborating chapters here, Bulacan, Cavite, KSA-ERC, Manila, and Mindoro. Hindi ko pala nabanggit ang IECEP Manila kanina. Patawad po, sabi ko nga medyo malabo na yung screens. No? And please continue serving the general membership and spreading the news on your, in particular, your specialization. Mabuhay po kayo, Power Electronics Society and the collaborating chapters. Have a pleasant good morning po. Engineer Alvin.
Yes, thank you very much, Pres Lyle, for the wonderful information and insights that you have given to us today. As expected, every engineers are enjoying to join the IECEP Ka-USAP, the mid-year convention and the national convention. Partner, you still there? Sekoni? I think yes.
Yes, hello partner, I'm still here.
Yes. Okay, that's good to hear. So,
So everyone, for the next part of our program, we'll have 5-minute break. So please do take a short break and then be back in 5 minutes. Thank you.
Thank you.
Do you know where you're going? Do you know where the road you're taking will lead? Your future depends on what you're doing right now. You wonder if you made the right choice. If your choices lead you to your dreams or nightmares. If your choices led you to Adamson University, then they have led you to a better future that begins with an amazing present. In AdU, we believe in solidarity. We are drawn together by a shared vision and mission. Here, our community is a family. Here, education is a shared responsibility where participation, teamwork, interdependence, communication, and dialogue is customary. In AdU, we inculcate social responsibility, the mark of an authentic Catholic faith. We are dedicated to your sustained integral development. We are committed to provide you with programs, facilities, services, and an education that guarantees your holistic development and continuous beneficial learning. We hold sacred the spirit of St. Vincent de Paul. His love for learning and love for the poor permeates our community. And finally, key to an Adamsonian education is the search for excellence. We continue to hold the highest standards of academic excellence and professionalism in service. This is the hallmark of our educative endeavors. Welcome to Adamson University. Here, your dreams for a brighter tomorrow will start coming true.
Maraming pangarap ang umusbong mula sa mga simpleng tanong. Mga tanong na humantong sa pagtuklas, inspirasyon, at paglalakbay. Matagal na nating tinutuklas ang kalawakan. Marami na rin tayong natuklasan dahil sa pagmamasid mula sa kalawakan. Ano na ba ang lagay ng panahon? Saan at kailan kaya tatama ang bagyo? Ano na ba ang kalidad ng hangin na ating nilalanghap? Pero mas malawak pa ang gabay na pwedeng manggaling sa kalawakan. Dahilan kaya tayo naglalagay ng infrastruktura at patuloy na kumukuha ng impormasyon sa ating planeta. Gabay tungo sa pangarap na makabangon at magkaroon ng mas maunlad na hinaharap katuwang ang agham at teknolohiyang pangkalawakan. Pangarap na abot tanaw na sa pangunguna ng Philippine Space Agency o PhilSA. Itinatag noong 2019, ang PhilSA ang magtataguyod ng mga programa para tiyakin ang payapang paggamit ng kalawakan upang pangalagaan ang pambansang seguridad at suportahan ang ating pag-unlad. Bantayan ang kalikasan at tiyakin na makakaiwas tayo sa peligro ng mga sakuna at nagbabagong klima. Paigtingin ang pagsasaliksik at paggawa ng mga bagong teknolohiya. Suportahan ang pagsibol ng mga bagong industriya at pagsigla ng ekonomiya. Palawakin pa ang edukasyon at kaalaman ng publiko tungkol sa kalawakan at makipagkaisa at makipagtulungan sa iba pang mga bansa. Tinatahak na ng Pilipinas ang landas tungo sa makabago, mas ligtas at mas masaganang buhay para sa mga Pilipino gamit ang agham at teknolohiyang pangkalawakan. Isang karangalan ang pagkakataong maging bahagi ng paglalakbay na ito. Isang karangalan na isulong at panatilihin ang matatag na pangkalawakang komunidad na magpapahalaga sa mga mithiin ng mga Pilipino sa buong mundo. Isang bansang masagana, nakakaangat at may kakayanan, katuwang ang payapang paggamit ng kalawakan.
And we're back.
Yes,
Do
partner,
you
we're back.
have great?
I hope that
Yes,
everyone
yes, partner. So now, yes, yes, Tony.
Go ahead, partner. Go ahead.
Okay. So I hope that everyone have their health breaks so far. Now moving on to the next part of this webinar. At this juncture, let's call Engineer Roel Demdam, trustee from IECEP Bulacan, to introduce our next speaker. Engineer Roel, over to you.
Okay, thank you, Engineer Alvin and Engineer Tony. Okay, hello everyone. Again, a blessed morning to each of us. All right, I'm very happy that we are growing more in knowledge as we conduct this third colloquium on power and clean energy. But now our next speaker for this day is a career scientist of the Department of Science and Technology, DOST, detailed at the Philippine Nuclear Research Institute, PNRI. She is the former head on the PNRI Nuclear Reactor Operations Section. Her current research activities also focus on characterization of neutron fields and nuclear reactor core configurations. She is the lead person implementing the project to re-establish the historical Philippine Research Reactor 1 as a subcritical assembly for training, education, and research. She is also the lead developer of a novel neutron spectrometry system that is used to characterize neutron fields in medical accelerators. She is a member of 3 subcommittees of the Nuclear Energy Program Interagency Committee, which is developing the nuclear power program in the Philippines. She obtained her doctoral degree, PhD physics degree, from Ateneo de Manila University and has extensive training in reactor physics and engineering, nuclear safety, security, and safeguards from international nuclear institutions. Without any further ado, let us all welcome Dr. Alvi A. Astronomo.
Thank you, Engineer Demdam. Thank you, IECEP, for the invitation and for the opportunity to share about nuclear energy in your organization. So it is my pleasure to be with you this morning, and I hope that I can impart to you some of the benefits that we can derive from nuclear energy. So for this presentation, this is the outline of my presentation. I hope that we will have a very good Q&A discussion later, and I hope that you can learn from this. So let me start by talking about the global status of nuclear power. So just this January, there are 423 operating nuclear power plants in the world, and that supplies 379 gigawatts of electricity. That corresponds to 10% share in world electricity, and to date, there are 56 nuclear power plants that are under construction. Now, this is a comparison of the world energy share by source. So what you can see here is that 10%, this is relatively constant throughout the past decade. So if you look at 2017 and 2020, you will see here that nuclear supplies about 4.2, and here nuclear supplies about 4.3. But this is the total energy, not just the electric consumption. But what you will notice in this in both these figures is that a majority of the energy source is still coming from fossil fuels. So there's oil, coal, and gas. And as we are familiar with climate change, these are the main carbon emitters or carbon source, which is directly correlated to the climate change that we are experiencing. And as I have mentioned, nuclear has a fairly constant share. The world's total electricity, this is the time trend from 1971 up to 2019, and you see the nuclear power here. If you will notice also, the hydro is relatively the clean energy, like hydro and wind, solar, and other renewable energies are also providing some supply. However, for the renewables, it only started to become significant in around 2000s. But for nuclear, the technology has been existing as since the 1970s. Now, what I would like to point out with this figure is that nuclear is not really competing with renewable sources. They're supposed to be complementary. Whether we like it or not, we will be using energy. I'm quite sure that even right now, you have more than one electronic device that is open, and all of those will involve electric consumption. And I don't know about you, but it has been known that if you try to check try to compare the net income of your family and compare that to the electric bill that you have. And according to data or according to statistics, the average Filipino family is paying around 10%. 10% of their income is going towards electric bill. Okay, so please check that, and that's really high compared to other countries in the world. So what we know is definitely we're going to use energy, but the question is, where are we going to get it? So the more diverse our energy sources are, the more secure we are. Kasi pag halimbawa masyado tayong dependent sa isang source lang, just like what happened if we're so dependent on oil, what happened in the oil and gas, what happened in the Ukraine crisis, we have seen how it affected us very much. And also, for example, kung coal naman, ang isa sa mga major suppliers ng coal ay Indonesia. So, syempre, kung ang Indonesia ay magbebenta ng coal, tapos merong demand from other countries, uunahin nila yung mas kayang magbayad kaysa sa atin. And being in a developing country, mas nagmamahal yung mga presyo sa atin. Okay? In terms of regional capacity, so what you will see here is that, again, the technology has been existing since the 1970s. In fact, the early versions or the early generation of nuclear power designs started as early as 1960. It's already commercially available. But the major players are North America, Western Europe, and it is only recently that Far East Asia is becoming also a major player. Okay. And as of this January, this is the relative distribution of nuclear power capacity by region. So again, it's still North America that is leading, followed by Western Europe. And for Far East Asia, we're third. We are part of this group. But what you see here, this darker shade of blue are those units, nuclear power plant units that are in operation, while the lighter shade of blue are those that are under construction. So what you will see here is that if the units in Far East Asia that are under construction will be completed, eventually Far East Asia will overtake both Western Europe and North America. Let's try to look at that per units. So this is the number of units. This is the number of countries. So there are around more than 30 countries that have nuclear power plants, and these are the regional distributions. And in terms of per country, so the US has the most number of nuclear power plants with 92, and they're constructing 2 additional units. The gray figure here represents those that are already shut down. That means that they have already reached their operating lifetime, the end of their operating lifetime. So the second is France, and that's followed by China. Now, what you will see here is that China actually has the most number of units that is under construction with 18 units. But just to share with you, I joined PNRI more than around 12 years ago. During that time, China is not even in the top 10. But as I have been presenting about nuclear energy and its potential impact in the world, I have seen China really accelerating in this list. So Japan used to be number 3, and after Fukushima, they had to shut down majority of their plants. But they have now upgraded their systems, and now 17 are operating, and with 2 still under construction. So you see the figures here, and these are readily accessible in the internet. If you're more interested, you just visit this IAEA website. So IAEA stands for International Atomic Energy Agency. These are the emerging nuclear countries. There are around 30 countries that are considering, planning, or starting nuclear power program. We belong in this figure. We are already starting a nuclear power program. To highlight, Belarus, Bangladesh, and Turkey, which have relatively comparable economic conditions with the Philippines, they are all constructing their first nuclear power plants. Another interesting thing is the case of the United Arab Emirates. As you well know, the United Arab Emirates is an oil-rich country. So why are they going nuclear? So the logic behind it is that oil is becoming more expensive. It's a source that will gradually decline. What they did is, instead of using their oil for their energy demand, what they did is they constructed 4 nuclear power plants, and they would rather sell their oil because they understand that nuclear is cheaper than oil. And they just connected their 3 nuclear power plant units every year since 2020. They have been they have started, or they commissioned their plants. So August 2020, September 2021, and most recently they connected their 3rd nuclear power plant just last October. And the remaining unit, the 4th unit, is still under construction. Now, why are countries choosing nuclear? One of the main things is because of the high energy density. Most of our power source relies on chemical reactions. No? So you just burn something, you produce heat, and you convert that heat into mechanical energy, and mechanical energy is converted into electricity. So basically, it's just a matter of changing your source of heat. But most of our source of energy are just burning. Either we burn gas, gasoline, coal, and in primitive times, we burn wood. But nuclear power plants have a different way of harnessing energy. What is involved in the nuclear power plant is the fission process. The fission process makes use of nuclear material like uranium-235. If you split that nucleus into 2 fragments, it releases energy that is 1,000,000 times greater than what you can get from chemical reactions like burning. So because of that, the energy density is very high. Also, this is the amount of energy that you can get per kilogram of fuel. So 1 kilogram of nuclear fuel will give you around 4 million megajoules of energy. Compare that to 1 kilogram of natural gas. You burn 1 kilo of natural gas, you get around 55 megajoules of energy. Okay, so you get the idea that is what we mean by the high energy density. Another way of comparing it, which is more illustrative, is by looking at this figure. 1 gram of uranium, the amount of energy that you can get from that, is equivalent to the amount of energy that you can get from 1,800 liters of oil, which is equivalent to the amount of energy that you can get from 3 tons of coal. Another reason why countries are choosing nuclear is because it is a reliable source of energy. One way of saying it is also secure. So if you want a power source, you don't want it to be intermittent. Na there are times na brown out ka, or there are times na available siya, or there are times na hindi siya available. We want it to be available 24/7, no? And this data is based on the US. So 2021 data ito, and I would think that they would have to have the most reliable source, reliable comparison, because they have the most number of nuclear power plants. And based on the track record of all their nuclear power plants, according to their Energy Information Administration, nuclear has the highest reliability in terms of capacity factor. So nuclear power is available 92.7% of the time. Geothermal is also a good source, but it has a relatively lower capacity factor. And what you can see here, we have a lot of promotions for renewables. They have very good advantages. They have low carbon emission. However, we also have to accept that they have limitations in terms of reliability. So solar, in particular, solar photovoltaic, even with the best batteries available, which is still a developing technology, it only has 24.6% capacity factor. Another reason, many people are saying that nuclear waste is a problem of nuclear. I beg to differ, because in terms of waste, if we have a small volume of fuel corresponding to the amount of energy we're getting, that means that the volume of waste is proportional. So this is just a comical way of representing it. But if this is the comparison of the volume of your fuel, we see that the amount of waste is equivalent to this compared to the volume of waste that will be produced by burning coal. Okay, and in terms of energy security, now nuclear power can contribute to energy security by providing a stable supply of fuel, regardless of the global energy landscape. Again, we saw a very important important impact of power distribution and energy distribution with what happened in the regions of Russia and Ukraine. What happened there really affected the whole world. Now, it has something to do with the availability of oil. It is very localized. Yung mga very good oil deposits and coal deposits, fossil fuel availability is very localized in certain regions of the world. That is not the case for uranium, which is the nuclear fuel. Uranium is a naturally occurring radioactive material. That means you can see it in soil. You can see it everywhere. It's just a matter of choosing a high-grade uranium that is usable for nuclear power plants. In fact, you can get uranium from seawater, and at PNRI we have a group that is doing some studies in harnessing uranium from seawater. Now, as I have mentioned, the power demand or the electricity and energy demand will just increase even with the implementation of the energy efficient act and the energy efficient policies. But so we still have a growing demand. Now, at the rate that we're going, oil, liquefied natural gas, and coal are depletable sources. And at the rate that we're going, the deposits of oil that we have will last just for the next 40 years. LNG for the next 65 years, coal for the next 155 years. While uranium can provide us energy for the next 230 years. And this is not even considering the possibility of reprocessing or recycling the fuel. Okay, and what you can see here is that the distribution of uranium mines, major uranium sources, it is well distributed around the world. So in case you have conflict somewhere in this region, then you can source out your fuel somewhere in Brazil, or you can source out your fuel somewhere in Australia. So there are more diverse sources, making the fuel source more secure. Another reason why countries are going nuclear. So majority of the countries, I think it's just not a minority now, a minority group now that is not considering the climate change that we are experiencing. And the Philippines is very susceptible with that. With the number of typhoons that we're experiencing, we see how the intensity and the frequency is really increasing, and that is directly attributable to climate change. And that is also climate change has already been correlated with the carbon emission. So the world is agreeing that something has to be done with the carbon emission activities of the world, and if there's no nuclear power, the world's total carbon emission would even increase by 10%. So you will see here in this figure that the three major energy source, the coal, petroleum, and LNG, which are burned, and even biomass also burned, they are emitting the most amount of carbon dioxide. Now, what you will see here is that nuclear has even lesser emission compared to solar power and wind power. And later I'll explain further why. So this makes nuclear a sustainable energy source because it is a green energy. It's not exactly renewable. Some groups says it's pseudo renewable because you can get it everywhere in the world, even in the seawater. But that is debatable. It's debatable whether it's renewable or not, but it is definitely a green energy. There's almost zero emission. There's zero emission in the plant itself, zero carbon emission. But the 10 gram here is coming from the manufacturer of the concrete, the fabrication of the fuel, and so on. So we have to remember that when accounting for the carbon emission, we look at the full footprint of the nuclear power plant or the power plant. So of course, solar power and wind power do not emit carbon dioxide in their plants. However, the production of the solar cells, the production of the wind turbines, and the concrete, the production of the concrete structures, those also require energy, which are based on these sources. So when we account for all the carbon footprint. Again, from the beginning of life to the end of life, nuclear will have even lower emissions. Another reason why countries are going nuclear because it is a mature technology. As I mentioned, the technology has existed as early as the 1960s, and there are generation 2 designs, and we have also what we call the innovative designs. At this point, I would also like to take the opportunity to differentiate between two kinds of generation 2 designs: the pressurized water reactor, which is the design of the Bataan nuclear power plant, and the boiling water reactor, which is the Fukushima nuclear power plant design. So one main difference is that the Bataan nuclear power plant has three independent loops circulating water systems. So you have the primary, the secondary, and the tertiary systems. While for the boiling water reactor design, which is the design of the Fukushima nuclear power plant, you only have this primary loop, which already includes the turbine and the condenser, and the circulating water system that is connected to the heat sink. Now, why am I comparing this? It's worth noting na madalas kasi tinatanong ng mga tao, yung nangyari ba sa Fukushima pwedeng mangyari sa BNPP? The short answer is no, because they have completely different designs. Okay, and of course there are other factors. The worst thing that can happen in a nuclear power plant is that the fuel could melt. It could melt if there are no protection strategies that are appropriately in place. But that is prevented by making sure that the heat is removed from the reactor core. So this generation 2 designs have hundreds of years combined operational experience. And for the innovative designs, the designs benefited from the experience obtained from generation 2 designs. So although we have very limited operational experience with innovative designs like small modular reactors, its features have safety improvements that were derived from these previous generations. So there are other designs. So parang ano lang din to, no? Parang makina ng kotse. There are diesel engine. Parang let's say you want to have a transport vehicle. You can choose whether you use a manual or automatic. You can choose between a diesel engine or a gasoline engine. In the same way, either of those, meron silang advantages and disadvantages, but they all have the same purpose of transporting you. Now, for nuclear power plants, the main purpose is to harness energy from the nuclear fuel, and there are also different technologies to do that. And here are the main technologies. So PWR is pressurized water reactor or light water reactor, boiling water reactor (BWR), LWGR, that's light water graphite moderated reactor, FBR or FR is a fast breeder reactor. HTGR is a high temperature gas cooled reactor, and PHWR is pressurized heavy water reactor. So here we see the load factors, and the load factor is an important parameter as well in determining the utilization rate of the energy provided or supplied by a particular power plant. And this is the figures here shows the amount of electricity supplied, the current supply of electricity from a particular power plant design. And here, this figure here provides the number of units that are operating. So there are 303 operating PWRs, 61 BWRs, and so on. And the last column here shows the figures of the total electricity that is generated from the moment that the design was made. So as you can see, in terms of operational experience, in terms of the number of units, the pressurized water reactor is more common. In terms of age distribution, so how old is our nuclear fleet? You can see here that the most number of units, this in terms of installed capacity, so 30 gigawatt electric is provided by power plants that are 36 years old. Okay, So ito yung distribution ng age. So majority are in the 31 to 40 years old. And with good management, nuclear power plants can last until 60 years. One of the nuclear power plants that I visited in Slovenia, it has been operating for almost 40 years now, and just recently its license is renewed to operate for another 20 years. Okay. Another reason why countries are going nuclear is because of the small footprint. So this is a comparison of the land use per square kilometer, square kilometer per gigawatt of electricity produced per year, and the materials used. I think this is a okay. So this is a comparison, and we see that nuclear has lesser material throughput compared to other sources. And this is another way of looking at the data. So the energy source with the most material throughput is solar PV. Again, this is weighted according to the power that it can supply. So a 1 gigawatt nuclear power plant, for example, for every terawatt hour that of electricity that is produced, this is the amount of energy or the amount of materials that you will need for the solar PV. So you see here that there's a part of cement, concrete, then glass, and the steel and other materials. For hydro, obviously, it's mostly concrete and some steel. For wind, concrete, steel, and other materials. For geothermal, you have this. And for nuclear, it's mostly concrete, steel, and other materials. So per unit electricity produced, nuclear has the least material throughput. And again, that is correlated to the amount of waste that will be produced. So I've shown you earlier, if nuclear has the least materials, then it also has the least waste in terms of volume, okay, per unit electricity produced. But and now what we see here is that solar PV has the most material throughput, and that will also translate to the waste projections. And this figure here is provided by the International Energy Agency, which covers the photovoltaic power systems program. And we are now here in this period here, and with the very aggressive renewable programs of different countries, they are projecting that from around 300 to 500 gigawatt supplied by solar power. Many countries are very aggressive in introducing nuclear from around 500 to around 4,500 gigawatt by 2050. And if we look at the corresponding volume of waste from around 500,000 million tons, that could increase to around 78 million tons of waste that can be produced from solar panels. So that is something that people has to think about. So it's good that we're promoting renewable, but we have to remember that all kinds of technologies has pros and cons, and there should be a complementary way of looking at the energy sources that we're considering. Another reason why countries are going nuclear is because of its competitive cost. Now, when comparing competitive cost, we have to look at the levelized cost of electricity, which is the unit cost of different technologies over their economic life, from construction up to decommissioning that is accounted for. And it varies widely among countries. So here's a comparison. Here's a comparison of the base load. So you're familiar with this. Base load sources are those that are available 24/7, and variable renewables are available during intermittent periods. Okay, and here we compare different financing scheme with 3%, 7%, 10% discount rates, and at least there are 22 countries that were compared, but here there are just 10 countries. Kumbaga nandito yung range na to. How do we look at this graph? For example, for a coal power plant. For a coal power plant, it is least expensive to construct it in Germany. It is most expensive to construct it in Japan. And the other countries, the figures are somewhere here in between. For natural gas, it is least expensive to construct it in the US. It's most expensive to construct it in Japan. So, and nuclear, as you can see, the range of costs is comparable or even lower than other baseload sources. While for variable renewables, we see that this is the range. The range is very large, depending on which country you're manufacturing the units. And sometimes they can look artificially cheap because of the tax incentives that is provided to solar power. But here, what you can see here is that it is least expensive to construct solar PV in Portugal. And depending on the discount rate, it is most expensive to construct it in Japan at 3% discount rate, in France at 7%, and in Portugal at 10% discount rate. So our takeaway here is that if we want an energy source that is affordable for the people, so that people will have access to electricity or to energy, then we have to have a cheap electric source. And what we see in these figures is that nuclear has a competitive cost. It can significantly help lower the cost of electricity if we look at these figures. Again, I already mentioned about radioactive waste. Okay, so previously I have talked about the different reasons why countries are going nuclear. For the succeeding slides, I will talk about the risks. Why are people so afraid of nuclear? So let me start with radioactive waste, which I already introduced a while ago. So I already mentioned that the nuclear waste volume is lower compared to other sources because of the energy density. And the waste management system of the nuclear field is second to none. It is highly regulated. And what happens is that when you have a nuclear facility, after using the fuel, the waste or the nuclear waste and the radioactive waste are categorized very carefully. And according to the categories, there are appropriate or applicable management system that is applied according to the category. So for example, if you have a very low level waste, it can be disposed without artificial barriers. For low level waste, it will be disposed with artificial barrier and so on. So we have here, so the idea is that nuclear waste disposal, definitely it is a socio-political problem. The technology is already available, but yung NIMBY, not in my backyard, na merong ganong mindset ang mga tao na, oh, alam ko, bilib ako sa technology na yan, napatunayan na yan sa maraming bansa, napag-aralan na yan ng maigi, pero ayoko pa din. So may ganun pa rin tayong, and it's not just a social problem, it's a socio-political issue that has to be addressed as well. People are also afraid of the possibility of making nuclear power plants or nuclear fuel into a weapon. That is simply not possible because of this. The usability of a nuclear material as a weapon will depend on the uranium-235 enrichment. When we get, I mentioned that uranium, pwede natin siyang makuha sa paligid natin, sa environment. Pag kumuha ka ng uranium sa isang minahan, merong dalawang klase ng uranium. Yung uranium-235 at uranium-238. Mas mabigat yung uranium-238. Ang kailangan natin sa nuclear power plant at sa weapons ay yung uranium-235, yung mas magaang klase. Now, ang mga ginagamit sa nuclear power plant at sa mga research reactor ay mas konti ang amount na uranium-235, from 0 to 20%. Yung mga ganitong klaseng nuclear material ay not weapon usable. They're called low-enriched uranium. For a nuclear material to be weapon usable, kailangan meron siyang mahigit na uranium-235. So in short, yung mga nuclear fuel na nasa power plant at nasa research reactor, hindi posibleng sumabog na parang bomba. Kasi hindi enough yung uranium-235 na present doon. There simply is not enough nuclear fuel for it to explode. The worst that can happen nga, tulad na nabanggit ko kanina, pwedeng mag-melt yung fuel pag hindi natin natanggal yung heat. But there are already protection systems to prevent that from happening. Okay? Isa pang dahilan kung bakit takot ang mga tao sa nuclear dahil daw sa mga aksidente. Now, come to think of it, Nuclear energy has been existing for more than 60 years. And it has 19,000, more than 19,000 years of operational experience. And out of that, there have only been 3 major accidents. If you try to compare that to all other industries, sa electronics industry, sa electric industry, sa coal industry, you will see na ang safety record ng nuclear is highest. So again, napakaliit ng mortality. Mamaya, I'll show the figure. And let's just look at these 3 major accidents. The first one is the 3 Mile Island, which happened in 1979. No one was killed, no one was injured. Ang pinakamalaking consequence, public confidence is severely damaged. Chernobyl, 1986. This is the worst accident that happened in the history of the nuclear technology. And in this case, 31 workers, mostly firefighters, were killed because of acute radiation syndrome. However, the greatest consequence still is world confidence on nuclear was severely damaged, and it was from fear. So hanggang ngayon, takot pa rin ang tao sa nuclear dahil sa Chernobyl, and Hollywood doesn't help. Okay? Sabi nga ng director namin, paano ka naman makikipag-compete kila Tom Cruise, kila Christian Bale? Kapag nanonood ka ng Hollywood, lagi na lang ang pinapakitang ultimate weapon ng kalaban ay nuclear, no? But anyway, for Chernobyl, this is a very different case kasi ang design ng nuclear power plant na to ay definitely unsafe. And during that time, the operators are doing an activity na hindi dapat ginagawa sa power plant. You have to remember that the Chernobyl accident happened during the time of the Cold War, when there's a competition between there's this very strong competition between the US and Russia. And Russia is parang accelerating its program to develop nuclear weapons. So, meron silang ginagawang experiment sa nuclear power plant na bawal dapat gawin. And because of what they did, yun yung nag-initiate ng accident. Ngayon, lahat ng mga design ng nuclear power plant ay na-improve na dahil sa nangyaring aksidente sa Chernobyl. That's another thing about nuclear. Every time that there's an accident that happened, yung lahat ng regulation ay updated according to what happened to make sure that the accident will not happen again. Okay? So again, if you look at it, more than 400 nuclear power plants operating in the world. And you don't know their names. Hindi nyo alam yung pangalan ng mga nuclear power plant na yun. Ang naaalala lang ng mga tao, Fukushima, Chernobyl. So it's like having a very good record, and the only thing that is remembered ay yung very few, very small percentage. It's even less than 1% nung lahat ng track record ng nuclear, pero ito yung naaalala ng mga tao. And okay, so next about radiation exposure. So definitely radiation exposure to very high levels of radiation can cause radiation sickness. But what we have to be aware of is that radiation is present all around us. No? Kung takot tayo sa radiation, huwag tayong sumakay sa airplane. Kasi na-expose tayo sa cosmic radiation. Kung takot tayo sa radiation, huwag tayong magpa-X-ray. But why do we do those things? Because we know that there's benefit. There are benefits in doing those things. So when we look at radiation as a risk, we have to look at it in perspective. So here's a comparison. Ang average background level radiation is around 2 millisievert is a unit of radiation dose. Even if we don't really fully understand the unit, this is just a relative comparison. So average of 2 millisievert per year, that's the background level. So it's naturally existing. And in the regulations, ang dose limit for radiation worker in any single year is 50 millisievert. Pero average over 5 years, that's 20 millisievert. I am working with the Philippine Research Reactor 1, and it has it is the only facility in the Philippines with nuclear fuel. And we already calculated the potential exposure of all personnel. If only one person will do all activities in the facilities for a year, ang maximum possible exposure is 16.2 millisievert. And obviously, this is a conservative estimate. We know that none of us will be able to reach this value. We're just getting background levels of radiation. So we do the calculations conservatively to show na yung aming potential exposure is even lower than the limits that are set in regulations. Now, in comparison, bago makaranas ng radiation sickness, ang threshold value ng dose na pwedeng ma-receive ay 1,000 millisievert. So, dito, wala tayong masyadong makikita, only stochastic or statistical effects. So, here, this is the threshold for start of radiation sickness. And this could happen if this dose is delivered in a very short time. So another comparison, when you have a nuclear power plant, the target radiation level near a nuclear power plant is 0.05 millisievert in a year. And you can get that amount of radiation in a single chest x-ray. Tulad ng binanggit ko nga, kapag nag-travel ka, let's say from Manila to Davao, yung amount ng radiation na may expose ka, mas malaki pa yon sa pwede mong makuha when working in our facility. Okay? So, kaya sabi ko, kung takot tayo sa radiation, huwag na tayo sumakay ng airplane. If we're flying in an airplane, therefore, hindi tayo dapat takot sa radiation. Okay? And how about number of deaths? So, this is a comparison of the days of life, lost life expectancy for different activities. And what you will see here is ang pinaka-risky in terms of death is being an alcoholic. Being an alcoholic results in 4,000 days of lost life. That's followed by being poor, by smoking, poor social connections. Ayan, make sure that you have good social life, no? Heart disease, these are based on average values, cancer, and so on. We have here motor vehicle accidents, so medyo maliit na, kaya we magnify the scale 20 times, so this motor vehicle accidents. Contingent data, and here riding bicycles. Again, we magnify it 1,000 times, so for this part of the figure, we're now looking at this axis. And where's nuclear here? And this is based on government estimates. And you see here, so by living near a nuclear power plant, it is less risky than riding a bicycle. It is less risky than riding a motor vehicle, and so on. So if we look at, there's no such thing as zero risk. Lahat ng possible activity na ginagawa natin may risk. Really, the question is it worth the risk? So we still ride the motor vehicle because we know we need it. So sa nuclear, we acknowledge that there are risks. But if there are more benefits than risks, why are we afraid to go for it? So that's just a question that should be considered. And again, this is a very neutral source. It's our world in data. So it's one of a database that shows different data for different countries in the world. So they ask this question, what are the safest and cleanest sources of energy? In terms of safest, the measure is the death rate from accident and air pollution. So coal is the least safe, followed by oil, natural biomass, then hydropower. Now, if you will look here, ang safest ay solar. Safest yung solar. And kasunod nun ay nuclear energy. And nuclear is already giving 10%. So even if it's supplying more than solar, diba? 6% higher than solar, it's still resulting in comparatively lower deaths, lower number of death rates, 0.03, okay, per terawatt hour of electricity produced. And I have shown you this figure kanina, but the figure earlier is based on IAEA data. This is another tertiary source, which is more neutral. So hindi siya biased towards nuclear. And as you can see here, it's consistent. And if you will see, mas mababa pa ang greenhouse gas emission ng nuclear kesa sa wind at kesa sa solar power. Again, carbon dioxide equivalence compared per gigawatt hour of electricity produced. Now let's look at the Philippine situation. At this point, I have shown you the case for nuclear. Why are countries going for it? But even if there are very good advantages, we also talked about the risk and perspective. Now, what's the situation in the Philippines? So as of 2021, this is the energy mix of the Philippines. So 34.6% oil, 37.1% coal. We have renewables, 16.5%. We have geothermal supplying 1.8%. Hydro, we have good hydropower plants, especially in Mindanao, 4.5%. And we have natural gas, 5.5%. Now, we have about 50.9 megaton of 50.9 MTOE. That's the total primary energy supply. But we are importing 56.8%, and more than 90% is coming from fossil fuel. So looking at the net zero goal of the world, looking at energy security, we are not really secure because we're dependent on imports, and we're not contributing to the net zero goal of net zero carbon emission goal. Now, here I summarized here the energy consumption per capita, energy consumption per person in the Philippines from the 1990s to 2021. So as you can see, the population is increasing in a relatively linear way. Yung mga black dots that represent actual population, actual census data, population census data. Yung mga gray dots, those are data. Tapos, again, you can see linear change in the number of population. But what you see in the energy consumption is that mga times nagpaplato siya. Even if dumadami yung population, mas kumukonti yung energy consumption. Now, why am I comparing this? Kasi, okay, let me just show yung in comparison to other Southeast Asian countries. So, from 1965 to 2021, noong 1965, comparable tayo sa Indonesia, Vietnam, Thailand. Again, this is normalized per person. So, we're not looking at, baka sabihin na, mas marami naman kasi tao sa Indonesia. So, malaki population nila. This is already divided by the number of people. So, per person ang tinitingnan natin. So 1965, comparable tayo till around 1980s. But you see here how we have plateaued. Hindi masyadong nag-increase ang energy consumption per person. Pero sa Thailand, we have seen a very an exponential increase. Indonesia is also increasing even with their very large population. Mas malaking population ng Indonesia kaysa sa atin. And Vietnam, they have a low population, a small population, but their energy use per person also has an exponential increase here. Okay, again, why are we looking at the electricity consumption per person? Because it is closely related to the Human Development Index, sa quality of life ng bawat tao. So here is a comparison of the Human Development Index, which is based on health, education, and living standards. Okay, and there's actually a logarithmic or relatively proportional na comparison between the energy consumption and the Human Development Index, telling us na mas malaki yung availability ng electricity per person, mas maganda yung quality of life. At ang pinakamaganda ang figure dito ay Iceland and Norway. Nandito ang Nigeria, Afghanistan, Zambia. Where's the Philippines there? The Philippines is somewhere here. Okay? And why is electricity not very much available for us? Because it's very expensive for us. Okay, so I can just imagine that if there's more electricity or energy that is available for more Filipino, then I believe that it is possible to increase our Human Development Index as well. And this has been shown in Korea. You know, in South Korea, in the 1960s, halos pareho. Actually, mas mababa pa ang state ng Korea kaya sa Philippines. But they have had a very good track record in nuclear. And now they have more than 20, almost 30 nuclear power plants operating. And now they're even selling their technology. Yung nuclear power plants ng United Arab Emirates, that is constructed by Korea. And kasabay lang natin silang nagpapatayo ng nuclear power plant noong 1970s, 1980s. Okay? And they have shown in their studies na talagang ang laki ng increase ng economy ng Korea as a direct contribution of their nuclear industry. So what I'm saying this that yes, we can go for renewables, and actually yan ang program ngayon ng Department of Energy, aggressive renewables. However, if we rely on renewables, we see the potential problem. It's good to go for renewable, pero kung yun lang yung solution natin, it's pretty sure that it will become our electricity will become fairly more expensive in the coming years. And the ways that we will produce, wala pang plano how to manage it. And also, imagine yung amount of land na instead na gagamitin for agriculture, ibibigay for solar power. So it will compete with the land use. Kasi in terms of land footprint, pinakamalaki ang land requirement ng solar. Pinakamaliit ang land requirement for nuclear. Now, obviously, we're not entirely a newcomer in nuclear. We have the Bataan nuclear power plant. And let me talk about that and show the brief history of it. In 1976, the contract was signed to procure the nuclear power plant. In 1977, a safety mission was organized by the International Atomic Energy Agency, which is focused on the review of the preliminary safety analysis report. By 1978, another safety mission was conducted by the IEEA to review the geological features of the site. By 1979, if you recall, the 3 Mile Island accident occurred in the US. So an accident that occurs in one part of the world affects the whole world. So even if the accident occurred in the US, the construction of the Bataan nuclear power plant was halted. It was suspended. Okay, no June 1979. And a commission was organized to study the feasibility of continuing the plant and also to study the safety improvements to address yung potential problem para hindi mangyari sa BNPP yung nangyari. So once it was addressed, 1981, dun lang nag-resume yung construction ng BNPP. By 1984, hot functional test was completed and the initial synchronization to the electric grid was conducted. By 1985, public hearings began for plant licensing, but by 1986, the BNPP was mothballed. There are 2 significant events that occurred in 1986. One is the Chernobyl nuclear power plant, Chernobyl accident, and the second, of course, is the change in government. So these 2 factors contributed to the mothballing of the Bataan nuclear power plant. Now, just to tell you, the Bataan nuclear power plant has 3 sister plants. We say they are sister plants kasi exactly the same design, exactly the same manufacturer and supply. Okay, so we have the Kori 2 nuclear power plant in South Korea. It was operated since 1983 and it is still operating until now. The Angra 1 nuclear power plant in Brazil started in 1985, still operating until now. And the Krishkon nuclear power plant in Slovenia, which was formerly Yugoslavia, 1990s Yugoslavia pa siya. So it started operating in 1983 and it's still operating until now. This is the power plant that I was able to visit in 2017. And I also mentioned previously that this nuclear power plant recently had its license, its operating lifetime extended for another 20 years. Now, just like the Bataan nuclear power plants, these 3 nuclear power plants are 600 megawatt electric. They're all built by Westinghouse. And throughout their almost 40 years, 4 decades of operation, no grave problems have been encountered. They are all pressurized water reactor. It's a very different design than the Fukushima nuclear power plant. So that is the current situation. We have a mothballed Bataan nuclear power plant. We have an energy crisis that is looming. And I personally think that, and the numbers are growing, that one of the ways to address the energy crisis is by going nuclear. Okay. So what is the state of the nuclear energy program in the Philippines? So here I show you a brief timeline of the activities that were done to support the National Nuclear Energy Program. In 2016, there was a conference that was organized with the IEEA, which recommended to create the Nuclear Energy Program implementing organization. So by October 2016, the DOE, Department of Energy, NEPIO, was created. Again, NEPIO stands for Nuclear Energy Program Implementing Organization. And this is the department order that created the NEPIO. By December 2018, the IEA conducted the Integrated Nuclear Infrastructure. Sorry, medyo may Unmute po yata. Anyway, December 2018, the Integrated Nuclear Infrastructure Review mission was conducted by the IEEA, and this mission reported an assessment of the nuclear infrastructure in the Philippines. Ano yung mga gaps? Later, I'll show you those nuclear infrastructures. And it was only in 2018 that the DOE NEPIO was officially funded. In 2019, a public perception survey was conducted using SWS, and the result shows that there's 79 approval acceptability of nuclear power. In July 2020, Executive Order 116 was issued. So before, the NEPIO is only localized to the Department of Energy. Based on Executive Order 116, it created the Nuclear Energy Program Interagency Committee, which involved not just the Department of Energy, but other agencies in the government. December 2020, we conducted this workshop, which drafted the national position for nuclear power. And it was only last year, February 2022, that Executive Order 164 was signed, which adopted a national position. So that means we are now considering, or we are now in the process of developing a nuclear energy program. Those activities are based on this energy projections. So this is an assessment of energy supply options. That it's a feasibility study that was conducted by the NEPIO, Department of Energy, in December 2017. And in this feasibility study, three scenarios were considered. The business as usual, or BAU, sustainable one. This means that BAU means business as usual. So that means we just continue the current development trends and strategies. Sustainable one is aggressive renewable energy development with consideration of wind offshore and improved solar technology. Sustainable two is there's renewable energy and nuclear power technology with a limit of 10,000 megawatt or 10 gigawatts for nuclear. So again, that's sustain one and sustain two. And this is a comparison of the projections. So 2020 for business as usual, sustainable one, sustainable two, and 2030 for the three scenarios, 2040 for the three scenarios, 2050 for the three scenarios. So the purple one is the nuclear. Yung second one, ito talagang renewable lang. Renewable lang you can consider. Okay? And based on the conclusion of this feasibility study, the sustainable scenario with the nuclear power plant or nuclear power program improves the affordability, the accessibility of electricity, the energy security, reliability, and environmental impact. That is consistent with what we see in the global trends. That if it is just renewable, it will be completely the opposite of this. It will be less affordable, there will be less access, it will be less secure, less reliable, and there is more environmental impact. If it's purely renewable or it's purely business as usual. But with the nuclear power program, there's an improvement in all these aspects. Also in the business as usual, with coal having the lowest levelized cost, the greenhouse gas emission will increase considerably because of the higher share of coal. Nuclear power will only be possible if we consider to reduce our greenhouse gas emission to at least 20% from the business as usual by 2030 and 30% by 2040 and onwards. According to the report also, nuclear power will come at the earliest time by 2027. So that's around 4 years from now at a high demand scenario. However, if we are very conservative, if there's low demand growth, then the entry can be delayed or will be delayed by 2 years. So that's 2029. Now, where are we? So the NEP IEC, I mentioned this already. What is the NEP IEC doing? This is the Nuclear Energy Program Interagency Committee. And according to Executive Order 116, these are the main functions of the NEP IEC. to draft the national position, to conduct the feasibility study, to develop the national strategy, to review the legal framework, to recommend how to utilize nuclear energy, to form the subcommittees, and to develop guidelines and rules to implement the executive order. Now, I have been mentioning about the 19 nuclear infrastructures. These are those infrastructures. We already have the national position. Then we also have to address nuclear safety, management, funding and financing, legal framework, safeguards. This is to make sure that we prevent any potential activity for nuclear weapons development, radiation protection, regulatory framework, electrical grid, human resource development, stakeholder involvement, site and supporting facilities, environmental protection, emergency planning, nuclear security, nuclear fuel cycle, where we will get the fuel, where we will put or how we will manage the radioactive waste or the nuclear waste. So front end and back end of the nuclear fuel cycle. We also consider the radioactive waste management, industrial involvement, and the procurement aspect. So all those 19 infrastructures, so they are grouped. For example, this is the grouping. We have 1, 2, 3, 5 infrastructure here. In another subcommittee, we have 4 infrastructure. Here we have 2, 3. Okay, so the total, of course, is 19. And according to this grouping, 6 subcommittees were formed in the NEP IAC. So subcommittee 1, 2 to 6. And these are the composition, the government agencies involved per subcommittee. And this government agencies are tasked to address this corresponding infrastructure. So what you will see here, the DOST, where PNRI is where PNRI belongs, is the co-chair for the NEP IAC, and the Department of Energy is the chair of the NEP IAC. The PNRI is involved in all 5 subcommittees. I'm a member of Subcommittee 1, Subcommittee 4, and Subcommittee 6. And our activities are ongoing to continue addressing all these infrastructures. And this is how the structure of the NEP IAC is organized. So we have the steering committee. These are the department secretaries. So as you know, it was only recently that we have the appointments of the different secretaries of all these agencies. So there was a restructuring of the NEP IAC. And it was only late last year that the reconvening of the steering team has started. And we have the NEP IAC Secretariat. And then we have the NEP IAC subcommittees, which interfaces with consultants, contractors, vendors, and suppliers. And from the work of the NEP IAC, from the drafted national position, finally in 2022, Executive Order 164 was signed, which is titled Adopting a National Position for a Nuclear Energy Program. And from this, we have the continuing work of the NEP IAC, which is continued review and improvement of the legal and regulatory framework, the national strategy of nuclear program, the development of the 19 nuclear infrastructure, implementation of a strategic communication plan, and the implementation of the integrated work plan with the International Atomic Energy Agency. So far, that is what we have with nuclear energy in terms of global scenario and in terms of the local scenario. So that's application of nuclear energy for power generation. Now, what I would like to share with you is that nuclear energy is not just limited to power application. There are also non-power applications of nuclear energy in industry, environment, agriculture, and health. In industry, even if we didn't have nuclear power because of the multiple nuclear power plant, the PNRI has been actively promoting nuclear technology for the improvement of Filipino lives for the last 50 years. Okay, so the PNRI has been existing since the 1950s. So not so 60 years already, but Atomic Energy Week is only 50 years. So in industry, the PNRI is involved in food irradiation. So through radiation technology, we can reduce the microbes in food products. Like here's an example: it's a burger patty, and it can also increase the shelf life of different agriculture products. So nagmahal yung sibuyas recently, di ba? Kasi isa sa reason kung bakit nagmamahal ang mga agriculture products kasi mabilis silang mabulok. Pag pinadaan sila sa radiation, pwedeng tumagal ang shelf life. Na instead na 1 week, pwedeng tumagal ng months. Okay, so yun yung application ng irradiation for food products and for material modification also. May mga PNRI scientists na involved sa pag-develop ng iba't ibang klaseng material na nagagamit for example as a fertilizer for farming and also for wound dressing. Environmental application PNRI is very much involved in environment monitoring using nuclear and radiation techniques, and also in soil erosion studies. In agriculture, nuclear technology can be used to control insect population, like mosquitoes, weevils, and other pests. For health, PNRI has studies for cytogenetics, or study of the cells and the blood composition of some patients, and also in wound dressing studies. So, as I've mentioned, some PNRI scientists developed this material, which is made of polymer, carrageenan, and it was irradiated. And after irradiation, they found that they developed a new material that is very effective in dressing wounds. So mas nagiging mabilis yung healing process through the material that was developed. And the PNRI has these facilities that can cater to different stakeholders. In case I see that there are universities here. These facilities can accommodate on-the-job training. If you're interested, you can just visit the PNRI website and nandun yung information if you would like to do on-the-job training at PNRI. So we have the radioactive waste management facility, nuclear analytical techniques, isotope techniques, radiation protection, applied physics, health physics, chemistry research, biomedical research, agricultural research, and nuclear materials research facilities. Now, here at this point, I would like to differentiate between two kinds of nuclear reactors. A nuclear reactor is any device that is used to initiate and control a chain of nuclear fission reaction. The basic mechanism is we have a neutron. When it encounters fuel material like uranium-235, the reaction causes the nucleus to split into two lighter fragments, which we call fission products, or FP. And this results in the production of energy that can be harnessed or more neutrons. Now, a nuclear reactor may have two different functions or purpose. If a nuclear reactor harnesses the energy from fission to produce electricity or to generate electricity, then what we have is a nuclear power plant. If the reactor harnesses the neutrons to be applied for different applications, then what we have is a research reactor. And in the Philippines, we both have this too. So we have the Bataan Nuclear Power Plant as an example of a nuclear power plant, and we have the Philippine Research Reactor 1 as an example of a research reactor. So at this point, I would like to introduce to you that the Philippines has a nuclear facility, which is the Philippine Research Reactor 1, and it has been shut down for more than 30 years. But last year, our group was able to commission it. So we reoperated the Philippine Research Reactor 1 as a subcritical assembly for training, education, and research, or SATR, which has the following objectives: to support nuclear manpower development, accommodate local access to an operating nuclear facility as a training facility, and also to engage stakeholders. So if you would like to visit the facility, we actually encourage that. I'm inviting you, if you have a chance, to visit PNRI, please visit Pier 1. Those who are able to go to Quezon City, pag nakita niyo egg-shaped dome doon, yun yung building ng Philippine Research Reactor 1. And we were able to commission the reactor last year in June 2022. And one of the objectives of this is also to repurpose the existing resources of the historical PRR1. It's a historical facility because it is the first nuclear facility in the Philippines. And so far, it is the only nuclear reactor that is operated in the Philippines. But we hope that it will not be the last one. So this is the utilization plan for the PR1 Center. It will be used for public awareness, for nuclear education. Right now, we are already catering to the University of the Philippines, Diliman, the Energy Engineering Program. They're already offering nuclear subjects, and the PNRI specialists are teaching in UP to deliver those courses. The facility will also be used for capacity building for nuclear power and also for research and development and services. So let me end with this slide. So this is the PNRI reactor team, which this is our team with the PNRI director. And this is the team that is responsible for the commissioning of the PR1 Center. So with that, thank you very much for your attention. And I'm open for your questions. Thank you.
Thank you very much, Dr. Aldi, for the wonderful presentation. And yes, thank you very much, Dr. Aldi, for this wonderful topic on nuclear energy. My key takeaway here is that I never knew that there's a significant relationship of primary power consumption to human development. It would be a great opportunity for us Filipinos to utilize optimally, at most safely, nuclear power. At this moment, we will now have the question and answer forum. You may now write your questions on the chat box. Partner, Sectoni?
Hello, partner. Can you hear me?
Yes, loud and clear.
Yes. Let me just share my screen. So this is question number 1. So, partner, go ahead. Please read the question.
Okay, for question number 1, is there an initiative from BOST to study and advance further the use of thorium instead of uranium? What are the pros and cons of using thorium? Dr. Sormo?
This is a very good question. It means that you have a background in, aside from uranium, you can also use thorium. And thorium is another naturally occurring radioactive material. So yung pinakita kong projection kanina na more than 200 years na available ang nuclear fuel, that is even extended pag kinonsider pa natin yung thorium. Now, right now, the focus of most research and most nuclear design is based on uranium pa rin. Although nasa conceptual stage, meron nang nag-study ng thorium. Why is the focus not yet on thorium? Kasi marami pang uranium. So, what do we mean by that? Na right now, there's no commercial, there is not yet this commercial motivation to pursue thorium. Pero once we deplete uranium, then we can go to thorium. Okay? So, pros and cons, thorium actually, yung thorium, yung cons siguro is that thorium in itself is not usable as a nuclear fuel. Kailangan pa siyang matransmute. Kailangan siyang patamaan ng neutron. At pag tinamaan siya ng neutron, mag-dedicate siya into uranium-233. It's still uranium-233 that can be used for nuclear fuel. So, meron ng mga conceptual design ng mga reactors at meron na rin mga demonstration facilities that have shown it is feasible. pero the technology is not yet commercially feasible. So technically feasible na siya, but not yet commercially. Why? Kasi nga, kasi alam natin to, di ba? Anong mas mura? Yung mga off-the-shelf na design o yung mga specially fabricated na design? Obviously, it is more expensive to have specially fabricated design. So wala pa tayong standardized design ng mga power plant na based on thorium. Kaya mas mahal pa siya. Okay? Pero yung uranium-based, kita natin mature na yung technology. Kaya cheaper siya. And hindi pa napupunta yung effort sa thorium kasi nga malayo pa bago natin maubos ang uranium. Okay, I hope that answers your question.
I see. Thank you very much, Dr. Astronomo, for that answer. That's very comprehensive, as said by Chairman MP. Question number 2.
Hello, partner.
Yes,
I think
partner.
your audio is weak. Can you put your mic closer?
Is my voice clear?
And better.
Now?
Okay. Please proceed. Thank you.
Partner? Okay. Okay. Question number 2. What about your views about nuclear fusion? I think it is much relatively safe than nuclear fission. I just remember the BNPP, sayang hindi sila napakinabangan. It has the same structure used in Switzerland, which until now operational, and there are plans to restore the BNPP. What is your view on this? Safe ba to restore it? Why or why not?
Once again, thank you for this question. I would be splitting this question into several parts. First one is about nuclear fusion. Definitely, it is relatively safer than nuclear. But just when I mentioned that thorium-based technology is far in the future, nuclear fusion is even farther in the future. So until now, there's this international collaborative project that involves billions of dollars, hundreds of billions of dollars that are being invested to demonstrate the commercial feasibility of nuclear fusion. And according to most assessment, it is at least 50 years from now bago siya maging commercially feasible. It's definitely safer, but it's definitely not cheap also. So it's an expensive technology right now. With regards, I think that's your first question. Your second question is about the BNPP. I would agree na hindi siya napakinabangan. In fact, nalubog tayo sa mga dahilan ba't nalubog sa utang ang Pilipinas is because hindi natin napakinabangan ang BNPP. With regards to the same structure in use in Switzerland, I think I would have to disagree here with you here kasi it's not in Switzerland but it's in Korea, Brazil, and Slovenia. Yun yung merong exactly the same design. Sister plants yung tawag natin sa kanila. But you are correct that those three, not in Switzerland, but those three, the power plants, 3 power plants in those countries are still operational until now. And in fact, they are the reference plants for the consideration to rehabilitate the BNPP. That brings us to your last question. Safe ba ito to restore or not? With regards to safety, there are always engineering solutions. And we already have a demonstration facility as shown by these 3 nuclear power plants in 3 different countries that are operating. So meron na tayong model kung paano i-upgrade, kung paano i-rehabilitate. Ang question na lang ay feasible ba siya? Ano ang mas mura? I-rehabilitate ba ang BNPP o gumawa na lang ng bagong plan? At yun yung sinusubukang sagutin ngayon ng Nuclear Energy Program Interagency Committee. In terms of safety, again, that can be done. And it has been done hundreds of times, more than hundreds of times. For 60 years, it is possible to make it safe. Ang question na lang talaga is the investment involved.
That's good to hear, Dr. Astronomo. Sa palagay ko nga maganda yung yung promise niya. Let's see kung anong magiging next step nito. Okay, thank you very much for the answer, Dr. Astronomo. Next question, partner.
Partner, dami po tayong tanong sa chat box.
Yes.
Here's the next question.
Question number 3 is the design of Bataan nuclear power plant is already updated? Is there a possibility that we can still utilize it, or is it acceptable in the current standards of nuclear power plant? Doc Astronomo.
Okay. this is related to the previous question. With regards to the update, no, it is not. Kasi tulad ng nabanggit ko sa inyo, tuwing every year na-update ang standards, na-update ang regulations, at na-update ang international best practices ng nuclear community. Dahil wala pa tayong nuclear program for for decades, then walang pondo na nai-allot to update the Bataan Nuclear Power Plant. But what I'm saying is, it is possible to upgrade it or to rehabilitate it. It's just a matter of investment. So, yun yung second question. It is still possible to be utilized. And in fact, the Korean company offered to rehabilitate it in 2017. Pero yun nga, dahil wala pang final decision that time, hindi pa siya lumalakad. Okay?
All right, thank you very much, Doc Alvi. Partner, next question.
Partner, here's the last question for Dr. Aston.
Okay, for the last question, okay, how would you assess po ang overall readiness ng Philippines in harnessing nuclear power as an alternative source of energy or of electricity? What are the challenges have you seen po?
Very relevant question. Very relevant question. So as for me, in terms of assessment, I don't have to say it myself. The International Atomic Energy Agency conducted the Integrated Nuclear Infrastructure Review, which assessed the readiness of the Philippines in terms of the 19 nuclear infrastructure. So ang IAEA, meron siyang milestone approach na tinatawag. So milestone approach na according sa decision to construct or decision to go nuclear, na doon na tayo sa first milestone. Ang next is decision to procure, and then decision to construct, and then the decision to operate. So in terms of overall readiness, nandun na yung assessment. And they are saying na we are in the right track. Okay? So what I would like to say is that yung readiness would be a matter of decision. Parang ganito. Nakita ko yung kanina yung parang promotional video nung Adamson University, no? Na like decisions, where are you going to study? So sometimes from or even from after graduation, saan ka magtatrabaho? In terms of your readiness to work after graduation, it's a matter of you deciding, I want to work na. O kaya I want to study na. Will I work or will I do grad study? So yung mga ganung mga option, you can be ready as long as you have the decision. Now, the Philippines already has a decision. And with that decision, we can be made ready. At yun na yung ginagawa natin. For example, sa legal and regulatory framework, ina-assess ngayon lahat ng mga batas, saan may loopholes. So ngayon, gumagawa na ng mga amendment para mai-address kung ano yung mga loopholes ng ating mga batas. In terms of human resource development, meron ba tayong critical number of people to address that? So meron tayong subcommittee to address that. And nabanggit ko nga kanina, ang University of the Philippines at ang Mapua University are very active now in developing the education programs to make sure that we have sufficient number of people. And I hope more universities will be involved. But based on the track record of other countries, even if you have for a single unit nuclear power plant, ang average number of people involved ay around 1,000. Pero konti lang ang kailangan mong specialist. Karamihan doon ang kailangan mo technicians, mga mechanical engineers, electrical engineers, electronics engineers, and so on, na kailangan lang merong capable to run large geothermal power plants and even hydropower plants. And in fact, yung mga nuclear power plants sa ibang bansa, hina-hire ang mga Pilipino. So in short, in terms of capability, I believe we are capable. It's just a matter of really organizing all those efforts to make sure that we benefit from nuclear power. So definitely, we can be ready. At kaya lang yun nga, yung mga challenges na yun, kailangan ma-address yung 19 na nuclear infrastructure.
Yes, thank you very much, Doc Alvi, for that answer. I think this is the last question for today. Sorry for that. I think that's the last question for today. Sorry to we couldn't accommodate any further questions to maximize the time. So let's proceed. Thank you very much, Doc Albi, for your insights and ideas for this topic. Moving forward, let me share my screen. Okay. So for the awarding of Certificate of Appreciation, I would like to call upon Engineer Bernard G. Viray, PECE, Vice Governor for External Affairs, IECEP Cavite. Engineer Bernard, over to
Good noon to everyone, and it is my privilege to award this Certificate of Appreciation to our speaker. Can I have the certificate slide, please? Institute of Electronics Engineers of the Philippines Incorporated, Power Electronic Society, hereby presented this Certificate of Appreciation to Dr. Alvi Asuncion Astronomo in sincere acknowledgement for with her invaluable contribution as a resource speaker for the third colloquium on power and clean energy with the topic nuclear energy, sustainable, secure, and equitable power source, given this 11th of February 2023. Signed by the governors of IECEP Bulacan Chapter, Engineer Christian P. Enobal, IECEP Mindoro Chapter Governor, Engineer Gerald U. Chocson, IECEP KSA-ERC Chapter, Governor Engineer Muhammad Ali B. Mauna, IECEP Cavite Chapter Governor Dr. Jodelix M. Cercilia, IECEP Manila Governor Engineer Teofilo Lorenzo S. Conquinco III, and Chairman of IECEP Power Electronic Society, Engineer Mark Philip G. Fernandez. So congratulations for Doc Astronomer, and a round of applause, please.
Thank you very much. Thanks, Laman.
Back to you, Sir Albin and Sir Tony.
Thank you very much. Again, Doc Albi, Bernard. So now I would like to call upon yes. Now we will have our photo opportunity. We would like to mute all since we are responded all of the participants. So please can you open the cameras? Yes. Okay. Partner, can you see the participants and view them appropriately in the screen?
So requesting all to please open your video. Si Miss Faye na po magpa-facilitate ng pagkuha ng picture po. Miss Faye, please kindly assist us po for the photo of.
Yes po. Wait lang po natin yung iba na mag-open po ng mga cameras nila. Ayan.
Okay po, Miss. Please,
Okay.
everyone, please turn on your video. We'll be giving you a couple of seconds, please. Para makita po natin ang inyong mga handsome and beautiful faces.
Okay. Okay, pa ready na tayo. And 3, 2, 1, smile. Okay po. Wait lang po.
Pwede pong one IECEP tayo. One IECEP.
Okay po. Then. Hold your smile lang po kasi po medyo madami tayo ngayon. We have 9 pages po. 1, 2, 3, smile. Next page po. 1, 2, 3. Okay. And next page po. 1, 2, 3. Next. 1, 2, 3. 1, 2, 3. Okay, malapit na po. 1, 2, 3. That's 2 pages na po. 1, 2, 3. Okay. Next. 1, 2, 3. And the last page po. 1, 2, 3. Okay po, thank you po.
Thank you very much, everyone. So nakita po natin ang mga handsome and beautiful faces niyo po. Thank you very much. Partner, over to you.
Yes, thank you very much, partner. Let me share my screen first. Thank you for the photo opportunity. Ang mga participants talaga natin, mga magandang itsura talaga, ano. No, now moving on. We have several announcements. Na kailangan namin i-deliver. First is, as mentioned by our National President Engineer Lyle, IECEP will be having this IECEP Kausap to be presented by IECEP National Publications Committee 2023 on February 11, 2023 from 7 p.m. to 8:30 p.m. This is a live event through Facebook page. So pakihanap na lang po ang IECEP National. Then next is also from IECEP National, we will be having the Mid-Year Convention 2023, the 73rd IECEP Mid-Year Convention with the theme Masterpiece, showcasing engineering ingenuity in electronics and emerging technologies. This will be at Puerto Princesa City, Palawan on June 1 to 3, 2023. See you there. Another announcement is from IECEP Cavite chapter. They proudly presents PECE Talks, a guide in upgrading to PECE by Engineer Bernard Viray, Vice Governor for External Affairs. This will be done on February 2023, this month. Details will be posted on their FB page. So, ano po, search na lang po yung IECEP Cavite chapter. Andun po yung kanilang announcement for further details. Okay? Then next is also from Cavite chapter. Yes.
Okay, so go ahead, Belas Papalag.
Next is the first consultative meeting with officers and members entitled AMA or Ask Me Anything with Dr. Jodelix Sarcilia, Governor of IECEP Cavite, and their moderators, Engineer Bernard Viray, Vice President for External Affairs, and Engineer Marichel Giogangco, Vice Governor for Internal Affairs. This will be done on February 18, 2023 from 6 p.m. to 8 p.m. The link is the QR code. You can scan the QR code or look into their Facebook page for more details. And lastly, also from IECEP Cavite chapter, Partner Spotlight, a monthly series featuring industry leaders and their aspiring stories of success. This starts on March 2023. Partner Sec Tony.
Okay, thank you very much, partner. So at this point, may we call on Engineer Eugene Embazaldo Jr., the chairman for the National Specialization Society. Engineer Eugene, are you there? Still there? So we'd like to invite you to give some message and also if you have important announcements. Dear Eugene. Okay, partner, siguro wala pa si Engineer Eugene. We can proceed with the evaluation muna.
So,
please pakidrop na lang sa ating chat.
Sure, wait lang. Let me share my screen again. All right, so here is the evaluation link for morning session. For first topic, we have the link please click on it on the chat box. Second, I'll be sharing this on the chat box. All right, this link will be shared via chat box. Hold on a second. Sorry. Here you go. Here's the link. Here are the links for the sessions that we have for this morning. Please do click on this link, and it is necessary for your claiming or for you to be qualified to claim for the e-certificates. All right. Reminder: this evaluation link is needed for your e-certificates. Please click the link on the chat box. All right. Yes, for further announcement, this form will be available on February 11, 2023 only. You can contact the organizer isep.pels@gmail.com. Sectoni, there are some concerns. May mga concerns po sa link.
Okay, we'll open na po yung mga evaluation links. So, pakiantay lang po. Okay, so we'll open po in 1 minute.
Alright. So habang ino-open ni Sectoni, ni partner ang ating evaluation link, please be mindful na na sa mga accidentally na bubuksan yung kailang microphone during the sessions. Please always mute the microphones during the session. Okay na ba, Sectoni?
Yes po, okay na po ata yung ating forms. Please check po. Thank you.
Okay. We're sharing the links for the evaluation.
Please try again. And pakilagay na lang po sa chat box kapag hindi pa po na-open. So thank you very much everyone for coming and attending the AM session. Yan, at least nakalahati na po natin yung ating program.
Yes. Now that we have finished 2 out of 5 sessions for this day, we will now have our lunch break. Lunch break. Yes. And see you after an hour. This is Alvin Lasso de la Cruz.
This is Engineer at Addiction Junior.
Happy lunch and God bless.
Yes po. So let's be back around 1:30 PM po. Happy lunch po.
Happy lunch. Thank you very much.
Do you know where you're going? Do you know where the road you're taking will lead? Your future depends on what you're doing right now. You wonder if you made the right choice. If your choices lead you to your dreams or nightmares. If your choices led you to Adamson University, then they have led you to a better future that begins with an amazing present. In AdU, we believe in solidarity. We are drawn together by a shared vision and mission. Here, our community is a family. Here, Education is a shared responsibility where participation, teamwork, interdependence, communication, and dialogue is customary. In ADU, we inculcate social responsibility, the mark of an authentic Catholic faith. We are dedicated to your sustained integral development. We are committed to provide you with programs, facilities, services, and an education that guarantees your holistic development and continuous beneficial learning. We hold sacred the spirit of St. Vincent de Paul. His love for learning and love for the poor permeates our community. And finally, key to an Adamsonian education is the search for excellence. We continue to hold the highest standards of academic excellence and professionalism in service. This is the hallmark of our educative endeavors. Welcome to Adamson University. Here, your dreams for a brighter tomorrow will start coming true. There is a rush that comes with being in Manila, a sense of dynamism, of growth, of the old mixing with the new, of yesterday and today coming together, of youthful energy and older wisdom blending perfectly, of science and faith melding effortlessly. Much of that energy and synergy springs from Adamson University. Adamson University lies sprawled in the heart of Manila along San Marcelino Street, one of the country's most historic avenues. Envisioned and designed by educators with a heart for the less privileged, and a particular skew towards scientific and technical education, Adamson University is pushing forward while being totally committed to its vision of being a recognized leading center for quality education, particularly for the socially disadvantaged. This was the dream of its founder and first president, Dr. George Lucas Adamson, and his cousins, George and Alexander Athos Adamson. On July 1, 1932, the Adamson School of Industrial Chemistry opened its doors to students, operating on the principle of a maximum amount of practical education in a minimum amount of time. 85 years into the future, and Adamson University is still living up to those principles, with the additional skew towards helping the poor as a Catholic institution, creating curriculum based on the present needs of society, thus allowing graduates to find work faster, as well as co-curricular activities that develop students' talents, character, confidence, and team spirit.
The Adamson University you see today began with the best intentions to give the burgeoning Filipino youth a technical and scientific education which was badly in need in the 1930s. But fast forward to today, and this school has become a center of quality learning and service, both here and abroad. All this ties in beautifully with the university's vision and mission.
Impelled by the dream to be part of nation building and driven by a love for education, Adamson University spares no expense in equipping the school and its students with the facilities necessary for a well-rounded education. Adamson University, or ADU as it is fondly called, is known across the country and in some parts of the world for its engineering courses. This, in large part, is due to a team of some of the finest and most skilled professors, as well as the state-of-the-art facilities available for both theory learning and practice. ADU has equipped itself with its leading-edge Information Technology Center. With the creation of the ITC, the university is moving towards becoming a fully computerized campus. Adamson University has 9 colleges, a basic education department, and a school of theology. The university offers other cutting-edge laboratories for the school's many course offerings, such as the pharmacy lab and other science laboratories. But Adamson University is most proud of its chemistry laboratory, which is considered one of the largest in Asia, housing up to 1,000 students. Aiming to give as many students the opportunity to learn and do what interests them, the university offers Bachelor of Science, and Bachelor of Arts programs. It also offers masteral and doctoral programs, offering those who choose to go on for higher education the chance to do so. The university's colleges belong to several national professional organizations, allowing our students to network with the best local minds in their particular field of choice. Beyond all these, some of Adamson University's degree programs have been recognized by the Commission on Higher Education as centers of development. In 2010, ADU passed the IECEP and received autonomous status from CHED. The university has always received an entire roster of certifications and awards.
There's much to be proud of, but at the heart of all this theory and practice is the true heart of Saint Vincent de Paul, our patron saint, a heroic yet humble man who devoted his life to the service of the poor. Following in his footsteps, we are trying to cultivate Adamsonians who will develop the virtue of using their talents to serve others. We are creating young Filipinos whose powerful faith allows them to freely and completely share their strengths with others, especially those in need.
In 1964, the Adamsons turned the university over to the Congregation of the Mission, also known as the Vincentians, whose mission is to evangelize the poor. While Dr. George Lucas Adamson remained as president for 3 more years, the school became a Catholic university, imbibing the spirit of St. Vincent de Paul in its teaching its students and academe, sensitivity to the presence of God, compassionate service, and the building of supportive relationships towards an effective service to persons in need. As such, Adamson University has one of the most affordable tuitions for a learning institution of its caliber, as well as numerous scholarships given out each school year. The school and its students are also recipients of the grants from several local and international foundations. But here, academic skills are not the only way to get a scholarship. ADU offers scholarships to its athletes, ADU Chorale, Band, and Pep Squad, with the intent to show that while academics are necessary, they are not the only way to get ahead. Based on the teachings of St. Vincent de Paul and the many presidents that have been at the helm of this illustrious institution for decades, there are 3 attributes that define a true Adamsonian.
You have competence when you are able to produce outputs based on the learnings that you had in the classroom. This is an education which many others can only dream of, but I am actually experiencing. We need to develop our creative and critical thinking, our fluency and articulateness, and also our lifelong learning. We really need to become up to date with technology because our generation as well as our businesses are slowly becoming tech savvy. We need to focus on both theory and practice. And in this way, we will become well-rounded Filipinos and we will make our university proud.
One of the theses of Adamsonian attributes is character. Mingled, of course, with the academics we offer here at ADU, we also strive to build our students' character via network and leadership, via the Adamsonian identity and integrity as well, by commitment to social transformation, by developing patriotism and, of course, a universal outlook, and by learning to care for the environment.
And lastly, charity. This will be guided and powered by our faith in God and the spirit of Saint Vincent de Paul. An intense love for learning and an equally intense love for the poor. As high as the falcon soars, that is how high we dream our students will soar as well. Because with them, the nation will fly higher.
Maraming pangarap ang umusbong mula sa mga simpleng tanong. Mga tanong na humantong sa pagtuklas, inspirasyon, at paglalakbay. Matagal na nating tinutuklas ang kalawakan. Marami na rin tayong natuklasan dahil sa pagmamasid mula sa kalawakan. Ano na ba ang lagay ng panahon? Saan at kailan kaya tatama ang bagyo? Ano na ba ang kalidad ng hangin na ating nilalanghap? Pero mas malawak pa ang gabay na pwedeng manggaling sa kalawakan. Dahilan kaya tayo naglalagay ng infrastruktura at patuloy na kumukuha ng impormasyon sa ating planeta. Gabay tungo sa pangarap na makabangon at magkaroon ng mas maunlad na hinaharap katuwang ang agham at teknolohiyang pangkalawakan. Pangarap na abot tanaw na sa pangunguna ng Philippine Space Agency o PhilSA. Itinatag noong 2019, ang PhilSA ang magtataguyod ng mga programa para tiyakin ang payapang paggamit ng kalawakan upang pangalagaan ang pambansang seguridad at suportahan ang ating pag-unlad. Bantayan ang kalikasan at tiyakin na makakaiwas tayo sa peligro ng mga sakuna at nagbabagong klima. Paigtingin ang pagsasaliksik at paggawa ng mga bagong teknolohiya. Suportahan ang pagsibol ng mga bagong industriya at pagsigla ng ekonomiya. Palawakin pa ang edukasyon at kaalaman ng publiko tungkol sa kalawakan at makipagkaisa at makipagtulungan sa iba pang mga bansa. Tinatahak na ng Pilipinas ang landas tungo sa makabago, mas ligtas at mas masaganang buhay para sa mga Pilipino gamit ang agham at teknolohiyang pangkalawakan. Isang karangalan ang pagkakataong maging bahagi ng paglalakbay na ito. Isang karangalan na isulong at panatilihin ang matatag na pangkalawakang komunidad na magpapahalaga sa mga mithiin ng mga Pilipino sa buong mundo. Isang bansang masagana, nakakaangat at may kakayanan, katuwang ang payapang paggamit ng kalawakan.
When the Philippines began building satellites, we started small. As small as a suitcase. Yet the stakes were high and the challenges were great. After the success with 6 of these small satellites, the Philippines is ready for something bigger. In December 2020, the Philippines kicked off the Multispectral Unit for Land Assessment, or MULA satellite project. Weighing around 130 kilograms, MULA will carry a true color camera that can capture higher resolution images, covering around 73,000 square kilometers of our country in one day. Data from MULA satellite will be used for addressing food security, disaster resilience, environment conservation, and protecting our national sovereignty. The Department of Science and Technology jump-started the funding of MULA. The project was jointly implemented by the DOST, Advanced Science and Technology Institute, and the University of the Philippines, Diliman, in coordination with the Philippine Space Agency, or PhilSA. 16 Filipino engineers who underwent a know-how training and transfer program in the UK are involved in building the satellite and are now part of PhilSA. The training capacitated our homegrown engineers, not just with knowledge, but the license to build more local commercial satellites in the future, leading the way for the creation of a robust and thriving space industry to support the country's space program. PhilSA will oversee the completion and launch of MULA and manage its operations. MULA in Ilocano means plant, pointing to the satellite's mission on food security. In Tagalog, it means point of origin or beginning, which symbolically signals the Philippines' foray into a new era in satellite development toward the vision of a nation bridged, uplifted, and empowered through the peaceful uses of outer space.
Hello, kamusta? I am Naoko Yamazaki, a former Japan Aerospace Exploration Agency's astronaut. I visited the International Space Station in 2010, and my background picture was taken at that time. I am so delighted to receive many questions from Filipino children, and I'm happy to answer.
Hello, my name is Aaron Wayne S. Mendoza. I am 10 years old and I study at Seria Osmeña SPED, Olongapo City. I have 3 questions. Question 1. How are black holes made? Question 2. How long does it take to go to the moon? Question 3. Where do auroras come from? Thank you and God bless.
Hi, Aaron. Your questions are: how are black holes made? Well, each star has its own life. When giant stars, which are much bigger than the sun, terminate their lives, they get so much pressure due to the gravity, and they become black holes. I do not have a detailed answer, but if you are interested, I'd like to encourage you to keep studying astrophysics, which is very interesting. And how long does it take to go to the moon? It takes about 3 days to get to the moon. So if you want to make a round trip, it takes about a week. And where do auroras come from? Auroras come from the Earth's magnetic field, which get high energy particles from the sun. So auroras happen due to the reaction from the solar energy and the Earth's magnetic field. I saw auroras many times in space, and which are very beautiful.
Hi, I'm Anton Rutuya and I am 11 years old.
I am looking to be an engineer when I'm older, with the intentions of building spaceships and maybe even space stations. So, can you tell me, from what you know, how far away are the space industries such as NASA from building artificial gravity on spaceships and space stations? Also, what subjects do you believe I have to study to achieve my goals? I'm looking forward to hearing back from you. Thank you.
Hi, Anton. Your questions are how far away are space industries, such as NASA, from building artificial gravity on spaceships and space stations. You know what? On board the International Space Station, there is already an artificial gravity facility, which is not for human beings. It's much smaller. It is for mice. But Japan experiment module has the artificial gravity facility for mice, and it can generate up to 2 Gs by centrifugal force by rotating the facility. And the good thing about artificial gravity is we can make any gravity up to 2 Gs, which means we can create 1/3 of gravity on Mars, or we can create 1/6 gravity on the moon. So we can, conduct various experiments changing the gravity in space. And what subjects do you believe I have to study to achieve my goals? If you are interested in space or astronauts, I'd like to, study STEM field, any field in STEM, because my background is engineering, but some of the astronauts are from medical doctors or pilots or researchers or so many, variety of fields. So any field, if you have some specialty, which is very helpful for you to pursue your career. So never give up, just keep going on. Good luck.
Mabuhay, Naguchi-san!
Hello, astronaut Noguchi.
Astronaut Noguchi. Hi, astronaut Noguchi. I want to be an astronaut someday like you. Magandang araw!
Hello, astronaut Soichi Noguchi.
One day, I think I want to be an astronaut just like you. Hi, astronaut Soichi Noguchi.
I wish I have a chance to meet you in person.
Hello, Mr. Soichi Noguchi. Hi, Mr. Astronaut Noguchi. Konnichiwa, Soichi-san. Daijoubu desu ka?
I hope you can continue your work safely on the ISS.
Make sure stay safe from the virus while the rocket is flying. And make sure you stay healthy too. Hi, astronaut Soichi. O genki desu ka?
Hello, magandang tanghali po. Konnichiwa. My name is Soichi Noguchi, Japanese astronaut. I just returned from the International Space Station after a 6-month stay. This was my 3rd flight and my 3rd different spaceship. And during my stay, I was fortunate to do my 4th spacewalks. And I established 2 Guinness World Records. What an experience. Now I am glad to talk to our friends in Philippines. I had many chances to see your beautiful islands from the International Space Station. I posted a few photos on my Twitter and hopefully you have seen them.
I think your picture is beautiful and I hope you're safe from asteroids and meteors. Thank you for the picture of the Earth. I really like how you took the picture of the Philippines.
This is where I live and this is where my grandma and grandpa lives.
I hope I can meet you soon.
When we be best friends, maybe I'll take me to the moon sometime. Please.
I received many comments and questions from children from Philippines. There were too many to answer today, but hopefully I can visit Philippines in the near future and talk to the children in person. Now, the COVID-19 has confined our activities on Earth to a greater extent. I, however, strongly believe that we can overcome the difficulties if we can all put together and try to preserve Earth for future generations. Thank you very much for the people of Philippines for great attention. Salamat po, paalam na po. Thank you and goodbye.
Gambate Rizal.
Your name rhymes with Tamagotchi. Bye, astronaut Suichi Noguchi.
I'm excited to have joined Advanced Energy during this landmark year, our 40th anniversary as a global power solutions leader. Our celebration highlights two key factors that differentiate AE. First, our innovation in precision power, conversion, and measurement. And second, the talented people who make this possible. It's an incredible story. Doug Schatz, Advanced Energy's co-founder, the first of many people at Advanced Energy to dream big, initially made power supplies in his home. Over the years, we have grown by developing leapfrog technologies that exceeded customer expectations. R&D has powered our business, and it still does. Worldwide, we have built a thriving ecosystem of global design centers and manufacturing facilities. Our ultimate goal is to deliver high-quality, best-in-class products and services to our customers. In recent years, we've grown rapidly, both organically and through acquisition, including Artisan Embedded Power in 2019. Today, Advanced Energy is the clear global leader in precision power. Our products are critical enablers for some of the most advanced manufacturing processes in the world. And our products help to power critical industrial, medical, data center computing, telecom, and networking equipment. With years of groundbreaking technology and strategic partnerships, you might think that tells the full story. But when you ask why Advanced Energy, customers talk about our people and the exceptional customer experience we deliver. We listen, we innovate, we collaborate, and we're passionate about our customer success. Today, at 40 years of age, we have over 10,000 employees, and we're growing. Our can-do culture, our deep technical expertise, and our collaborative approach to problem solving make Advanced Energy a great place to work. To kick off our celebration, I'd like to extend a heartfelt thank you to our employees for their commitment, talent, and passion, to all that you have built over the past 40 years. To our suppliers, thank you for your continued partnership and your support. And to our customers, you're the reason we're here, and we're committed to your success. And finally, to our long-term investors, thanks for your support over the years. For 40 years, Advanced Energy has been a proven power solutions leader. Now our innovative precision power conversion and measurement solutions are at the center of the fourth industrial revolution. We truly power the future, thanks to all who have made it possible. And here's to 40 more years of growth and success.
Advanced Energy powers the world around us by providing the precision power products required to manufacture and test many high-tech and industrial products, and many common household items that are ingenious in their own quiet way. Manufacturing the things we use and encounter each day requires an unbroken chain of innovation that begins with specific applications of power. With our precision power products, there's no room for error. And there's no comparison to our expertise at finding new ways to make the production, testing, and shaping of materials simpler, more reliable, and more affordable. Our purpose is to enable the innovations of our customers, so they in turn can meet the needs of their customers. Around the world, at home and at work, products made with Advanced Energy power are everywhere. From the thermal control products we provide to heat glass and steel, and the power needed to apply thin protective films to architectural glass. Manufacturers rely on our high and low voltage systems to deliver impressive performance and accuracy across a wide variety of modules and applications. No matter how complex the technology, our innovations are dedicated to helping our customers develop products that improve the lives of their customers. We even provide power for lasers used in laser eye surgery, electrosurgery, and cosmetic medicine, and the high voltage pulses needed for defibrillators and lasers to break up kidney stones. The power from mass spectrometers used in drug, water, and food testing, and in clinical and laboratory testing. As our customers innovate, we work to transform the future with them, wherever they are in the world. This makes our innovations global and personal. Precision, power, and performance. These words define our dedication to shaping and transforming power. and to doing our part to make each day a little more magical than the day before.
Do you know where you're going? Do you know where the road you're taking will lead? Your future depends on what you're doing right now. You wonder if you made the right choice. If your choices lead you to your dreams or nightmares. If your choices led you to Adamson University, then they have led you to a better future that begins with an amazing present. In AdU, we believe in solidarity. We are drawn together by a shared vision and mission. Here, our community is a family. Here, education is a shared responsibility where participation, teamwork, interdependence, communication, and dialogue is customary. In AdU, we inculcate social responsibility, the mark of an authentic Catholic faith. We are dedicated to your sustained integral development. We are committed to provide you with programs, facilities, services, and an education that guarantees your holistic development and continuous beneficial learning. We hold sacred the spirit of St. Vincent de Paul. His love for learning and love for the poor permeates our community. And finally, key to an Adamsonian education is the search for excellence. we continue to hold the highest standards of academic excellence and professionalism in service. This is the hallmark of our educative endeavors. Welcome to Adamson University. Here, your dreams for a brighter tomorrow will start coming true. There is a rush that comes with being in Manila, a sense of dynamism, of growth, of the old mixing with the new, of yesterday and today coming together, of youthful energy and older wisdom blending perfectly, of science and faith melding effortlessly. And much of that energy and synergy springs from Adamson University. Adamson University lies sprawled in the heart of Manila along San Marcelino Street, one of the country's most historic avenues. Envisioned and designed by educators with a heart for the less privileged, and a particular skew towards scientific and technical education, Adamson University is pushing forward while being totally committed to its vision of being a recognized leading center for quality education, particularly for the socially disadvantaged. This was the dream of its founder and first president, Dr. George Lucas Adamson, and his cousins George and Alexander Athos Adamson. On July 1, 1932, the Adamson School of Industrial Chemistry opened its doors to students, operating on the principle of a maximum amount of practical education in a minimum amount of time. 85 years into the future, and Adamson University is still living up to those principles, with the additional skew towards helping the poor as a Catholic institution, creating curriculum based on the present needs of society, thus allowing graduates to find work faster, as well as co-curricular activities that develop students' talents, character, confidence, and team spirit.
The Adamson University you see today began with the best intentions to give the burgeoning Filipino youth a technical and scientific education which was badly in need in the 1930s. But fast forward to today, and this school has become a center of quality learning and service, both here and abroad. All this ties in beautifully with the university's vision and mission.
Impelled by the dream to be part of nation building and driven by a love for education, Adamson University spares no expense in equipping the school and its students with the facilities necessary for a well-rounded education. Adamson University, or ADU as it is fondly called, is known across the country and in some parts of the world for its engineering courses. This, in large part, is due to a team of some of the finest and most skilled professors, as well as the state-of-the-art facilities available for both theory learning and practice. ADU has equipped itself with its leading-edge Information Technology Center. With the creation of the IECEP, the university is moving towards becoming a fully computerized campus. Adamson University has 9 colleges, a basic education department, and a school of theology. The university offers other cutting-edge laboratories for the school's many course offerings, such as the pharmacy lab and other science laboratories. But Adamson University is most proud of its chemistry laboratory, which is considered one of the largest in Asia, housing up to 1,000 students. Aiming to give as many students the opportunity to learn and do what interests them, the university offers Bachelor of Science, and Bachelor of Arts programs. It also offers masteral and doctoral programs, offering those who choose to go on for higher education the chance to do so. The university's colleges belong to several national professional organizations, allowing our students to network with the best local minds in their particular field of choice. Beyond all these, some of Adamson University's degree programs have been recognized by the Commission on Higher Education as centers of development. In 2010, ADU passed the IECEP and received autonomous status from CHED. The university has always received an entire roster of certifications and awards.
There's much to be proud of, but at the heart of all this theory and practice is the true heart of Saint Vincent de Paul, our patron saint, a heroic yet humble man who devoted his life to the service of the poor. Following in his footsteps, we are trying to cultivate Adamsonians who will develop the virtue of using their talents to serve others. We are creating young Filipinos whose powerful faith allows them to freely and completely share their strengths with others, especially those in need.
In 1964, the Adamsons turned the university over to the Congregation of the Mission, also known as the Vincentians, whose mission is to evangelize the poor. While Dr. George Lucas Adamson remained as president for 3 more years, the school became a Catholic university, imbibing the spirit of St. Vincent de Paul in its teaching its students and academe, sensitivity to the presence of God, compassionate service, and the building of supportive relationships towards an effective service to persons in need. As such, Adamson University has one of the most affordable tuitions for a learning institution of its caliber, as well as numerous scholarships given out each school year. The school and its students are also recipients of the grants from several local and international foundations. But here, academic skills are not the only way to get a scholarship. ADU offers scholarships to its athletes, ADU Chorale, Band, and Pep Squad, with the intent to show that while academics are necessary, they are not the only way to get ahead. Based on the teachings of St. Vincent de Paul and the many presidents that have been at the helm of this illustrious institution for decades, there are 3 attributes that define a true Adamsonian.
You have competence when you are able to produce outputs based on the learnings that you had in the classroom. This is an education which many others can only dream of, but I am actually experiencing. We need to develop our creative and critical thinking, our fluency and articulateness, and also our lifelong learning. We really need to become up to date with technology because our generation as well as our businesses are slowly becoming tech savvy. We need to focus on both theory and practice. And in this way, we will become well-rounded Filipinos and we will make our university proud.
One of the theses of Adamsonian attributes is character. Mingled, of course, with the academics we offer here at ADU, we also strive to build our students' character via network and leadership, via the Adamsonian identity and integrity as well, by commitment to social transformation, by developing patriotism and, of course, a universal outlook, and by learning to care for the environment.
And lastly, charity. This will be guided and powered by our faith in God and the spirit of Saint Vincent de Paul. An intense love for learning and an equally intense love for the poor. As high as the falcon soars, that is how high we dream our students will soar as well. Because with them, the nation will fly higher.
Maraming pangarap ang umusbong mula sa mga simpleng tanong. Mga tanong na humantong sa pagtuklas, inspirasyon, at paglalakbay. Matagal na nating tinutuklas ang kalawakan. Marami na rin tayong natuklasan dahil sa pagmamasid mula sa kalawakan. Ano na ba ang lagay ng panahon? Saan at kailan kaya tatama ang bagyo? Ano na ba ang kalidad ng hangin na ating nilalanghap? Pero mas malawak pa ang gabay na pwedeng manggaling sa kalawakan. Dahilan kaya tayo naglalagay ng infrastruktura at patuloy na kumukuha ng impormasyon sa ating planeta. Gabay tungo sa pangarap na makabangon at magkaroon ng mas maunlad na hinaharap katuwang ang agham at teknolohiyang pangkalawakan. Pangarap na abot tanaw na sa pangunguna ng Philippine Space Agency o PhilSA. Itinatag noong 2019, ang PhilSA ang magtataguyod ng mga programa para tiyakin ang payapang paggamit ng kalawakan upang pangalagaan ang pambansang seguridad at suportahan ang ating pag-unlad. Bantayan ang kalikasan at tiyakin na makakaiwas tayo sa peligro ng mga sakuna at nagbabagong klima. Paigtingin ang pagsasaliksik at paggawa ng mga bagong teknolohiya. Suportahan ang pagsibol ng mga bagong industriya at pagsigla ng ekonomiya. Palawakin pa ang edukasyon at kaalaman ng publiko tungkol sa kalawakan at makipagkaisa at makipagtulungan sa iba pang mga bansa. Tinatahak na ng Pilipinas ang landas tungo sa makabago, mas ligtas at mas masaganang buhay para sa mga Pilipino gamit ang agham at teknolohiyang pangkalawakan. Isang karangalan ang pagkakataong maging bahagi ng paglalakbay na ito. Isang karangalan na isulong at panatilihin ang matatag na pangkalawakang komunidad na magpapahalaga sa mga mithiin ng mga Pilipino sa buong mundo. Isang bansang masagana, nakakaangat at may kakayanan, katuwang ang payapang paggamit ng kalawakan.
When the Philippines began building satellites, we started small. As small as a suitcase. Yet the stakes were high and the challenges were great. After the success with 6 of these small satellites, the Philippines is ready for something bigger. In December 2020, the Philippines kicked off the Multispectral Unit for Land Assessment, or MULA satellite project. Weighing around 130 kilograms, MULA will carry a true color camera that can capture higher resolution images, covering around 73,000 square kilometers of our country in one day. Data from MULA satellite will be used for addressing food security, disaster resilience, environment conservation, and protecting our national sovereignty. The Department of Science and Technology jump-started the funding of MULA. The project was jointly implemented by the DOST, Advanced Science and Technology Institute, and the University of the Philippines, Diliman, in coordination with the Philippine Space Agency, or PhilSA. 16 Filipino engineers who underwent a know-how training and transfer program in the UK are involved in building the satellite and are now part of PhilSA. The training capacitated our homegrown engineers, not just with knowledge, but the license to build more local commercial satellites in the future, leading the way for the creation of a robust and thriving space industry to support the country's space program. PhilSA will oversee the completion and launch of MULA and manage its operations. MULA in Ilocano means plant, pointing to the satellite's mission on food security. In Tagalog, it means point of origin or beginning, which symbolically signals the Philippines' foray into a new era in satellite development toward the vision of a nation bridged, uplifted, and empowered through the peaceful uses of outer space.
Hello, kamusta? I am Naoko Yamazaki, a former Japan Aerospace Exploration Agency's astronaut. I visited the International Space Station in 2010, and my background picture was taken at that time. I am so delighted to receive many questions from Filipino children, and I'm happy to answer.
Hello, my name is Aaron Wayne S. Mendoza. I am 10 years old and I study at Seria Osmeña SPED, Olongapo City. I have 3 questions. Question 1. How are black holes made? Question 2. How long does it take to go to the moon? Question 3. Where do auroras come from? Thank you and God bless.
Hi, Aaron. Your questions are, how are black holes made? Well, each star has its own life. When giant stars, which are much bigger than the sun, terminate their lives, they get so much pressure due to the gravity, and they become black holes. I do not have a detailed answer, but if you are interested, I'd like to encourage you to keep studying astrophysics, which is very interesting. And how long does it take to go to the moon? It takes about 3 days to get to the moon. So if you want to make a round trip, it takes about a week. And where do auroras come from? Auroras come from the Earth's magnetic field, which get high energy particles from the sun. So auroras happen due to the reaction from the solar energy and the Earth's magnetic field. I saw auroras many times in space, and which are very beautiful.
Hi, I'm Anton Rutuya and I am 11 years old. I am looking to be an engineer when I'm older, with the intentions of building spaceships and maybe even space stations. So, can you tell me, from what you know, how far away are the space industries such as NASA from building artificial gravity on spaceships and space stations? Also, what subjects do you believe I have to study to achieve my goals? I'm looking forward to hearing back from you. Thank you.
Hi, Anton. Your questions are, how far away are space industries such as NASA from building artificial gravity on spaceships and space stations? You know what? On board the International Space Station, there is already an artificial gravity facility, which are not for human beings. It's much smaller. It is for mice. But Japan experiment module has the artificial gravity facility for mice, and it can generate up to 2Gs by centrifugal force by rotating the facility. And the good thing about artificial gravity is we can make any gravity up to 2Gs, which means we can create a 1/3 of gravity on Mars, or we can create 1/6 gravity on the moon. So we can, conduct various experiments changing the gravity in space. And what subjects do you believe I have to study to achieve my goals? If you are interested in space or astronauts, I'd like to, study STEM field, any field in STEM, because my background is engineering, but some of the astronauts are from medical doctors or pilots or researchers or so many, variety of fields. So any field, if you have some specialty, which is very helpful for you to pursue your career. So never give up, just keep going on. Good luck.
Mabuhay, Noguchi-san!
Hello, astronaut Noguchi.
Astronaut Noguchi. Hi, astronaut Noguchi. I want to be an astronaut someday like you.
Magandang araw!
Hello, astronaut Soichi Noguchi. One day, I think I want to be an astronaut just like you. Hi, astronaut Soichi Noguchi.
I wish I have a chance to meet you in person.
Hello, Mr. Soichi Noguchi. Hi, Mr. Astronaut Noguchi. Konnichiwa, Soichi-san. Daijoubu desu ka?
I hope you can continue your work safely on the ISS.
Make sure stay safe from the virus while the rocket is flying. And make sure you stay healthy too. Hi, astronaut Soichi. O genki desu ka?
Hello, magandang tanghali po. Konnichiwa. My name is Soichi Noguchi, Japanese astronaut. I just returned from the International Space Station after a 6-month stay. This was my 3rd flight and my 3rd different spaceship. And during my stay, I was fortunate to do my 4th spacewalks. And I established 2 Guinness World Records. What an experience. Now I am glad to talk to our friends in Philippines. I had many chances to see your beautiful islands from the International Space Station. I posted a few photos on my Twitter and hopefully you have seen them.
I think your picture is beautiful and I hope you're safe from asteroids and meteors. Thank you for the picture of the Earth.
I really like how you took the picture of the Philippines. This is where I live and this is where my grandma and grandpa lives.
I hope I can meet you soon.
When we be best friends, maybe I'll take me to the moon sometime. Please.
I received many comments and questions from children from Philippines. There were too many to answer today, but hopefully I can visit Philippines in the near future and talk to the children in person. Now, the COVID-19 has confined our activities on Earth to a greater extent. I, however, strongly believe that we can overcome the difficulties if we can all put together and try to preserve Earth for future generations. Thank you very much for the people of Philippines for great attention. Salamat po, paalam na po. Thank you and goodbye.
Dambate Rizal. Your name rhymes with Tamagotchi. Bye, astronaut Suichi Noguchi.
I'm excited to have joined Advanced Energy during this landmark year, our 40th anniversary as a global power solutions leader. Our celebration highlights two key factors that differentiate AE. First, our innovation in precision power, conversion, and measurement. And second, the talented people who make this possible. It's an incredible story. Doug Schatz, Advanced Energy's co-founder, the first of many people at Advanced Energy to dream big, initially made power supplies in his home. Over the years, we have grown by developing leapfrog technologies that exceeded customer expectations. R&D has powered our business, and it still does. Worldwide, we have built a thriving ecosystem of global design centers and manufacturing facilities. Our ultimate goal is to deliver high-quality, best-in-class products and services to our customers. In recent years, we've grown rapidly, both organically and through acquisition, including Artisan Embedded Power in 2019. Today, Advanced Energy is the clear global leader in precision power. Our products are critical enablers for some of the most advanced manufacturing processes in the world. And our products help to power critical industrial, medical, data center computing, telecom, and networking equipment. With years of groundbreaking technology and strategic partnerships, you might think that tells the full story. But when you ask why Advanced Energy, customers talk about our people and the exceptional customer experience we deliver. We listen, we innovate, we collaborate, and we're passionate about our customer success. Today, at 40 years of age, we have over 10,000 employees, and we're growing. Our can-do culture, our deep technical expertise, and our collaborative approach to problem solving make Advanced Energy a great place to work. To kick off our celebration, I'd like to extend a heartfelt thank you to our employees for their commitment, talent, and passion, to all that you have built over the past 40 years. To our suppliers, thank you for your continued partnership and your support. And to our customers, you're the reason we're here, and we're committed to your success. And finally, to our long-term investors, thanks for your support over the years. For 40 years, Advanced Energy has been a proven power solutions leader. Now our innovative precision power conversion and measurement solutions are at the center of the fourth industrial revolution. We truly power the future. Thanks to all who have made it possible. And here's to 40 more years of growth and success.
Advanced Energy powers the world around us by providing the precision power products required to manufacture and test many high-tech and industrial products, and many common household items that are ingenious in their own quiet way. Manufacturing the things we use and encounter each day requires an unbroken chain of innovation that begins with specific applications of power. With our precision power products, there's no room for error. And there's no comparison to our expertise at finding new ways to make the production, testing, and shaping of materials simpler, more reliable, and more affordable. Our purpose is to enable the innovations of our customers, so they in turn can meet the needs of their customers. Around the world, at home and at work, products made with advanced energy power are everywhere. From the thermal control products we provide to heat glass and steel, and the power needed to apply thin protective films to architectural glass. Manufacturers rely on our high and low voltage systems to deliver impressive performance and accuracy across a wide variety of modules and applications. No matter how complex the technology, our innovations are dedicated to helping our customers develop products that improve the lives of their customers. We even provide power for lasers used in laser eye surgery, electrosurgery, and cosmetic medicine, and the high voltage pulses needed for defibrillators and lasers to break up kidney stones. The power for mass spectrometers used in drug, water, and food testing, and in clinical and laboratory testing. As our customers innovate, we work to transform the future with them, wherever they are in the world. This makes our innovations global and personal. Precision, power, and performance. These words define our dedication to shaping and transforming power, and to doing our part to make each day a little more magical than the day before.
Okay, hello. Hello.
Hello, brothers. I think we can't hear you. Good afternoon, Dr. Su.
Hey, hello. Good afternoon, everyone.
Thank you very much for coming. Let's just wait for the moderator. I think there's something wrong with his audio. Thank you.
Okay, sure.
Hey, loud and clear.
Yes, Engineer Ross, I can hear you now.
Okay, thank you very much. Engineer Su, just stand by. We will give you the cue to start. Okay, let's go ahead now. My professional colleagues, to our subject specialists, yes, and my dear students of different universities and colleges, I would like to extend a warm welcome to the afternoon session of the third colloquium. Before we commence this session, I'd like to pose a simple question to everyone in this digital environment. This is the question. Do you believe why is knowledge a power? Think about it. In my own personal research, knowledge is power. Why? Because it's allowed us the ability to influence what people do and how they act. This means, in a simple word, knowledge helps shape society positively and which benefit everyone. Hello, everyone. Good afternoon, Philippines, and good morning, Middle East. As well, good day to everyone on us across the world. At this afternoon event, we will present three phenomenal speakers. They will share their technical knowledge with us, and I can assure you that we will learn a lot from these speakers. Fellow audience, attendees, virtual attendees, test mic. Okay, I'm clear now. I was out. Okay,
Yes.
I would like to ask. Okay, let's ready to rumble. By the way, this is our PM session. We will start now for our webinar for our first topic. Now, without further ado, I would like to call Engineer Alvin de Guzman of IECEP Mindoro Governor for the introduction of the resource speaker. Engineer Alvin, are you with us?
Hello, actually there's a mix up. Bale,
Yes.
it's me, Engineer Gerald Chokson, who will be introducing
Okay,
our
sorry for
dear.
that. Thank you for the reminder. Engineer Toxon, are you with us?
Yes, I'm here.
Wow, thank you very much. By the way, before I will proceed, I would just call in my co-host, Engineer Donna. Are you with us now? Because Engineer Donna, by the way, they have troubleshooting with the internet connectivity. I'll do just to call in. Engineer Donna, one more time, please acknowledge. So, second call, Engineer Donna. Are you still with us? Engineer Donna, by the way, is my co-host for this afternoon session. So, while waiting for Engineer Donna, let's proceed for the webinar topic for this afternoon. So, okay, let's do it. Okay, Tucson, the e-space is yours.
All right. Thank you for the warm introduction. Engineer Russ, I like your hat, by the way. All right. So for our first speaker this afternoon, he received the Bachelor of Engineering and Masters of Engineering degrees in Guangzhou, China in 2008 and 2011, respectively, and the PhD degree from the University of Newcastle, Callaghan, New South Wales, Australia in 2013. He performed postdoctoral research with the University of Sydney and then joined Nanyang Technological University, or NTU, Singapore with Nanyang Assistant Professorship. He is currently an associate professor with the School of Electrical and Electronic Engineering, and also the cluster director with Energy Research Institute at NTU, Singapore. His research interests include power system stability and control, microgrid, and data analytics for smart grid applications. He is the editor of several international journals, including the IEEE Transactions on Smart Grid, IEEE Transactions on Power Systems Resource Site, IET Generation, Transmission and Distribution, and IET Energy Conversion and Economics. And he is also the chairman of IEEE Power and Energy Society Singapore chapter. Okay, everybody, let us welcome Dr. Yan Xu.
Thank you. Thank you, Chairman, for your kind introduction. Hello, good afternoon, everyone. This is Yan speaking from Singapore. It is my great pleasure to be here and share some of our research works on the distributed energy resources in microgrids. So let me share my screen. Can you allow me to share screen? Okay. Can you see the screen now?
Yes, go ahead, Engineer Su.
Okay, sure, great. Okay, so today my topic is coordinated operation and planning of distributed energy resources in microgrids. This is the outline of my presentation. So first of all, I will give you a general introduction to our microgrid demonstration projects in Singapore, which is called REITs, standing for Renewable Energy Integration Demonstrator Singapore. This is one of the largest microgrid demonstration project here. So I will introduce the general backgrounds, general information to you. If you are interested, you will be very welcome to visit us when you travel in Singapore. And after that, I will introduce our research works on the operation and the planning of the DER units. And for the operation, I will talk about the energy dispatch as well as the voltage regulation for the microgrid with the DER units. So the time scale we are looking at ranging from the several minutes to hours. So generally it is a dispatch interval. And after that, I will talk about some methodologies for optimal planning of the DER units in the microgrid. Specifically, we are looking at the distributed generation units, including the solar PV, small wind turbine, as well as diesel generators. And also we are looking at the energy storage systems placement in the microgrid. So the time horizon we are looking at ranges from years to decades, so which is a planning time horizon. Okay, so first of all, let me give you some general background information about this microgrid project, so-called REITs. So since 2017, our university has been leading this microgrid demonstration project in an island called Semico. So this REITs is a research and development platform focusing on the designing, demonstrating, and testing solutions for DER technology as well as microgrid technology. So our objective is to promote this technology to Southeast Asia region based on this demonstration. So here you can see that this is a map for Singapore. Unlike Philippines, Singapore is a much smaller island country. So from the east to west, that is about 45 kilometers. From the north to the south is about 35 kilometers. So here you can see that we do not have high voltage transmission grids. So all of our grid are actually at the medium to low voltage distribution level. So here you can see this is our university, Nanyang Technological University, NTU. And this is a so-called Micro Island where we are developing this microgrid project. So this is a micro island. It is actually a landfill island. We are given 64,000 square meters to develop these microgrid projects. And this is actually an industry-oriented project. This is an industry-oriented project. We have a lot of industry partners. As you can see, they come from multinational companies as well as the local companies. And the whole project is funded by our government agency, including the Economic Development Board, EDB, National Environmental Agency, NEA, Energy Market Authority, EMA, as well as the National Research Foundation, NRF. So in total, we have about 20 industry collaborators to host and to invest and operate this microgrid system. Now here, this is a general framework of the microgrid system we are developing. So basically, it is networked hybrid microgrid systems. We have two phases. The first phase has already been completed. We have installed 4 independent microgrid systems. Each has a capacity of 500 kilowatt to 100 megawatt. And the second phase is ongoing. We are developing another 4 microgrids in a cluster configuration, which relatively smaller capacity, ranging from 100 kilowatt to 250 kilowatt each. And all of these 8 microgrids will be interconnected as a networked microgrid system. Well, if you look into each of the microgrids, we have a mix of different generation resources. We have a diesel generator, solar PV panels, the small wind turbine, as well as some tidal turbine generators. And in terms of the energy storage system, it is also a mix of different technologies, including the lithium-ion batteries, supercapacitor batteries, supercapacitor energy storage, flywheel energy storage. We are also installing the power-to-gas device to convert the power into the hydrogen. And also we have this fuel cell to convert hydrogen energy to back to electricity. And for the loads, we have the on-island loads from the residential, commercial, and other load simulators to emulate the whole microgrid system. As already mentioned, this is the industry standard microgrid system. So each microgrid is built, invested, and operated by our industry collaborators. So here you can see that we have different partners from different sectors. For the renewable generators, we have several companies investing the solar panels, small wind turbine, as well as tidal energy. While for the energy storage system, we have companies from Japan, from Europe, as well as the local companies. They are investing the energy storage systems, including the batteries, supercap, flywheels. And we also have diesel generator suppliers from a Rolls-Royce, as well as ENGIE, a French company. They have installed the diesel generator in this microgrid system. And in terms of the control of the whole system, we have a control system supplier from different companies with a different focus. Some of them are focusing on the frequency control. Some others are mainly focused on the energy dispatch. And also we have electrical vehicles demonstration and in collaboration with some vehicle manufacturer companies. And we also have some software system management software for visualization and data analytics. We are also investing on this part. Okay, so if you are interested, you can go to this website for more information. Okay, then this is the general electric structure of the whole microgrid system. As already mentioned, we have a total of 8 sub-microgrids, and they are all interconnected through this 6.6 kilowatt feeder, okay, then supplying the load to through the 66 to 400 transformer. Okay, then each of the microgrid is owned by the industry collaborator. So our university is now running the microgrid 0, okay, microgrid 0. And you can refer to this publication for more details about this system. Some on-site pictures. Here you can see the solar panels, the diesel generator, and this is energy storage system, and also a small wind turbine. I'd like to highlight that Singapore does not have wind resources because we are located in the equator part. So this wind turbine is actually the first and the largest wind turbine of the whole country. It is mainly for the research and development purpose. It's actually not for generating power because the wind resources is quite limited here. And this is the tank for the diesel generator. We also have some small meeting rooms and some other places for hosting the visit. Okay, so this network, the microgrid system, provides us a comprehensive platform for research and development, as well as to collaborate with the industry partners in the microgrid and the distributed energy resources technologies. Well, in my research group, we are mainly focusing on the system level coordination of the DR units in the microgrid. And we are developing, you can see here, this is our general research framework. Specifically, we are considering 3 types of the DR units. The first one is the flexible load, which has a certain of the flexibility to respond to the grid control signal, such as the demand response, such as HVAC units, as well as the smart building. All of them will have a flexible power demand dispatchability. Okay. And second one is the energy storage system. We consider lithium batteries, supercapacitors. Both are electrical ESS. And besides, we also consider the thermal energy storage that can store the heating and the cooling energy to supply the thermal load. And the third one is the distributed generators, including the renewable energy based, such as the solar and the wind turbine, as well as the controllable units, such as the micro turbine, combined cooling heating plants, which can simultaneously generate the electricity and the thermal energy. Okay, so this is the 3 types of the DR units. Well, the specific research problem we are looking at cover the full spectrum of the microgrid control and planning, control, operation, and planning. So at the milliseconds to seconds time level, we are looking at the control of the frequency and the voltage. So basically, this is implemented in the primary and the secondary control of the system. While in the operation time interval from minutes to several hours, we are looking at the optimal dispatch of the energy, as well as the optimal voltage and reactive power regulation. Okay, so this is at the operational stage. While at the planning stage, from years to decades, we are looking at the optimal allocation of the DER units, including the optimal sizing of the units, as well as optimal siting of the units in the network. And the specific methodologies for the control problems, we are developing different controllers under different control architecture, including the centralized control, decentralized control, as well as a distributed control. Okay? While in order to validate the performance of the controllers, we have also been doing the hardware in the loop test, okay, to study the actual impact, actual performance of the controllers. And in terms of the operation of the microgrids, essentially it is an optimization problem. However, because of the renewable energy resources, as well as the load demand fluctuations, the optimization problem is integrated with the uncertain parameters. So we need to make optimal decision under the uncertainty. So here we are developing robust optimization methods, stochastic optimization methods to cope with the uncertain parameters. And besides, we are also developing distributed optimization, which is to share the information among the DER units without the need for a centralized coordinator. That is for the operation problem. Well, for the planning problem, essentially, it is also an optimization problem. We need to make the best investment decision. And also, we are faced with uncertainties from the short-term operation time period to the long-term operation period. So we are also developing the robust optimization and stochastic optimization-based method to make the best decision on DER sizing and siting. And besides, we have also developed a hybrid algorithm combining the robust and stochastic algorithms together to make a better decision making for the long time horizon. Okay, so this is the general research framework. And because of the time limitations, so today my topic, my presentation will only be limited to the operation and planning of the DER units. While for the DER control, actually, I have another PowerPoint slides with over 60 pages. So that will be not introduced today because of the time limitation. Okay, then next I will introduce our specific works on the operation of the microgrid. So generally speaking, the operation of the microgrid can be divided into the energy dispatch and the voltage regulation. So for the energy dispatch, we are mainly focusing on the real power. Okay, we are going to dispatch the real power output of different resources in order to minimize the total cost, operation cost, or maximize the total revenue of the microgrid. While for the voltage regulation, the dispatch variables will be the reactive power resources, right? Such as the capacitor banks, the unload tap changers of the transformer, as well as the solar PV inverters, okay, because the inverter can also provide reactive power support. But for the energy dispatch, we basically are looking at the controllable real power resources, including the micro turbine, energy storage, and the demand response. And in terms of the parameters of the whole problem, we have the load demand, the wind and the solar power output, electricity price. All of them should be forecasted beforehand. However, you can see that all of these three parameters are highly uncertain and stochastic, especially for the renewable power output. So we need to consider the randomness and uncertainty into the whole problem. That's why we need a stochastic and robust optimization algorithm. And for the network, we have their electric parameters, right? The resistance, reactance, and the capacitance. And for the state variables, we have the bus voltage, the branch power flow, and the power exchange between the microgrid and the main grid. And in order to model the whole network, we need to have a tractable power flow model. So in our research work, we are mainly using the linearized distribution flow or the second order comprogramming model to characterize the power flow of the network. Okay, so this is a general problem description for microgrid operation. Well, traditionally, if you are familiar with the relevant literature, you will find that the distributed energy resources are generally dispatched in the same time scale. Let's say every half an hour or every hour, we will set the power output setting points to the equipment. And this is called a single stage dispatch. However, you can see that the drawbacks is that no matter 30 minutes or 1 hour, we cannot cope with the uncertainties from the load and the renewables during this dispatch interval. Okay, and also different DER units, they have clear different characteristic. For example, the diesel generators. If you compare diesel generators and the demand response, clearly the diesel generator may have a much higher response speed, because for demand response, we need to notify the customers given a certain lead time for them to respond. And also, if we compare the diesel generators with the energy storage system, clearly the ESS has a limited capacity. Okay, so it cannot charge or discharge for long, subject to its capacity. So we need to consider all of these different characteristics when we operate the system. So this will motivate us to develop some multi-stage coordinated operation approach. The objective is to coordinate different DER units in different time scales. Okay, so here you can see that this is a basic two-stage coordinated optimization approach. So basically we have two stages. The first stage is to dispatch the relatively slower responding DER units in a longer time scale. For example, hourly ahead or day ahead. Okay, which means in every hour or every 24 hours ahead, we will set the power output setting points to the equipment. While in the second stage, we are dispatching the faster responding or more flexible DER units in the short time scale. For example, every 15 minutes or every hour, okay, within a day. Now, this second stage aims to make use of the faster responding or more flexible DER units to cope with the uncertainties from the renewables and from the load. Okay, so by coordinating the two stages together, we can firstly deal with the uncertainties, and secondly, we can consider the different characteristics of the DER units. Well, for the practical implementation, as long as the first stage decisions are met, they will be implemented directly for the whole operating time horizon. Okay, and they will be fixed in the second stage. While for the second stage, the decisions will be re-optimized and implemented after the uncertainty realized. So specifically, during the day or during the hour, we will continue to predict the uncertainties, including the renewable power output, low demand, every 15 minutes or every 1 hour ahead. So the short lead time forecasting will certainly have a higher accuracy. Okay, so based on the latest forecasting, we will re-optimize the second stage decisions. So the two stages are coordinated in such a way that the second stage is actually a recourse action to compensate the imperfect decision from the first stage. And the two stages are actually coordinated mathematically through a two-stage optimization model. And talking about the mathematical model, so basically they can be divided into the stochastic programming model or robust optimization model. Well, there are some differences between the two methods. In terms of the uncertainty modeling, stochastic programming is based on the probabilistic scenarios through sampling from a probability distribution of an uncertain variable, while the robust optimization relies on an uncertainty set to define the upper bound and the lower bound of the uncertain variable. Okay, so correspondingly, the input to these two algorithms is the point forecasting for stochastic, while the interval forecasting for robust optimization, right? Then in terms of the mathematical models, you can see that the stochastic optimization is to optimize under the expectation of the objective function over the uncertain variables. Okay, so this E denotes the expectation. Okay, so here you can see that we have two objectives. The first one corresponds to first stage, while the second one corresponds to the second stage. So they are summed up together during the optimization process. But the robust optimization is to optimize under the worst case of the uncertainty. So here you can see that we are actually maximize the objective function in order to consider the worst case when the uncertainty happens. Now, advantages for stochastic programming is a relatively simpler mathematical formulation and the solution process. But the disadvantage is that we need to have the probability distribution function, which is sometimes not available in reality. Or the probability distribution is also a time-varying model, which is difficult to obtain. Okay? And besides, since we are optimizing under the expectation, so it can only guarantee the probabilistic satisfaction of the constraints. In other words, it can only give a probabilistically robust decision. While the robust optimization is to optimize under the worst case, so it can guarantee that the solution is always robust against any realization of the uncertain parameters. Okay. However, a drawback is that this may be conservative. In practice, maybe we do not need to have this 100% robustness. And besides, the robust optimization has a more complex mathematical model and more difficult solution process. But unlike the stochastic programming, we don't need the PDF. We are just using the interval forecasting to model the uncertainty. Okay, so that is a comparison between the stochastic programming and the robust optimization techniques. Now, next, I would like to briefly introduce some of our representative works in this area. Okay, the first one I would like to introduce is two-stage coordinated demand response and the diesel and the microturbine dispatch in the power grid. Okay, first of all, let me introduce the principle for price-based demand response. By its name, this demand response is based on the price signal. Okay, in other words, in reality, the power utility company can notify the electricity price of the next, let's say, next time period, next 1 hour or next day to the customer. After receiving the electricity price of the next periods, the customer will adjust their power demands according to the price. Okay? In practice, there is a so-called price elasticity that can reflect the relationship between the demand and the price. So clearly, this is actually a exponential, negatively exponential relationship between the price and the demand. Okay, and if a utility company want to increase the load, they will set a lower price. And reversely, if you want to reduce the load, they will set a higher price. Now, the relationship is modeled by this price elasticity. Okay, you can see that the base case, if we have the base electricity price, we have the base load. Now, if we increase the price by 10%, you can see that the load will reduce by 2%. And if we increase the load by 20%, you can see the load will reduce by 3.8%. Okay, and reversely, if we reduce the electricity price by 10%, then you can see the load will increase by 2.3%. Okay, so the key is to model this the price elasticity value epsilon. Okay. Okay, according to our previous study, this number is minus 0.38 in Australia. Okay, while in Singapore, our students are doing the customer survey to obtain this value. Okay. Now, based on this relationship, you can see the utility can indirectly change the power demand by setting different electricity prices. Now, our idea is that to operate the whole microgrid through setting the optimal electricity price, as well as dispatch the micro turbine in order to balance the total power demand. Now, here we have designed a two-stage operation framework. Okay, so the first stage is to dispatch, is to optimize the price in one day ahead. And after we optimize the electricity price within every hour of the day, we will redispatch the micro turbine, okay, in order to satisfy the total load demand. And these two stages are coordinated through this two-stage robust optimization model. Okay? The objective here is to minimize the total profit, to maximize the total profit of the microgrid while considering the electricity, the revenue from selling electricity to the customer, as well as the operation cost from the micro turbine, solar power, wind turbine, as well as the power purchasing cost from the grid. Okay? And here you can see that we are optimizing under the worst case. So we are maximizing the worst, and we are maximizing the second stage objective, considering the worst case of the uncertain variables. U here. Now we are modeling three types of the uncertain parameters. One is from the wind turbine, one is from the solar PV, and another is from the load. That is because in reality, not all of the load will respond to the electricity price, because some loads, some customers, they may be price sensitive, while some others may not be sensitive. So you also need to model this type of uncertainty from the demand response rate. Okay. And also, in reality, we have to ensure that the electricity bills for customers after this price-based demand response does not exceed the original bills. In other words, we should restrict that by setting the electricity price, the benefit of the customers is not affected. Right? So we will also need to model this requirements in these constraints. Finally, you can see that the whole problem is modeled as a mixed integer linear program. And after some mathematical precision, then we can solve this model to get the solutions. Now here you can see some simulation results. This is the forecasted load demand, not load demand, the forecasted wind power output and the solar power output in interval. Okay, so you can see we have predicted the upper bound and the lower bound. And this is the dispatch results. This is the dispatch, okay, this is the day ahead dispatched results and the comparing the load curve before the demand response and after demand response. So you can clearly see the difference here. In the off-peak during the night period, we are actually encouraging the customer to use more power. Okay, so use more power. So that means the price here during this period is set smaller. While during the noon period, when the solar power has the highest power output, we actually are also encouraging the customer to use more power. But during the evening period, when the solar power's output drop to zero, we actually disencourage the customer to use the power. Okay, so in other words, through this electricity price setting, we are actually shifting the load curve of the day. Okay, we are trying to shift the load curve in order to use as much as possible the solar PV. And we have also considered our, tested our solutions under the uncertainties. Okay, we have set different uncertainty range for the wind turbine, solar power, and the demand rate. And we check the feasibility as well as the obtained solution results. You can see that the robust optimization can beat the single stage operation significantly. Okay, so they can also ensure a high rate for the voltage and operation constraint satisfaction. Okay, so this is the simulation results. Now, if you are interested in the more details, please refer to this paper. And this paper has been listed as a highly cited paper since 2018. Now, in addition to the electric network, nowadays, our power grid is also interacting with other energy carriers, such as the thermal energy, including the heating and the cooling. So if we develop a microgrid with different types of the energy, electricity and the thermal, we can have this so-called multi-energy microgrid. Okay, multi-energy microgrid. You can see that the idea here is that we have the electric network there, and in the meantime, we have the thermal and we have the thermal network supplying the cooling and the heating load. Well, we have a coupling unit called CCHP, combined cooling and heating plants to supply simultaneously the electricity and thermal heating as well as the cooling. Okay, through the heat recovery unit and the assumption chiller. And also we have an electric boiler, electric chiller to produce heat and the cooling in the meantime. And for the original electric microgrids, we have our battery energy storage. We have a solar power, wind power. And besides, we also have the thermal storage, the heat storage tank, and the ice storage tank. Okay, so the problem here is to optimally dispatch this multi-energy microgrid in a coordinated way. Now, in order to do the multi-energy microgrid dispatch, the first step is to model the grids, including the network and their components. So here we need to model the district heat network. You can see that we need to consider the thermal transmission, thermal energy transmission, and the insulation of a pipe. Okay, and also we need to consider the load, the thermal load, including its conduction and insulation. Okay, and then we couple the thermal network and the electric network together to make a multi-energy microgrid. Okay. And more details can be found in our publications here. And after the modeling, we should operate the system in a coordinated way. Clearly, the different energy carriers, they have different characteristics in terms of the energy inertia and the response speed. So it's quite sensible for us to integrate them as a coordinated operation framework. So here you can see that we are still using a two-stage operation framework. In the first stage, we dispatch the thermal energy units because they have a relatively slower response speed. And in the second stage, we dispatch the faster responding units because they are faster than the thermal energy. And this is the detailed mathematical models, including our objective functions, constraints. Okay. So here, the model is based on the stochastic optimization. So you can see the second stage objective is expectation. Okay. Now, the whole framework in the first stage, we are dispatching the on and off status of the CCHP unit, as well as the electric boiler, and also the discharging power of the energy storage system, and taking the inputs of the load demand, renewable power output, and system parameters. And in the second stage, we will dispatch the power output of these controllable units, including the output of the CHP and the electrical boiler, taking the updated forecasting of the electricity price and the renewable power output. Okay, the two stages are coordinated through the stochastic programming. Now, this is the dispatched results for day ahead, and this is the intraday dispatch result. Okay. And we have also compared our approach with a traditional single-stage deterministic optimization and single-stage stochastic optimization. Now, clearly, our method can outperform them quite well. We also compare with the two-stage deterministic optimization. So clearly, our method can outperform them significantly in terms of the average cost as well as the voltage violation. Okay, we can not guarantee we can achieve a zero voltage violation, while in the meantime have a smaller operation cost. So please refer to this paper if you are interested in the methods here. Now, after the energy dispatch, another operation problem is on the voltage regulation. Okay, the focus is to dispatch the reactive power resources to manage the bus voltage. Okay. Then clearly, because of the integrations of the solar power, the power fluctuation from the solar panels can also fluctuate the bus voltages because for low distribution network, the resistance over reactance ratio is much higher. Okay, so real power will also affect the bus voltage. So traditional voltage control devices such as capacitor bank and transformer, they are all mechanical. So they cannot respond fast enough to the solar power output fluctuation. So here we need faster responding device. Now in our research, we are considering to use the inverters of the solar PV to provide the reactive power support. Now, based on the different responding speeds of the traditional device and the inverters, we can also design this two-stage coordination framework. In the first stage, we dispatch the capacitor banks and OLTCs every hour. And within every hour, we can dispatch the solar PV's inverter to provide the reactive support. And these two stages can be coordinated either through stochastic programming or robust programming. Okay, and this is how this is the process for modeling the voltage control problem to the mathematical problem. Okay. For more details, you can refer to this paper. Okay, and this is some general formulation for the objective function, and this is to sample the stochastic scenarios in order to approximate this expectation. Okay, then finally we can convert the stochastic model into a deterministic model, and this is the probability distribution of the forecasting area. And this is the simulation result. You can see that our objective is to minimize the total power loss of a day. And this is the optimized results for the first stage, the OLTC's tap position, capacitor banks position. And this is the output dispatch for the second stage, the reactive power from the inverters. And this is the voltage profile of two representative buses. You can see that they can always satisfy the operation limit within plus minus 0.5 per unit. Okay, see, the voltage regulation is also a very popular topic for the microgrid, especially because of the potential of the power converters. So since this seed work, we have continuously developing new methods for the inverter-based voltage control. You can see that this is our trajectory of the whole research. Since 2017, we have further developed a 3-stage coordinated approach, hierarchically coordinated approach, the multi-objective approach, and also we consider the reliability of the PV inverters and also the voltage stability into the control. Okay, so if you are interested, please have a review, have a look at our publications. Okay, then the last session will be on the planning of the DR units. Okay, the problem is to optimally allocate the DR units, including the distributed generators and energy storage systems into the network. Okay, essentially, this is a decision-making problem, right? We need to decide the type of the DG, the size, location of the DG, as well as the investment timeline. Okay. Mathematically, we need to, our objective could be the minimization of the total investment cost plus the expected operation cost. And constraints including the operation limits, network constraints, and component constraints. All right. The variables include this size, site, type, installation here. Okay. And because of the uncertain parameters, we may also need the optimization algorithms under uncertainty. Right. Now here is a general review of the existing, a general review of the DR planning framework. Okay, so we have the deterministic input and uncertain input. The uncertain input come from the renewable power output, the low demand electricity price in the future time horizon. Right, then in practice, we have 2 stages. First one is the investment stage. That is to decide the site and size, as well as the type. Well, after we install the units in the network, at the operation stage, we need to schedule. We also need to dispatch them to minimize the operation cost. And also, we may need to do some sensitivity analysis to understand the impact of the parameter changes on the final results. Okay. Now here is a review of existing literature in terms of the constraints, in terms of the objectives. Okay, you can also review this paper for this literature survey. In our group, we have worked on the planning for DG units and planning for ESS units. And for the DG units, we are considering heterogeneous distributed generation, including the power generator, as well as the thermal generator, that is the CCHP. Okay, so here we are developing this 2-stage stochastic approach, including the investment stage and operation stage. Our objective is to maximize the net present value of the project. Okay. So we are considering a CCHP unit, electric boilers, electric chillers via thermal generator, and also the photovoltaics, wind turbine, they are renewable-based generator. And also we consider the, okay, now this is a simulation results. Okay, so this is the simulation results for different planning phases and for different buses in the network. Okay, so this is the planning results for the distributed generators. And this is for the, another work is on the planning of the energy storage system. Okay, here we are also considering heterogeneous ESS, including both electric and thermal storage. And in order to characterize the thermal behavior of the network, we need to consider the end user, from the end user side and from the thermal storage side. And we also, the whole problem is also modeled as a stochastic programming model. And here we are also considering the risk of the whole decision making. So here you can see we have included this conditional value at risk item into the whole objective function. The idea is to hedge the risk in the final solution. Okay? Now this is the planning results. We are considering this multi-energy microgrid with thermal load and electrical load. And this is the planning results for battery storage for different phases and different buses at the capacity. And this is the result for the thermal storage, including the cooling storage and heat storage for different locations and for different locations, yes, and for different capacity. Okay, so if you're interested, you can refer to this paper as well. And a last okay, so you can see that the two works for the DG planning and ESS planning, they are both based on the stochastic programming. However, as already introduced, the stochastic programming can only guarantee a probabilistic satisfaction of the constraint. Okay, so there is still risk for constraint violation. While the robust optimization can guarantee the 100% robustness, however, it may be conservative. So it's quite sensible to combine the stochastic programming and the robust optimization together to make use of their respective advantages. So here we have developed this probability-weighted robust optimization algorithm. Okay, so idea is that we model this uncertainty set in a probabilistic way. Okay, so you can see that each uncertainty is assigned a probability rate, okay, H here. Rho here. Okay, rho here. So you can see that the second stage is modeled as a probabilistic manner. And this is a developed solution algorithm for this model. Okay. And to illustrate the result, this is a probability distribution for the wind and the wind speed, and this is the corresponding wind power output after the power speed curve. And based on this algorithm, we can deliver these planning results, and we also compare it with the robust optimization under different uncertainty profile. Okay, so you can see that for the probabilistic robust optimization, since the probability nature has already been considered in this uncertainty set, so you can see that it can achieve 0-degree voltage violation, while in the meantime it can achieve a very good net present value. Compared with the robust optimization, okay, you can see that on average it has a better performance in both economic and security constraint satisfaction. Okay, so if you are interested, you can also refer to this paper. Okay, so that is all for my presentation today on our research works on the DER units operation and control. All of our research works have been published in these journal papers. So if you are interested, you can have a reference to them. Okay, and we have also published a book with IET Press to summarize all of our research works in this area. Okay, so in this book, apart from the operation and planning, we have also included the controller design and the hardware in the loop validation of the microgrid. So if you are interested, please go to have a look at this book. Okay, and last but not least, I would like to take 1 minute to introduce our university, especially to those students who are considering to study in Singapore for postgraduate degrees. So our university, NTU, Nanyang Technological University, stems from Nanyang University, which is the first Chinese university outside China in 1955. Now, after around 36 years ago, 60 years, our university is renamed as the Nanyang Technological University. So today we have over 33,000 undergraduate and postgraduate students covering all the subjects, not only in engineering, science, but also in business, humanities, social science, arts, education, and even medicine. Okay, we have founded a medical school with Imperial College London in 2015. Okay, then I am from the School of Electrical and Electronic Engineering, School of EEE. This is one of the founding schools, one of the 3 founding schools of our university, and is one of the largest and the most highly ranked school in the world, with over 3,000 undergraduate students and 1,000 graduate students. So you are looking at the ranking system, both our university and our school are performing very well. So for all of the 4 major ranking system, you can see that our ranking is from 13 to 81 for the whole university. And for our school, most of the time we are ranked in the top 10, okay, around the world. And I am from the power engineering division in our school. Our school covers power engineering, electronic engineering, microelectronics, and the photonics, the control and automation, so on and so forth. So I'm from the power engineering division. We have 11 professors at different ranks, including 6 IEEE fellows and 1 fellow from Royal Academy of Engineering, UK. We focus on the power system and the power electronics area. And we are very well funded in terms of the research funding and support from the government agencies. And we are also very productive. Every year, we, as our power engineering colleagues, will publish more than 80 international journal and the conference papers per year. Okay, so if you are interested, please visit our university website. There is more information about our academic program and our research program. Okay, with that, I finished my presentation. Thank you very much for your attention. Thank you.
Hey, Dr. Yang, that was an incredible presentation. I tried to figure out the formulas, the graphs, but still puzzled over them. But with your skills and knowledge, I think there are improvements. Yes, Dr. Yang? Engineer Donna, yes, go. Let's proceed with the Q&A portion.
Okay, let me check.
Okay. Yeah, Dr. Yan, just stay. We will do a Q&A portion.
Okay.
Okay, Engineer Ross, am I clear and loud?
Yes, loud and clear. Go ahead. Engineer Donna, you're clear. Go ahead.
Okay, again, before we start our question and answer, thank you very much, Dr. Yansu, for sharing your expertise to us. Okay, if you have questions, so we will be entertaining some, but for our limited time, we will be collecting at least 3 to 4 questions. However, for other questions that we will not be airing, we will collect it and give it to our resource speaker for you to be answered via email. So the first question flashed on the screen, Dr. Zhu.
Yes.
May we know that what tools are you using for your microgrid simulations?
Okay, that depends on the steady state simulation or dynamic simulation. For the steady state, we can just use the power flow models such as those available in MATLAB. Let's say the MATPower. Okay, we can just use the MATPower to do the power flow simulations. And also you can use industry software such as PSSE or DigSilent. DigSilent probably is better, especially for distribution grid. That is for the steady state simulation. But for the dynamic simulation, similarly, we can use a MATLAB-based Simulink for the frequency and voltage dynamics simulation. And also you can use DigSilent, and DigSilent is also a good software. So for our research group, we basically use either MATLAB-based toolbox or PSSE and Simulink. Thank you.
Okay. Some others suggest on our chat box, ETAP can do too. Okay, for our second question, Doctor, with your model about optimal dispatch, how many actual generators, all energy sources were attempted?
Okay, that also depends on the testing system. So in our publications, we are mainly use the IEEE 33 bus system. Then there we place around 10 distributed generators in the system. So that means we are dispatching around 10 generators. However, depending on different, system size, it could be different. Thank you.
Okay, thank you, Doctor. Do we have another questions? Okay, for question number 3, under the two-stage stochastic optimization equation model, how about the sensitivity of equation to different unexpected or noise parameters?
For the two-stage stochastic optimization, the idea is to model the uncertainty through the Monte Carlo sampling.
Okay. For question number 3, under the two-stage stochastic optimization equation.
Yeah.
Yes,
Okay,
go
yeah.
ahead, Mr.
My answer is that for the stochastic optimization, the idea is to sample the scenarios from the probabilistic distribution function to approximate the uncertain parameters. Okay, so there is no, I don't quite understand about this sensitivity. The whole idea is to sample these different scenarios. I suppose you are asking about the number of the sampling or some other input parameters changes and their impact on the final results, right? So certainly the number of the sampled scenarios is very important. And there is a kind of a trade-off between the accuracy and the number of samples. However, in practice, that means if you sample more scenarios, it could be more accurate. However, the problem size will be bigger and the solution time will be longer. So we need to have a balance between the problem size and the accuracy. And in practice, we actually can use some scenario reduction method to just select the most representative scenarios from a large number of the scenarios. So from that we can balance the accuracy and the speed. Yeah, and the unexpected or noise parameter, the unexpected and noise, they are all uncertainty. They are all uncertainty. They are treated through this sampling.
Okay, thank you very much. That would be
okay, thank you, Dr. Su. Back to you, Engineer Ras.
Yes, thank you very much, Engineer Donna and Dr. Yan. Dr. Yan, just stay for a while for the award of your certification. Okay, and this time I would like to call in Engineer Carlos, Director of Membership for IECEP Manila, for the awarding of appreciation to our technical speaker. Engineer Carlos, the space is yours.
Okay. Thank you, Engineer Russ, for the short introduction. So, to award the certificate of appreciation to our dear speaker, Dr. Yan Shu. So, the Institute of Electronics Engineers of the Philippines Incorporated, our electronic society, is hereby awarded and presented the certificate of appreciation to Dr. Yan Shu for his invaluable contribution as our resource speaker for the third colloquium on power and clean energy with the topic coordinated control, operation, and planning of distributed energy resources, DERs, in microgrids, given this 11th of February 2023, signed by Engineer Christian Enoval, Governor IECEP Bulacan, Engineer Gerald Chocson, Governor IECEP Mindoro, Engineer Muhammad Ali B. Mauna, Governor IECEP KSA-ERC, Dr. Jodelix Sarcilia, Governor IECEP Cavite, Engineer Chofilo Lorenzo Ongkiko, Governor IECEP Manila, and Engineer Mark Philip Fernandez, Chair IECEP Power Electronics System. Thank you very much.
Thank you. Thank you too.
Hope to see you again in the future presentation. Thank you very much for your time. Okay, now let's proceed for our certificate awarding for our sponsorship. So before that, I would like to ask the attendees, please, if you're still with us, please type or hit your keyboard with the letter Y if you're still with us. We have 2 more speakers to go. Please, those attendees, please type letter Y. And I see those Y's in our chat box. Okay, I think only 2. How about, wow, good, good. Clap your hands, everybody. Okay, I'll give you a thumb up for this one. Okay, now let's proceed for the awarding of certificates for our sponsor. I'm requesting the Zoom master to blast in us the awarding sponsor certificate. And I would like to thank you for unending support to our sponsors to help this third colloquium a success. First, we will call in our EBB representative by Engineer Job Mayo to receive the virtual certification. So certificate goes like this. Certificate of appreciation. This is to certify hereby presented to ABB Incorporated in sincere acknowledge with a company invaluable contribution as a sponsor of the third colloquium on power and clean energy given in this 11th of February 2023, signed by Governor Ian Enobal of IECEP Bulacan, Engineer Toxon of IECEP Mindoro, Engineer Muhammad Ali of IECEP KSA Saudi Arabia, and Dr. Sarcila of IECEP Cavite chapter, and Engineer of Okemko of IECEP Manila. Last but not the least, our very own Chairman, Engineer Fernandez of IECEP Power Electronics Society. Engineer Jamayo, are you still with us? Please acknowledge. Engineer Mayo. Last call. Engineer Mayo, anyhow. Engineer Mayo will be asked for our speakership after this. And back to you, Engineer Dora.
Okay, to receive the Certificate of Appreciation for Advanced Energy Incorporated, we have Mr. Stuart Mitchell, the Senior Director Appreciation from the Institute of Electronics Engineers of the Philippines
Engineer Donna, your signal is very
This
low.
certificate is hereby presented to Advanced Energy Incorporated in sincere acknowledgement with the company's invaluable contribution as a sponsor for the third Colloquium on Power and Clean Energy 2023, signed by Engineer General
Okay. Yes. Engineer Donna, we have some minor difficulties with your signal. It's okay. So can we call it Smart Mitchell? Smart Mitchell, are you with us? Please acknowledge. Okay. Second call. Smart Mitchell, if you're with us, please acknowledge and do so. Okay, let's proceed for reminders for our house rules. Engineer Donna, please do so. Yes, Engineer Donna, please. Okay, but while waiting for Engineer Donna, so I would like to remind once again our house rules, reminders, and qualification for the e-certificates. Mr. Zoom Master, please proceed second. So this is our house rule. Simple, easy, and straightforward to comply. So keep doors open for better communication, greater mutual respect, and greater efficiency. Please do this one thing. Mute your device or audio or your webcam during the presentation. Turn it on only when needed. Second, respect the speakers on the floor. Note that you are allowed to ask questions. Remember, ask questions via the Q&A mechanism on the webinar. We will not entertain questions via the chat box, no spamming or chat box. Thank you for that one. Third rule, create discussion or ask questions during the is mentioned by the speaker related to the topic. Fourth one, do not close your session or log out during the seminar. You may leave any time between you and your login, but not connected as it may interrupt the system. You can log out after the event finishes. Last, don't forget, fill out the attendance and evaluation form later. The link will be posted in the chat box after the webinar. Okay, so master? And this is how you're gonna qualify for the e-certificate. Fellow attendees, students, professionals. So I think this is what you need. So registered and confirmed participation at IECEP for the IECEP members. Okay, I think there's also procedure for non-IECEP. We did already. Complete the 90% session. Remember, 90% and sign the attendance forms. We have also the test to evaluate you. So this is mandatory. Accomplish the evaluation form to complete a certificate. Agree, attendees? Please type yes if you're very clear for you. Please, can I have those letter Y? Go ahead. Y. Where is the Y? Wow. Yes. So not only Y. They said yes, 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 yes. Yes. Okay. Thank you very much, attendees, fellow professionals. Back to you, Engineer Donna. What you can say? Yes, Engineer Donna. You have something to say? I think you're back online now.
Okay, so sorry, Engineer Ross. I really
No
have
worries.
a very bad internet connection today because of the incident. I think it's okay. Just so please bear with us. Stay tuned. We will have our 5-minute break.
Yes, Engineer Donna. 5-minute break. The count start now.
I'm excited to have joined Advanced Energy during this landmark year, our 40th anniversary as a global power solutions leader. Our celebration highlights two key factors that differentiate AE. First, our innovation in precision power, conversion, and measurement. And second, the talented people who make this possible. It's an incredible story. Doug Schatz, Advanced Energy's co-founder, the first of many people at Advanced Energy to dream big, initially made power supplies in his home. Over the years, we have grown by developing leapfrog technologies that exceeded customer expectations. R&D has powered our business, and it still does. Worldwide, we have built a thriving ecosystem of global design centers and manufacturing facilities. Our ultimate goal is to deliver high-quality, best-in-class products and services to our customers. In recent years, we've grown rapidly, both organically and through acquisition, including Artisan Embedded Power in 2019. Today, Advanced Energy is the clear global leader in precision power. Our products are critical enablers for some of the most advanced manufacturing processes in the world. And our products help to power critical industrial, medical, data center computing, telecom, and networking equipment. With years of groundbreaking technology and strategic partnerships, you might think that tells the full story. But when you ask why Advanced Energy, customers talk about our people and the exceptional customer experience we deliver. We listen, we innovate, we collaborate, and we're passionate about our customer success. Today, at 40 years of age, we have over 10,000 employees, and we're growing. Our can-do culture, our deep technical expertise, and our collaborative approach to problem solving make Advanced Energy a great place to work. To kick off our celebration, I'd like to extend a heartfelt thank you to our employees for their commitment, talent, and passion, to all that you have built over the past 40 years. To our suppliers, thank you for your continued partnership and your support. And to our customers, you're the reason we're here, and we're committed to your success. And finally, to our long-term investors, thanks for your support over the years. For 40 years, Advanced Energy has been a proven power solutions leader. Now our innovative precision power conversion and measurement solutions are at the center of the fourth industrial revolution. We truly power the future. Thanks to all who have made it possible. And here's to 40 more years of growth and success.
Advanced Energy powers the world around us by providing the precision power products required to manufacture and test many high-tech and industrial products, and many common household items that are ingenious in their own quiet way. Manufacturing the things we use and encounter each day requires an unbroken chain of innovation that begins with specific applications of power. With our precision power products, there's no room for error. And there's no comparison to our expertise at finding new ways to make the production, testing, and shaping of materials simpler, more reliable, and more affordable. Our purpose is to enable the innovations of our customers, so they in turn can meet the needs of their customers. Around the world, at home and at work, products made with advanced energy power are everywhere. From the thermal control products we provide to heat glass and steel, and the power needed to apply thin protective films to architectural glass. Manufacturers rely on our high and low voltage systems to deliver impressive performance and accuracy across a wide variety of modules and applications. No matter how complex the technology, our innovations are dedicated to helping our customers develop products that improve the lives of their customers. We even provide power for lasers used in laser eye surgery, electrosurgery, and cosmetic medicine, and the high voltage pulses needed for defibrillators and lasers to break up kidney stones. The power from mass spectrometers used in drug, water, and food testing, and in clinical and laboratory testing. As our customers innovate, we work to transform the future with them, wherever they are in the world. This makes our innovations global and personal. Precision, power, and performance. These words define our dedication to shaping and transforming power, and to doing our part to make each day a little more magical than the day before.
Okay, I think 5 minutes is already up. Co-host, my co-host Engineer Donna, are you with us? Please proceed with our second topic of this afternoon session. Engineer Donna, the space is yours.
Okay. Thank you, Engineer Ross. Okay. Thank you, Engineer Ross. Naririnig niyo po ba ako?
Yes, loud and clear. Go ahead.
Okay. To introduce our second resource speaker for this afternoon, let me call on Engineer Teopilo Bitoon Jr., PECE, the Vice President of External Affairs from IECEP KSA-ERC.
Thank you, Engineer Donna. My audio is clear?
Yes, loud and clear.
Yes.
Thank you. Good day, everyone. I hope you're all doing fine wherever you are in the world. So now we are in the fourth webinar session. Our next speaker, I think he's the fourth one for the day. He is an electronics engineer with competencies in the field of energy management, sustainability, and design. He is currently a member of IECEP's Power Electronics Society, a board of trustee in NPAP 4.0 Incorporated, and a member of DTI/BPS TC and TC10. He is currently acting as the global application market developer of ABB, supporting the buildings and data center solutions in the APAC and Middle Eastern region. So without further ado, please join me in welcoming Engineer Jove Mayo the fourth. A warm round of applause, please.
Good afternoon. Thank you po, Engineer Bitoon and Engineer Donna. Good afternoon. Malinaw po ba ang aking audio?
Yes, very loud and clear.
Okay, perfect. So let me go ahead and share a copy of my slide. Here it is. would like to also request if kita na po ang aking share.
Yes,
Yes, visible na po.
Thank you for confirmation. So again, good afternoon everyone. So hopefully hindi pa tayo na information overload. Ang ganda ng mga topics simula kaninang umaga hanggang hopefully hanggang yung susunod na speaker after me. We stay and we will listen. So again, ako po si Job. I'll be presenting to you today some trends and probably some design considerations in terms of power continuity, especially in the critical infrastructure with the focus on data center reliability. So medyo mahaba-haba lang rin tong slides na to, but I'll try to discuss and run through all of them. Please feel free to ask questions dun sa chat, and then let's see if we can answer it after the presentation. So again, let's start. So ang aking agenda, actually 6 lang naman po ang aking i-discuss ngayon. I'll start it off with the basics of data centers, ano ba yung mga languages na ginagamit. We'll start, then we'll deep dive on the trends, history, saan nagmula, nasa na ito ngayon, and ano pang i-expect natin sa future, and bakit kino-consider natin na critical ang isang data center, especially tayong mga nasa field of electrical and electronics engineering. Medyo malaki ang papel natin pagdating sa power reliability and power continuity, and at the same time sustainability ng data centers. Of course, we'll start we'll have a deep dive on design considerations. Ano ba yung mga kailangan i-consider pag nagde-design? Kunwari may project tayo, anong concepts ba yung kailangan nating tingnan? And at the same time, of course, last but not the least, the concepts in order to improve data center reliability. So ano ba to? Later on, I'll give a short discussion on this as well, and I'll try to answer the question and answer probably after the last subtopic. So let me start this off with the common terminologies. Most of you guys, I think, are well aware or well familiar with this. Let me start it off with the description, or ano ba ang ibig sabihin ng data centers, kasi malamang most of the time pag pinag-usapan natin data centers, we're talking about IT infrastructures, we're talking about servers, we're talking about storage processes, and other equipment within a certain telco facility or a certain business process facility. So technically, by definition, a data center refers to a building, a dedicated space within a building, or a group of buildings used to house computer systems and associated components, such as telcos and storage systems. So anything to do with IT, actually. May sa normal buildings, typically meron tayong mga telco rooms. We consider them as data centers as well, because this houses the servers, the racks, the switches, and the hubs. And sa larger facilities, we also call them as data centers, especially pagka pinag-usapan na natin ang cloud computing, artificial intelligence, and even crypto mining. So lahat yan papasok sa level ng data centers, because we need to store, we need to process, and we need to extract data or information coming from those IT equipment. Another terminology that you may experience when dealing with data centers is what we call brownfield. Typically, ginagamit rin ito sa mga construction sites. So by definition, this is a facility or a location wherein installing and configuration of new hardware or software must coexist with the existing IT system. So pag nakatayo na yung building or pag nakatayo na yung facility, may existing IT infrastructure siya, kailangan mo mag-integrate. We're talking about brownfield. Again, pag pinag-usapan natin ito sa construction, this is a construction site that is already previously developed land. And technically, as mentioned kanina, the IT infrastructure or technically the infrastructure are already in place. Now, if we're talking about kabaliktaran, greenfield, Syempre, totally new IT systems yung pwede nating ipasok. Pwede kang mag-design ng sarili mo. May gusto mo bang magkaroon ng raised floor or gusto mo ng bus duct tracking system for bus bar distribution or for the IT distribution, you can do it. So you have all of the uh, the liberty to design kung paano pagagandahin yung data center. So again, in terms of construction terminologies, this refers to new developments on previously underdeveloped land. And as mentioned, for greenfield data centers or greenfield projects, you are not constrained by any existing networks. Kasi ang medyo madugo minsan is i-integrate natin yung bago dun sa luma. Minsan hindi talaga sila nagtutugma. Minsan minsan mas madali na palitan ng buo kaysa mag-introduce ka ng bago dun sa lumang system. So this goes the same for greenfield. It's really more of doing the design from ground zero and up. Now, very critical, of course, when we're talking about data centers, very important redundancy. This only refers to the duplication of equipment. So technically, pagka pinag-usapan natin ng redundancy, meron ka laging backup, may it be a genset or a UPS or an extra storage rack. So this is in most cases, pagdating sa standards or pagdating sa power system design, we always talk about this this usually refers to the backup power available. And in terms of numbers, the higher the redundancy, the lesser periods of downtime. Kasi any downtime inside a data center would entail loss in terms of money, especially sa mga malalaking data centers, mga hyperscales or mga co-located data centers. Malaki yung nawawala pagka nagkaroon ng downtime. This reliability is also more or less used term pagdating sa data centers. Typically, napagpapalit sila with redundancy and reliability, pero technically isa lang yung main intent niyan. It refers to the ability of a system to function under stated conditions for a specified period of time. Redundancy, ibig sabihin, meron kang backup, pero pagka mas marami kang backup, of course, mas reliable yung system mo kasi mas marami kang pagkukunan or pagsustoran ng data or pagkukunan ng needed power mo. So in terms of data centers, having a reliable system design is critical. In cases of failure, the most important consideration is to get the IT equipment and business processes up and running as soon as possible to minimize downtime. So again, as madalas na binabanggit ko, pag pinag-usapan natin data centers, dapat hindi siya namamatay. Dapat hindi na mamatay na yung buong building, wag lang yung IT equipment or yung business process equipment. Kasi nandyan yung buhay, nandyan yung negosyo. Pag namatay yung pinakadulo ng ating data centers, nasa downstream niya yung IT equipment, dali tayo, deads yung negosyo natin. Kawawa yung customer natin, kawawa yung mga gumagamit. For example, namatay yung server, for example, ng Lazada. Of course, mahirap umorder, mahirapan si Mrs. mag-order ng kanyang mga pang-shopping, mainit ulo. And on another end, syempre, yung mga nagtitinda naman within Lazada, hindi sila makaka-receive ng orders. Bagsak ang negosyo nila. And in terms of contracts, of course, pag may bumagsak na server na, for example, bumagsak yung server ni Lazada, of course, it will entail some sanctions kasi nalugi yung sellers nila within Lazada. This goes the same with other business processes as well. May it be financial institutions, may it be an airport, may it be a simple office na kailangan ng internet connectivity. Reliability is very important. And typically, this is measured by what we call the MTBF, mean time between failure. So usually, this is counted as typically 99.99, the number of nines after the decimal points. So tinitingnan natin yan. Syempre, if we have redundancy, we have reliability, of course, there's what we call the power of the availability. So data center availability. This is a measure of how often something is in an operable state. This is typically measured in percent. So this is the amount of time a system is functioning and measured in the percentage of time. Gaano katagal ba siya naka-up? And syempre, when we're talking about power availability, we're talking about redundancy. There's such thing as what we call the uptime, which is the guaranteed annual availability of a data center. Tinitingnan natin on an annual basis yung yung availability niya. So define natin kanina yung availability, gaano katagal tumatakbo yung data center. So pag define na natin siya within an annual period of certain period of time, for example, 1 year, makaklasify natin siya as uptime. Yung number na yan, uptime na siya. And that this is the time that the equipment and systems are available to perform its function for 1 year. This is one of the core business goals of data center. Kaya nga, later on, I'll discuss kung ano si uptime and bakit may uptime institute, ano yung mga kailangan nating i-comply, what do we need to comply in order to satisfy the requirements of the tiering certifications under the Uptime Institute, and other terminologies as well being practiced in the industry. Now, to achieve high uptime, data center providers spend a lot of money, time on redundancy, processes, and certifications. Syempre, kabaliktaran ng uptime is downtime. So downtime is more or less a form of an outage. So this is the time that the equipment and systems are unable to perform its functions. So later on, mamaya may tayo. I'll show you an example of block diagrams that you can for easy visualization on how to interpret yung ating requirements pagdating sa power reliability. And downtime in the data center can have the worst impact on a business. So one example would be yung nangyari rin sa atin early part of this year, January 31 sa airport, di ba? Nagkaroon ng downtime more or less sa isang area within KAAP na nagkaroon ng downtime, which in effect has caused a lot of problems. May na-delay na flight. Of course, may mga rebookings na naganap. And at the end of the day, business yung tinamaan, economics. So this is also one way of a worse one example of an impact of a downtime in critical infrastructure, especially for data centers. Another definition would be PUE, power usage effectiveness. This is a measure of how efficient a data center is. As you all know, data centers run 24/7, 24/7, and they don't run on dynamic loads. So more or less tatakbo siya dire-diretso without the operator having the chance to turn on and off yung mga equipment niya within the data center. So medyo hindi dynamic yung loads within the data centers. That's why it's very important to have or to measure the power usage effectiveness of data centers at the onset to understand how efficient yung data centers while they are running. And at the same time, syempre, they would know if there's a need for maintenance or other issues that they need to address, if they need to upgrade the chiller system, or if they need to upgrade the UPS in order for the data center to run much efficiently and much sustainably. So by formula, this refers to the ratio ng total equipment within the whole facility over the total IT load. So later on, may trending tayo na ipapakita about this, but let's move forward with the Uptime Institute. This is a standardization body which refers to the certification typically for tiering, tier 1, tier 2, tier 3, tier 4 types of data centers. Ang idea nito is that they are providing advisory services or advisory programs in terms of improving the performance of both the efficiency and reliability of data centers. So tinitingnan niya yung power usage effectiveness as per ASHRAE and as per IEEE, and they're also looking at the power reliability of the system. Kasi of course, katulad ng binabanggit kanina, data center certifications is very important at nowadays, primarily because third-party certifications coming, for example, Uptime Institute, would prove that the data center facility being built or being operated is fully optimized, reliable, and that would encourage more businesses to lease out server spaces within that that data center, within those certified data centers. Okay, now let's start with the trend. History muna tayo, mga history. So data center history, I'll start this off with the evolution. More or less, the earliest form of data center started 1950s. This started from what we call the ENIAC, the Electronic Numerator Integrator Analyzer Computer. Medyo malaki-laki. So makikita mo rito sa photo na to, nasa museum na siya ng Penn Engineering. So makikita mo dito one example of a data center rack ng ENIAC. Medyo malaki siya. And this is the first programmable general purpose electronic digital computer. More or less ginamit siya during the World War II by the United States, and it's weighing more than 30 tons with the footprint of 1,800 square foot. And in order to operate this, you'd need to have around 6 full-time technicians. Medyo marami-raming kable, malaki-laki, malawak, mabigat. And then the 1970s, this started the boom of yung mga maliliit na ICs. Of course, one of which is the Intel 4004, and of course, kasabay nito would be the requirement for disaster recovery. So pag sinabing disaster recovery, ito yung data recovery ng mga IT equipment. So as mentioned, this Intel 4004 is the first 4-bit CPU, and it was known as the first commercially produced microprocessor that time, 1970s. I think most of us here, hindi pa tayo pinapanganak ng mga panahon na to. And the need during this time, again, na-recognize yung need sa IT disaster recovery due to increasing dependence to computers. This goes the same with other systems such as building automation systems and programmable logic circuits. More or less during the 1970s, dun sila medyo nag-start. And then of course 1980s, the rise of the supercomputers. So we have an example here, Micral N, which is developed by R2E, which was released 1980s. So this microcomputer was used for scientific and process control applications. And in most cases, the supercomputers are becoming more prevalent and are used more in R&D. From 1950s na ginamit sa gera, ngayon wala namang gera during, well, mas light yung war during the 1980s, although there's nandito yung Vietnam War and other. Pero in terms of technological warfare, hindi na masyadong so most of the technologies during the 1980s are being used for R&D, and this is one example of this. And syempre 90s, tayo mga 90s babies, mga generation, ito yung nabutan natin, the dot-com bubble. So this is more or less yung itsura ng modern data center servers and racks. So the rise in stock market valuations of internet-based companies such as alam niyo naman sila Apple, sila Google and whatnot. This started from yung 90s. This started yung migration from the traditional on-premise server rooms to a more specialized location, co-located data center server rooms. So in some cases kasi dati well, here in the Philippines, most of the data centers are still on premise, but during the 90s, this triggered yung paglilipat ng mga data center facilities from the typical business offices to a more specialized, more secure locations. Minsan madalas remote na siya ina-access for better maintenance and ease of security. This triggered the construction of bigger facilities from to house the servers and computers. And of course, the Y2K or the year 2000 triggered the growth of a lot of centers. So data centers are being built across the globe to store, process, and analyze data for different applications such as banks, telcos, internet providers, and cloud service providers. Dito sa Philippines, ngayon nararamdaman natin to. Marami-rami tayong ini-expect na data center projects. Most of the bigger data center operators or bigger cloud operators such as Google, Alibaba, Amazon are now trying to go here. If not, they're already here. For us, for example, us in ABB, we see a lot of projects coming in starting last year. I've been meeting with a lot of operators since last year from Singapore and from Malaysia, and based from different forums. Philippines will be one of the data center hubs probably in the next 5-10 years. Kasi Singapore, for example, medyo kulang na sila sa land, medyo kulang na rin sila sa energy. So wala na silang places to put data center facilities. Tayo medyo marami-rami pa tayong mga remote areas na pwedeng paglagyan. So we see a boom here in the Philippines, and we're expecting more and more data center operators and partnerships coming in here in the Philippines. Now, ano ba yung mga trends? Kasi syempre, most of us here in the Philippines, or most of us here in this session, mga practitioners in terms of power electronics, telecommunications, building auxiliaries and whatnot. So I think most of you guys probably, hopefully, makapasok rin sa data center projects here in the Philippines. So we are seeing a lot of trends. So this is one example in terms of trend ng efficiency ng servers, ng storage. So we see here a trend in terms of power ng ating mga servers. So makikita nyo rito from 2007 to 2013, average idling power ng mga racks bumababa. In effect, mas nagiging efficient yung mga nasa IT infrastructure natin. What more ngayon? This study was conducted 10 years ago. So what more ngayon? I'm sure meron ng mas malayong developments pagdating sa data center, pagdating sa IT storage efficiency. And this is an updated one, 2014 comparison between the different types of storage. So for example, tape storage servers, the 1U blade and custom and high density. So we see here the effect nung heat load per product equipment medyo bumababa kahit lumalaki yung capacity. Hindi siya proportionate dun sa increase in terms of heat load, and we're seeing a lot of this actually we've seen a lot of this development, and we are seeing a lot of better developments in the market at this point, especially dun sa IT space. Again, major trigger ng IT infrastructure ng data centers is more or less because of the requirements of different technologies. For example, IoT, Internet of Things. Without the proper connectivity, without the proper infrastructure, IoT devices medyo alanganin. And we've seen a lot of these issues here in the Philippines ngayon, and even other Asian countries. Medyo takot sila mag-shift to IoT, especially for commercial applications, dahil natatakot sila in terms of how fast how secure yung data. So this goes the same with cloud computing, artificial intelligence, big data analytics, blockchain, and syempre yung 5G. Nandito si engineer sa JID, so very familiar sila dyan. 5G rollout, I think there's a new one, 6G. So this is something that that will contribute to exponential growth pagdating sa data center market, especially for the Philippine market. Medyo lumalaki siya, and you see that here. The forecast up to 2023, up to this year, 11% yung possible increase in terms of market size. And most of the communities ngayon, they are now trying to shift toward cloud. And we need these kinds of infrastructures, 5G, IoT. We need these kinds of infrastructures, technologies to support yung demand from transitioning from on-premise data center to cloud data centers. So we see this, and we're seeing a lot of positive developments in this kind of management. Kasi ikaw ba naman, for example, ikaw ay isang residential facility and you own your own data center on premise. Minsan minsan for developers or for facility owners, typically medyo mas mahirap mag-maintain talaga ng data centers, lalo na pag nawalan ka ng internet connectivity. Unlike, for example, naka-house yung data, yung process mo on another facility, sila na yung nagme-maintain, sila na yung nag-a-add at saka nagbabawas ng demand mo, pay as you parang naka-modular ka, and sila na rin yung mag-upgrade ng mga patches. So for nawawala yung naaalis yung burden nung required competency dun sa facilities, different facilities, if we put the storage and the maintenance, etc., outside to a more secure, more competent facilities such as data centers or cloud. And this would also increase the demand for data center management and cloud technologies. Now, again, 5G, another trend that we're looking at, the deployment globally, the deployment of 5G network services will boost edge large data center and hyperscale investments. Of course, the decentralized model of data centers network, where multiple edge data centers will connect to central hyperscale facilities. So ngayon, meron ka ng central hyperscale facilities, and just for redundancy, may mga decentralized data centers ka pa. Minsan hindi siya, madalas remote siya for redundancy and security purposes. Of course, because of this drive, we are seeing a lot of growth in the hyperscale and co-location data centers. We're looking at around, we've seen around more than 50 hyperscale data centers opening at 2021, and another set in the succeeding years. And of course, there's a demand for growing rack power density, which signifies the growth in terms of energy demand ng hyperscale facilities. Siyempre, lumaki yung rack power density mo, lalaki rin yung energy demand mo. So more or less data center hyperscale facilities will grow. So when we say hyperscale facilities, these are the IT data centers with IT loads of total of 15 megawatts and above per power per site. And of course, kasama dun sa demand ng power, the increased demand in power would be the demand for energy efficiency and total cost of ownership. And syempre, in accordance to this, of course, the environmental certifications. Yung we need to make new data centers more green, more sustainable, and we, as mentioned kanina, ang daming discussions about green technology, sustainability, and this is something that could contribute in making data centers more sustainable and energy efficient. An example, I think, would be the one being done in in China. So there are some projects in China na DC grid na yung ginagamit. Hindi na siya nag-AC kasi we see that, for example, for IT racks naman, DC naman talaga siya. So we see some power losses if we convert back to AC and then we convert back to DC para ma-power natin yung yung IT rack. So there are ongoing studies, ongoing projects about this, and this will also trigger another trend in terms of technology kasi sa DC you'd need to have different kind of protection. You need to have solid state circuit breakers or fast reacting fuses in order to protect yung power system. So there are these kinds of technology would trigger another growth sa ibang ibang sector or ibang segment. This is an example of the sustainable development goals ng Microsoft. So they're looking at carbon negative. Hindi na siya carbon neutral kasi pag carbon neutral hindi ka na nagpo-produce ng carbon, but they're looking at carbon negativity. So ibig sabihin they're now offsetting yung emissions. Nagka-carbon removal na sila instead of reducing yung emissions. So this is a good direction. So this is this kind of goal medyo ambitious, but then again, technology is available, alternative resources of energy are also available. So this is something that we think is achievable not only for Microsoft but also for other facilities, may it be data centers, may it be critical infrastructures, may it be the commercial or the industrial sector. So if kaya ni Microsoft, I think most of the facilities, pag nakakita lang sila ng isang technology or ng business case na kaya magawa to, definitely magagawa yan. And ito yung trend in terms of energy efficiency, power usage effectiveness. So again, yung formula is overall power consumption over the consumption ng IT rack. So from 2007 na 2.5 yung ratio na yun, ngayon nasa 1.59, 1.6, and I am seeing a lot of new hyperscales na tina-target 1.3. So ibig sabihin parang 30% lang ng excess ng kanilang total capacity is going towards the auxiliary equipment, the UPS, the auxiliaries, and then the cooling. So medyo ambitious, pero again, this is feasible. Now we're talking about when we talk about data centers, we're talking about uptime. Gaano kadalas ba ang nag-ooperate yung data center. So this is one study conducted by the Uptime Institute. So you'll see here the percentage in terms of the seriousness of downtime pagdating sa category 5 and category 4 impacts. So you'll see here yung category 4 serious, severe, category 5 severe, and yung description. So category 4 refers to the disruption service and or operation, and then category 5 refers to the damaging disruption. So ibig sabihin merong losses with ramifications including large financial losses, possible safety issues, compliance breaches, customer losses, and reputational damages. And in most cases, you'll see here the most common costs ng downtime. So kita mo rito 30% is really power. So pagka may problema ka sa upstream mo, definitely you'll have problems in the downstream. So it's very important that the power system within the data centers are reliable to make sure that the IT loads are powered, are given the power at the most applicable time, or when they need power. For example, pag nagkaroon ng sudden fluctuation, for example, or naputol yung kuryente natin from Meralco, dapat biglang papasok ang power smoothly papasok yung power going to the IT racks para hindi magkaroon ng damage dun sa electronic devices. And syempre para hindi magkaroon ng putol dun sa connectivity or this transmission ng different data and connection, communication. So you'll see here, medyo malaki-laki ang problem pagdating sa power. So this is something that we're trying to address now, the power continuity in terms of critical infrastructure, especially with data centers. How critical is it? Let me just give you an idea by the numbers. With increasing volume of data being created, consumed, and transmitted across the internet, we need data centers to process them fast and safely. So just by the numbers, in 1 minute, 190 million emails are sent, 694,999 scrollings. So these can be Facebook, Instagram, Twitter, etc. 5.9 million messages sent, and 4.7 million viewed videos. So depending on which part of the globe kayo, pero by the average, this is the amount of data being transmitted within 1 minute sa internet. Of course, in terms of new connections, we're seeing 127 devices new devices being connected to the internet on every second. So multiply mo yan ng how many minutes, maraming devices yan. Laging may bagong device na pumapasok globally. And most issues is really hardware failure. Loss of data. Common cause of loss of data is really due to hardware failure. May it be kumbaga nasira, may it be the damage sa hard drive mo, or during the transmission medyo nagkaroon ka ng surge kaya corrupted yung data. Anyhow, it's 40% hardware failure. This is something na kumbaga pag nawala dali tayo lahat. So in terms of criticality, how critical, I can say na very critical. One data center down will entail a lot of damage. Isipin mo isipin niyo na lang mag-down si Facebook. Anong gagawin natin habang nag-aantay tayo ng bus? So traffic. So sakit sa ulo, di ba? Ang daming mawawala, ang daming magbabago sa pamumuhay natin. Now, design considerations, tatlo lang naman. Actually, first would be resiliency. You need to have a resilient data center. First and foremost, that's the main priority. So the challenge is that the average cost of a single data center outage is around $730,000 and continues to rise as more and more data centers are created. Now, the trend is that the pressure to invest in infrastructure redundancies and recovery system to meet reliability and sustainability goals. Now, the idea is that in order to make facilities more reliable, more resilient, more available, intelligent solutions should be present to achieve energy efficiency, not only energy efficiency, but also the uptime while requiring manpower safety. So first, first consideration would be kailangan ng isang data center would be resilient, should have the required power available at any given amount of time. Second would be speed and scalability. Ito naman, pinag-uusapan natin dito, gaano kabilis bumuo ng data centers. Kasi as you all know, data mining is now kumbaga a commodity. Kumbaga maraming companies ang nagbebenta ng data, kaya nga meron tayong data privacy law, meron tayo. Kasi ginto 'yan. Pag may data ka, may information ka, this is something that magagamit mo for any use pagdating sa different applications. Now the trend is really pay as you grow, SaaS. The need for speed and fast return on investment drive the need for scalable and or modular solutions. So mas mabilis ang pagre-require natin ng maraming data versus sa growth ng pagtatayo ng data centers in the market. Kaya medyo malaki-laki ang hahabulin. This goes the same with power and energy. So pagka dumating ang maraming data centers, you need to have more power substations, more resources of energy. Ano yan? Magkakadugtong yan. And the solution would be to meet the demands, to meet the speeds required. Many data centers are leveraging on modular, prefabricated, and pre-tested solutions. So again, in some countries, what they're trying to do now are modular data centers. Ibig sabihin, naka-container yung mga data centers pagdating sa site, i-energize na lang pagka dumagdag ng leasing or maraming data, dumaas yung demand nila, bibili na lang sila ng isa pang container, i-connect lang nila. So this would reduce yung yung cycle ng construction, but more on the but will put more focus on project management and of course on the operations ng data centers. And lastly, of course, pinaka-important would be sustainability. This is something that already becoming a buzzword, not only for data centers, but especially for data centers, because data centers consume 1 to 2% of the world's electricity. And consumer demands are growing. As mentioned kanina, habang dumadami ang mga apps na ginagawa, habang dumadami ang mga requirements, applications, lalong dadami yung requirement for data centers. And kaakibat nun is that lalong tataas yung demand for electricity and energy. And this, of course, would entail stress or this would, of course, entail more push to develop more sustainable energy. On the other hand, of course, the development of data centers would need to be optimized. Mas aggressive yung sustainable goals nila dapat. Which katulad nung pinakita ko kanina pagdating sa Microsoft, they have their goals pagdating sa carbon negativity. So this is something na bago, although sa atin dito sa Philippines, we're now going towards nag-start tayo sa green building. Ngayon, we're introducing the net zero buildings, eventually carbon neutrality and carbon negative. Medyo marami pa tayong hahabulin pagdating sa competency and market acceptance. Tapos, of course, syempre, in order to address this, of course, again, katulad ng number one, energy efficient solutions, intelligent solutions, smart solutions, lahat na ilagay mo. Kailangan at least kahit papaano, most of the equipment within data centers are intelligent or smart. Now, let's start with concepts to improve data center reliability. So when we're talking about data center reliability, we're talking about the first design consideration, resiliency and time. Kailangan meron kang power availability. So itong fifth topic na to, meron tayong tatlong subtopics ito. We'll talk about standards. The second and third, we'll talk about how to address it on a technological perspective. And last is how to address it on a system level perspective. Kasi syempre, in these scenarios, hindi natin maipagkakaila na malaki ang papel ng technology in order to advance or in order to guarantee power reliability, power continuity in critical infrastructures. Let me go ahead with the standards. So sa standards, we're talking about design, we're talking about architectures. Madali ito sa medium voltage actually. Sa medium voltage side, 36 kV, 16 kV, 13.2 kV, 6.6 kilovolts. Medyo madali kasi ngayon we're now talking about modular substations. So we see these kinds of redundancy. So first would be system plus system redundancy. Ibig sabihin, meron kang dalawang substation to power the critical loads. In case mag-down to, 100% will be transferred to system 2. Now, we have what we call the shared redundancy, wherein meron kang tatlong sources of energy. and you have different way to transfer yung loads from one system to another. Na ang idea nito is that pagka nagkaroon ka ng downtime from system 1, dapat kayang paghatian ng system 2 at saka system 3 yung load ng critical ng downstream natin. So ang idea nito would be itong mga maliliit na box in the middle are controlled by automatically controlled na switches in order to guarantee yung power availability within the for the critical loads. And lastly, block redundancy. Medyo mas efficient to, mas reliable to, but would entail cost kasi meron kang electronic transfer switching. So medyo mas mabilis, but you'd need to invest on these kinds of medium voltage switches in order to support different loads. So medyo sa power side, medium voltage side, medyo madali yung concept niya, medyo mahirap lang siyang medyo costly yung in terms of implementation. Typically, bumabagsak tayo sa system plus system topology, but more and more hyperscale data centers are going towards shared redundancy and block redundancy because of the availability ng technology pagdating sa prefabricated solutions. Now, let's talk about data center spaces. So sa spaces, the typical ones you'll see, tatlo lang naman yan. You have the ballroom spaces kung saan naka-house yung ating mga precision air conditioning units at saka mga power distribution units. You have the hot aisle at saka cold aisle. Pinagkaiba lang kasi sa loob ng data centers, racks, sa loob ng white spaces, you need to have, you need to classify kung saan nagpo-flow yung init at lamig. Kasi syempre, if we're talking about IT racks, we're talking about servers, these are equipments that are very not only sensitive sa power disruption or power quality, they are also sensitive with environmental parameters as well. How humid, how hot, how cold. So during design, we classify the hot aisles and the cold aisles. Madalas yung hot aisles madalas nagkakaroon tayo ng containment aisle pa nga para hindi pumapasok yung mainit na hangin dun sa loob ng containment. So there are a lot of design considerations with this, but I'm leaving that with our mechanical engineering counterparts to study the CFLs and the heat load studies. Now we also have the gray areas. So sa gray areas, more or less you'll see all of the auxiliaries. Dito papasok yung generators, the UPS systems, the electrical switchgear, even the generator sets, and the pumping room. Okay, now different standards, of course, would entail different categories, but in most cases, the pagpapalit-palit natin sila. So we have the BICSI. I think for most telco guys na nandito ngayon, familiar sila sa BICSI standard. So class 0, class 1, class 2, class 3, class 4. More or less, this is talking about the network infrastructure. When we're talking about measurements or energy efficiency, we're talking about EN 5600. We're talking about TIA 942. This refers to the ratings. But then again, this all refers to the same idea. We have the N plus 1 or the shared redundancy. We have the N plus 1 na merong backup pagdating sa utilities, and we have the N after any failure. So wala kang single point of failure. So mamaya pakita ko yung single line. But power distribution path, you'll see here class tier 1 or tier 2 certification or tier 1, tier 2 topologies. Single path lang yan. Single path yung power. Tier 3 would refer to multiple path, pero isang active at isang alternate. And lastly, multipath would be referred to the simultaneous or yung naka-dual feed. let's focus more on kung ano yung madalas na ginagamit sa industry, which is the sa data center industry. I mean, let's talk about the Uptime Institute certifications. You'll see here an example of the topology of the power system ng Tier 1. So you'll see here the utility feed, you have the generator passing through the main distribution board, going to the UPS, isang UPS, going to the secondary distribution board and the PDUs, as well as the IT servers or IT loads. And you also have the power going to the mechanical load. Ngayon, ang problema ng ganitong type of architecture is that pagka namatay yung utility mo or pagka nag-maintain ka ng UPS, isa lang yung panggagalingan ng extra source mo. So, isa lang yung critical power backup mo. Ang pinaka-backup mo lang would be the generator set. Let's go to Tier 2. Sa Tier 2, ang pinagkaiba sa Tier 1, dalawa yung UPS mo. Pero sabay mong ginagamit. N+1. So, ibig sabihin ng N+1, kung meron kang 200 kilowatt na UPS, may isa ka pang 200 kilowatt na UPS. But you're using them simultaneously. Ang idea lang yan is that pag nasira yung UPS na isa, yung UPS number 2 can accommodate all of the loads going to the IT loads. So naka 50-50 sila. 50% yung loading capacity nila in cases of normal operation. Ngayon, pagka nagkaroon ka ng downtime pagdating sa nasira yung utility mo, nasira yung isang UPS mo, mini-maintain mo, kaya ka pa rin tumakbo ng ng 100% kasi may isa pang UPS na tumatakbo ngayon. Naka-partial redundancy ka. Now, we're talking about Tier 3. Medyo komplikado ang kanyang topology. Meron kang dalawang feed, meron kang UPS, and meron kang alternate source. So, para siyang dalawang Tier 1 na pinagtabi. Naka-mirror siya. So, ibig sabihin kung ano yung capacity ng transformer mo dito, ganun rin yung capacity ng transformer mo dito. Anong capacity ng genset mo, ganun rin yung capacity ng genset. And so on and so forth. The idea is that mawala man yung buong utility feed mo, mabubuhay pa rin ang IT load mo because of the utility feed number 2. So, by standard ng ating utilities dito sa Philippines, dati ang binibigyan lang ng ganitong type of feed is mga critical facilities, mga Bangko Sentral, Malacanang, and yung merong dalawang substation na feed na pinanggagalingan. Pero ngayon kasi because of the onset of the data center projects, depending on how big yung project is, they are now allowing this kind of topology. Ang pinagkaiba lang nito is that ito lang muna ang utility feed A lang muna, normal power A lang muna yung gagana. Naka-backup lang yung secondary, yung nasa pangalawang feed. Or pag mini-maintain natin yung mga facilities natin, yung switchgear, yung PDUs, yung UPS dito, pwede natin i-transfer papunta galing dito sa kabila yung power. Yung power source. And Tier 4, most simplest lang yan is that pareho sila ng itsura ng Tier 3 in terms of topology. Pero pagdating sa Tier 4, meron kang simultaneous feeding ng power for both the mechanical and the IT loads. Ang idea nito is that para mabawasan natin yung downtime during transferring and during unnecessary downtime. So makikita mo rito, sabay na gumagana, naka-dual feed siya, simultaneous yung power distribution niya and yung electrical path niya pagdating sa backbone. So may distribution, UPS, secondary, and then meron ka lang ditong transfer switching sa IT loads. Kung saan mo kukunin yung saan mo kukunin yung source mo. Manggagaling ba dito sa utility B o sa utility A? Simultaneous naman. Now, sa design kasi ng ng data centers, very critical yung yung dalawang approach to improving power reliability. We can approach it on the technology perspective. Ibig sabihin, the proper selection of components within the data centers, or the proper selection nung electrical systems and other components within data centers. And on the second level is that we're talking about the system level power continuity approach. So again, let's browse through this and let's see kung ano yung ano. Pero again, unahin ko muna ang technology level kasi medyo kumbaga this is the traditional way of making data centers reliable. So unahin natin si UPS kasi si UPS ang pinaka puso ng backup power pagdating sa data centers. So in the practice, there's two kinds. Actually, there are three kinds of UPS: the VI, the VFI, and the VD. So depending on which standard you're talking to, but in typical scenarios, UPSs are also classified in terms of their modularity. So you have the modular UPS and you have the standalone UPS. So pag sinabing standalone, these are the typical UPS that you'll see connected to your laptop or to your workstations. So when we say standalone UPS, pag if you want to expand the capacity, you add battery sources or you do some paralleling with reference to the same identical capacity ng UPS. So in terms of expansion, the standalone UPS will have horizontal scalability. Ibig sabihin, pag horizontal scalability, pag magdadagdag ka ng capacity, magpaparallel ka ng dalawang UPS. Now, there's such a thing as modular UPS. Ibig sabihin ng modular UPS is that parang Lego. Kumbaga, meron kang different modules within a certain, parang server siya. Meron kang different modules within a certain cabinet. So for example, in this scenario, you have 5 modules, 1, 2, 3, 4, 5. So in every module is a UPS of its own. So technically, pagka inalis mo tong isang module na to, mababawasan ka ng 50 kilowatt. Pag nagdagdag ka, dadagdag ka ng 50 kilowatt. This goes the same with this type of UPS na 200 kilowatt yung maximum niya, 20 kilowatt yung pwede mong idagdag. So in modular UPS, you would be able to do both vertical scalability and modular scalability. So nakakapag-parallel ka ng mga maliliit na na UPS na naka-mount sa cabinet niya, and pwede ka pang mag-parallel ng another cabinet for horizontal scalability. So for example, you have a UPS rated at 200 kilowatt pero 20 kilowatt lang yung module niya. So gusto nating siguro in 3 years we want to expand the capacity from 20 kilowatt to 60 kilowatt. So ang gagawin natin, bibili lang tayo ng 20 kilowatt modules, lalagay lang natin siya dito para ma-expand natin yung 60 kilowatt. On the other hand, pag dito tayo kumuha, pag naka-standalone ka na UPS, you'd be needing to do some paralleling. 2 UPS na kaagad o 3 UPS na kaagad yung ilalagay mo. This is an example of yung block diagram niya in terms of scalability. Kasi for example, again, we're talking about horizontal scalability. We do some paralleling. Kakain tayo ng footprint pagdating sa standalone. Pagdating naman sa modular UPS, of course, each module is a UPS of its own. It has its own rectifier, it has its own control logic display and chargers, etc., etc. So pag nasira yung isa dyan, gagana pa rin yung buong yung buong cabinet natin. Nasira tong 50 kilowatt, sasaluhin ng remaining 200 kilowatt yung capacity. And it's intelligent kasi we have the control display logic which can balance or which balances yung load distribution in each modules. Now, when we're talking about UPS, in most cases, especially for ABB, we're talking about how modular it is. So more or less, if you're talking about modular, this would help in improving the reliability of the system, primarily because if, for example, may nasira na isa, hindi mamamatay yung buong UPS system mo. This would prevent any untoward downtime. So with every UPS module has all the essential functions, eliminating any single point of failure. So lahat siya, lahat ng modules ng isang modular UPS would have the similar components within each module. This is also another advantage of using modular UPS, especially for hyperscale and co-location, yung online swappable module for continuous uptime. So again, we're talking about maintenance, we're talking about uptime. If may nasira, gusto natin palitan, gusto natin i-maintain yung UPS module na to, hahatakin lang natin siya without disrupting the whole operation of the UPS. So this would prevent any untoward downtime, thus guaranteeing yung maximum uptime ng ating IT systems. Of course, the ease of control and monitoring, and the time of service. So this will prevent yung pagbaba ng ating mean time between failure. So ano yan, this is an advantage pagdating sa certifications. This is another one, which is medium voltage one naman. Medyo malaki siya. Typically, ginamit natin siya to control the input power, the input voltage coming from the utility to prevent from sagging, especially for critical MV infrastructures. No. Of course, syempre, ang UPS will only power up within 15 minutes. The standard is 15 minutes. Swerte ka na kung ang data center owner is willing to invest on a 30-minute autonomy. Pero in most cases, it's just 15-minute autonomy. So, ang pinaka-function kasi ng UPS would be to provide backup power during downtime ng normal power, and for it to give more time for the facilities engineer to cold start the generator sets. Now, pagka bumalik na sa utility, you need something to help out in terms of transferring back from emergency power to normal power. And this goes the same, from normal power to emergency power. So you also need to consider the transfer switching technologies. Now, by practice, minsan ginagawa na naman to by design by the electrical engineers. In most cases, they do the design and the specification of the ATS and the transfer switches. There are cases wherein gagamit tayo ng traditional way of controlling the transfer switching of breakers using logics, and also using power contactor type solenoid. Difference lang would be, of course, for higher capacity, it's highly recommended that we still go with the breaker type, because we need the protection for the transformers. Pagka critical equipment na downstream papunta sa PDUs, it's best to use the solenoid type or the power contactor type. Pero technically, pareho lang naman sila. Mas mabilis lang ang transferring ng in-phase transfer ng power contactor type. By standard kasi tinitingnan natin yung yung tatlong parameters, yung frequency, phase angle, at saka yung voltage. Now, yung kanina, example lang naman yun ng approach to product level or technology level mitigation pagdating sa power continuity. Now, we can talk about now the system level. So, pagdating sa system level, this refers to multiple components within the data centers. So, for example, a combination of UPS and circuit breakers. So traditionally, our electrical engineering counterparts are doing the selective coordination study. So when we say selective coordination, the idea is that yung different circuit breakers are coordinated, wherein the circuit breaker protecting the fault, detecting the fault should be the one to trip. So for example, meron tayong trip dito sa downstream, dapat ang magti-trip is yung breaker na to, hindi yung breaker na nasa taas. So ang tendency pagka ito pag dito yung fault, tapos ang nag-trip is dito sa taas, lahat ng breakers natin, lahat ng power or lahat ng load dito sa branch na to or sa bus na to mamamatay kasi dito yung mapuputol na power. So pagka merong selective coordination, which is more or less ginagawa na rin naman natin in most critical facilities ngayon, pag dito nag-trip, dito nagkaroon ng fault, etong breaker lang tayo nagtitrip, buhay pa rin yung iba nating loads. So in most cases, ginagawa na natin to by practice, ginagawa na to ng ating mga kasama sa electrical engineering practice. There's only one thing that's missing. In all softwares, we're not coordinating the UPS and the breakers. Typically, it's just the breakers versus the breakers. We found out that if ganito yung scenario, there may be some cases na ang fault is nandito sa breaker sa UPS na to, pero ang nagtitrip itong nandito sa upstream natin. So there's a tendency that we need to consider also the protection within the circuit break within the UPS, kasi by theory ang standalone UPS pagka nagkaroon ka ng fault, lilipat siya sa bypass mode. So pag nagkaroon ka ng fault, of course, madali lang sa standalone UPS kasi isa lang ang single meron lang tayong single path of current during fault. So the circuit breaker, the circuit breaker output circuit breaker, the fuse ng UPS, and the bypass circuit breaker. Ang problema sa traditional way of doing selective coordination, ito lang yung kino-consider natin, output breaker at saka input breaker. But we're not considering the fuse protection ng UPS. So this is one way to up ng power reliability. We're talking about the whole coordination ng whole system. So we see here sa modular UPS medyo mas kakaiba kasi syempre modular ka, meron kang multiple UPS. So meron kang multiple UPS in one single cabinet going to one input bypass during fault. So again, we also need to consider yung multiple fuses within the different power modules. Again, this is not being considered kasi syempre availability of data, hindi natin nakukuha ang data ng bawat UPS manufacturer. So hindi talaga siya nagagawa. But for some cases, there are several tools on how to do it. We can do it on a calculation-based approach by calculating the let-through energy using energy selectivity, and we can do it using testing approach or destructive testing. Magpapasok ka ng different short circuit levels on different points of the power system. Now, this is medyo tinitingnan natin yung energy selectivity and yung time current curves ng different transformers and ng different circuit breakers and ng fuses. So again, for us electronics engineers, this is something good to know. It is something that probably we may need to understand kasi we're also talking about power electronics within the UPS. So we need to understand how it works in correlation to the protection devices externally located outside the UPS, the output at saka input breakers. So again, for this is something that we can study and see how we can adapt this to our upcoming and ongoing projects. So nandito rin naman yung formulas in how to do it. We just need to get all of the data coming from the fuse manufacturer nung UPS. Another approach would be system level. I think this time medyo magagamit yung ating knowledge in terms of communications kasi again yung mga bagong breakers ngayon would it's not breakers are now circuit breakers are now evolving. Medyo we're now talking about intelligence, and when we're talking about smart, we're talking intelligent, we're talking about communications, the capability of circuit breakers or any other devices to communicate with each other. So again, let's go back sa ating mga topologies. Typically, gagamit tayo ng digital selectivity in this level to prevent any unnecessary tripping ng mga circuit breakers downstream. So we again for us we classified this into 3. The essential ones is the traditional way of doing selectivity, katulad ng pinakita ko rin kanina, but this time with using the circuit breaker to breaker selectivity. Wala tayong kailangan any sort of communication devices or communication ports in order to do this. Again, this is the traditional way of doing it. We have the enhanced way where we're now considering the communication capabilities of the breakers. So with the availability of technology na nakakapag-communicate yung circuit breakers, we are now able to do 2 things: zone selectivity or digital selectivity and dual settings. Pagka nagkaroon ng change of source, of course you need to change yung settings ng ating mga breakers. So we are now using different communication protocols. I'm sure you're familiar with the IEC 61850. This is the major protocol pagdating sa smart substation automation or utilities. So sa low voltage side, this is also being used to coordinate between the low voltage and the medium voltage systems. Now, for digital selectivity or for enhanced selectivity, we're now using Ethernet protocols, communication ng breakers, at saka embedded technology, embedded watchdog within the breakers for uncompromised reliability. Again, we still are using the energy selectivity capability ng mga breakers, but then again, this is now being backed up by the digital selectivity capability. Ang idea nito is that sa energy selectivity kasi you need to oversize the upstream circuit breaker versus the branch circuit breaker. Kaya ka merong circuit breaker at saka molded case circuit breaker. Sa enhanced selectivity or sa digital selectivity, gagamit tayo ng logic instead of we're still using the electrical parameters of the breakers, but again, we are now using the logic to control the system behavior. So kung mayroong kailangan mag-trip, siya lang yung mag-trip at magsasend siya ng signal, ng non-tripping signal papunta sa mga breakers. Sasabihin niya na huwag kayo mag-trip, ako lang yung magde-trip. Using communications. Hindi tayo gagamit ng hindi na siya via measurements, so the typical way of doing it. So again, aside from the power connection that you have here, you also have the communication connections. So lahat ng breakers na to nag-uusap, hindi lang dahil nagpapakiramdaman sila dahil mataas na yung current, pero nag-uusap talaga sila because alam nila kung ano yung nangyayari within the system. And this is one critical way of doing zone selectivity. So in this scenario, we are able to increase yung instantaneous speed, yung speed ng instantaneous stripping natin ng upstream while still guaranteeing yung ating energy selectivity. So in cases na magkaroon ng fault dito, si circuit breaker D magsasend siya ng signal kay circuit breaker E at saka circuit breaker F na circuit breaker E, circuit breaker F, wag kayo mag-open kasi nandito yung fault. Ako lang dapat ang mag-open. Instead of doing the traditional way of measuring the short circuit and letting the electrical parameters of the cables set in. Okay, so different types of communication. Again, we're talking about the traditional way of doing digital selectivity using 24 volts. There's what you call the IECEP link protocol, and there's what you call the IEC 61850 communication protocol. So there are different possibilities. So meron tayong different options in doing digital selectivity, thus helping out in improving power reliability in facilities. So the traditional architecture, pag gumamit ng 24 volts, of course, low-level interfacing ang ginagamit natin dito. Ang dami nating kable na gagamit. Magpapadala ka ng kable papunta dito sa breaker na to, magpapadala ka ng kable papunta dito, and so on and so forth. Now, if we're using the Ethernet capability, we're using the physical layer ng ating OSI layer using the Ethernet cable within 100 meters using router switch, we are able to do communication, simplify the cabling while enhancing the capability of the circuit breakers in terms of selective coordination. Again, in terms of advantages, disadvantages, the traditional way of doing this using 24 volts cable, 24 volts signal, you need to have 3 cables in order to provide or extract data. You need digital input, digital output. So medyo marami kang kable. Medyo malayo lang siya, 300 meters, kasi nga digital signal siya. Low resistance to disturbances. Complex kasi marami kang kable na kailangan i-test. So medyo mahaba-haba yung testing mo. Now, if we're talking about Ethernet capability, 100 meters lang, pero although power systems naman usually hindi naman lumalagpas ng 100 meters in distances niyan. So pasok ka pa rin. Pero pag gumamit ka ng fiber, of course, we can improve the distance to 100 kilometers. Of course, since communication siya, ang downside lang will be disturbance. Of course, high availability and mas simple yung kanyang testing. This is also because of this capability, we are also able to do directional protection. When we say directional protection, this goes without saying na pagka nagkaroon ka na ng grid tie interaction, grid tie solar or grid tie renewable energy, you are able to have parang may mesh ka na, so you are able to detect yung flow ng fault. Thus, you are able to provide signals. So pag sinabing may fault dito, malalaman mo kung upstream or downstream. Ito sa example. So meron tayong dalawang source of energy, simultaneous gumagana, nagkaroon ng fault. So we are able to detect yung circuit breaker mismo is able to detect yung flow nung fault because of the directional capability, and thus would be able to provide yung directional selectivity. Ibig sabihin, this circuit breaker can provide signal going up or going down. For in this scenario, going down yung signal niya papunta sa sa QF3, QF4 at saka QF2. And then in this scenario, si QF2 pababa rin yung signal niya. So medyo kumbaga mas precise yung ating detection ng ating short circuits. And lastly, of course, when we talk about selectivity, we're talking about also redundancy. So again, sa different communication protocols, we are able to have multiple communication links as well. So in this scenario, you'll see two communication links, one using the IEC 61850, the other using another protocol like IECEP link or probably Modbus RTU. In this scenario, pag may naputol na, if there's a cable na naputol, we are able to guarantee still the connectivity between the different breakers because of the redundancy ng communications. So most circuit breakers can accommodate up to maximum of 3 communication protocols. So hanggang triple redundancy pwede siya. But then again, medyo may kamahalan na. So probably for this scenario, we can just do two communication protocols. And this would enhance, of course, in terms of tiering, syempre, for the tier 1 and tier 2, of course, bakit tayo mag-invest sa enhanced selectivity? We can just go with the traditional way of doing coordination studies, while for concurrently maintainable tier 3 and tier 4, it is advisable to go with the digital selectivity aside from the traditional selectivities, dahil of course you need faster way of detecting and faster way of isolating yung faults. I think I'm on my last topic. So aside from the system level approach pagdating sa selectivity, we also have the approach to digitalization. This is the one of the more important trends that we are seeing. We are now able to communicate different devices in one interface. Again, different capabilities for communications. You have different communication protocols, Ethernet IP, Profinet, Modbus TCP, or Modbus RTU. So it depends on what requirements we have. We are able to communicate with different devices. This is actually already a need, especially for hyperscale data centers, wherein you need to have continuous monitoring of the asset health. So what you see here, an indicator, for example, if all of the assets are connected, you'll see here a percentage of a certain health of the asset. And this is also one way of predicting any issues that may arise. So for example, you have here a certain circuit breaker, for example, that's not maintained from 2014 to 2020. You'll see here na nagde-degrade talaga ang buhay ng isang circuit breaker, ang capability nito to protect. But during this time, when we do some preventive maintenance or predictive maintenance, tightening, cleaning, we are able to increase the capability of the breaker. And you will see here, 90%. This was back to 90+% in terms of health. And because of different algorithms in terms of digitalization of asset monitoring, you are able to predict and prevent any untoward incidents, especially for the power systems, the protection systems, even the UPS and other auxiliary systems within the supporting the IT infrastructure within the data centers. So this would provide back lesser maintenance frequency, which reduces yung cost pagdating sa pagpasok at paglabas ng mga tao within the data center facility, and also helps in extending the life cycle of the power system. So with this, I'd like to close this off with a summary wherein I'd like to put emphasis on the number one priority in the data centers. Tatlo yan, di ba? Uptime, resiliency, and uptime, scalability, and sustainability. But number one, first of all, would be resiliency. Of course, we need to have data centers that are reliable, that are available, and that are resilient. And one way to do this is we can do system level approach, or equipment level, or technology level approach in ensuring maximum reliability of data centers, as well as digitalizing the infrastructure within the data centers to bring about their opportunities in terms of asset monitoring, asset management, and of course, most importantly, the sustainability and power reliability of the facilities. So with this, I'd like to congratulate our colleagues in the IECEP Power Electronics Society for a successful colloquium, and thank you so much for inviting us. Here's my contact details. If there are any questions, we can probably answer it after this session. So I'd also be providing a copy of this presentation to the organizers so that you can probably review it at your most convenient time. So with this, thank you so much, and back to you po, Engineer Donna or Engineer Tony, Engineer Russ. Thank you po.
Okay, all right. Engineer Job, we are very thankful for your unending support to the society. And your knowledge, your knowledge sharing to our Filipino IECEP, it was outstanding presentation, easy to navigate. But before we do the Q&A, please prepare the Q&A, our master. Before that, I would like to ask the attendees, can you enumerate or inject some international standard for data centers you know? Please chat in your chat. Please, do you have any international standard you know? Maybe from your school, from your colleagues, or anything. Is there anyone knows it? What are the international standard what we follow? Okay, by the way, while waiting for that inputs, by the way, engineer job as well, yours, we are part of the data center developed by our IECEP. Well, it will be released soon. It will be IECEP data center best practices. So hopefully it will become true. So Big C, one say Big C from Engineer Kadahang. So Big C is one good also. So there's so many plethora of international standards. However, the Electronic Institute or the IECEP, we adopted some standard and developed for Philippine environment. So hopefully it will come soon. Now let's go to our let's say, okay, we'll proceed first with the Q&A. So Q&A for this, let's say, what are those? Please, Zoom Master, zoom in. First question, engineer job. Let's see. And before engineer job, this is for you. While waiting for the question. Yes, Zoom Master, question 1. Please. Question number 1. Engineer Donna, are you still with us? Please acknowledge. So do we have some questions?
Yes. Yes, Engineer Russ, I'm here.
Yes, go. Yes, thank you for that. Engineer, by the way, is my co-host. So question number 1. Let's Zoom Master, please do so. So Big C, some are gold-based standard data center. So by the way,
I think we need to wait for our moderator to type in questions.
Yes, we have now.
Okay, there's question number 1.
Yes, go ahead, Engineer Donna. Do so.
Okay, for question number 1, for what happened to KAAP, what do you think were the problems? What will KAAP need to do to prevent this kind of downtime? What will be the best solution you can recommend? Thanks. Engineer Job?
Well, actually, for the KAAP incident, well, for the KAAP, kasi I was also involved in one of the, I'm also working with some of the government agencies in investigating this. So I think I'm not yet at liberty to to provide any information on this. However, one thing that we can see here is that of course there may be some slight concerns in terms of how the facility was maintained. But then again, I'd refer to the formal report to be submitted by the CICC and the rest of the government agencies on this. Medyo, medyo conflicting. I cannot really provide any information on this. Apologies, Sir Joey. Thank you.
Well noted, Engineer Job. Okay, thank you for that.
We understand.
Yes, really.
Because that issue from KAAP is very controversial. So we understand, Engineer Job. For question number 2, for network equipments, data center, OLT, switches, majority of the harmonics are present affects energy efficiency as observed. Oh, I think there's a glitch. Question number 2, please.
I think
as observed through PQA. Can you share some inputs? Best practices to reduce, sir? Thank you. Do I need to reread it again?
No need po, Engineer Donna. Thank you po. So, for hello.
Yes, loud and clear, Engineer Job.
Okay, perfect. Yeah. So one thing's for sure, definitely for electronics equipment, medyo ano siya, mataas talaga. Actually, source talaga siya ng power quality issues. Specifically for total harmonics distortion on current. dahil considered siya as non-linear load. There's actually no way in reducing this on an equipment level. However, there's a way of ensuring that the harmonics generated by the sources are limited. So again, on the level of the UPS going to the servers alone, you are already able to measure yung power quality nito. And ideally, in order to effectively measure yung losses, you'd be needing different points of measurements in terms of the location. So you need to have power quality analyzer at the point of common coupling pagdating sa transformer side going down to the low voltage switchgear side. You'd need to have a power quality analyzer at the input of the UPS, and you would need to have another one at the output going to the servers. This would guarantee the proper measurement and at the same time provide the better insights in how to handle yung power quality issues. Kasi hindi natin maalis ang harmonics, nandiyan na siya. It's really how you deal with it after you know what's already there. So yun. So I think the best practice is really to have the different measuring devices there. Understand kung kailan siya nagkakaroon ng peak, kailan siya nagkakaroon ng sudden surges due to harmonics, and if there's a need for harmonic filters, improve yung technology ng servers and ng IT equipment, go for that. Better check yung equipment na ginagamit dun sa sa ating mga IT servers, kasi most of them naman are within standards in terms of EMC, EMI, and the harmonics. May may standard tests naman bago ilabas sa market. So go for those that are tested na already on those standards.
Okay, thank you very much, Engineer Job. So at least we have one more question. Zoom Master, please flash in the question number 3. Okay, General, I will do for you. Question number 3, here we go. Are there some sort of latency requirement for the TCP/IP link?
Okay. Yes. Actually, the latency is pretty much the same as what we're experiencing with the typical Ethernet connectivity. The only difference is that when we're talking about IECEP link, medyo secured yung yung data niya. So we're not only using the TCP/IP layer, we're having the headers and yung iba pang mga processes natin. We're also using some sort of some sort of encrypting the data for cybersecurity, kasi ang IECEP link is proprietary within the ABB. So pag ABB yung gamit natin, mas mabilis yung communication niya. And the problem lang with IECEP link, yung brand ng circuit breakers hindi mo connect. That's why we're going to IEC 61850 or the Ethernet protocol. If there are other third-party components connecting to the network.
Okay, thank you, Engineer Job. I think, Engineer Job, your topic was very interesting, a phenomenal topic. So if you can see in the chat box, so what happened in Philippines, only as let's wait for the final summary of the government. But if you see in the chat box, it's helping them what really happens there. Okay, Zoom Master, do we have one question more to go before we proceed for the awarding of appreciation to our technical speaker? Do we have? Okay, I think we don't have. Okay, let's proceed with the awarding of certificate appreciation to our technical speaker. Now I would like to call in Engineer Alvin de Guzman, the Vice Governor of IECEP Mindoro, for the awarding of certificate. Engineer Alvin, the e-space is yours.
Thank you very much, Engineer Ross, the very energetic host for today. And it is once again a pleasure to present this certificate of appreciation to our esteemed IECEP colleague and the speaker for today. So if we can please flash the certificate for everyone to see. Our technical team, please. Yeah, thank you very much. So the Institute of Electronics Engineers of the Philippines Incorporated, Power Electronics Society, presents this certificate of appreciation To Engineer Job R. Mayo IV, in sincere acknowledgement of his invaluable contribution as a resource speaker for the third colloquium on power and clean energy with the topic Power Continuity in Critical Infrastructure, given this 11th day of February 2023. This certificate is signed by the following IECEP chapter governors: Engineer Christian Enoval of Bulacan, Engineer Gerald Jackson of Mindoro, Engineer Muhammad Ali Mauna of KSA-ERC, Dr. Jodelix Sarcilia of Cavite, Engineer Teofilo Lorenzo Oquinco III of Manila, and finally by the chair of IECEP Power Electronics Society, Engineer Mark Philip Fernandez. So once again, Engineer Job, please accept this certificate of appreciation, and thank you very much.
Thank you po. Thank you po.
Yes, Engineer Job. Thank you very much. Engineer Donna, go ahead, Engineer Donna.
Thank you very much, Engineer Job. And to introduce our resource speaker for this afternoon, let me call on Engineer Giancarlo A. Banao, the Director of Finance from IECEP Manila. Engineer Gian, the floor is yours.
Engineer Donna. Okay, good afternoon, ladies and gentlemen. It's a great pleasure and honor for me to introduce our next speaker, who is going to discuss space microgrids related to neuroscience and artificial intelligence, which for me, it's highly interesting and innovative in nature. Our speaker for today received his bachelor's degree in telecommunications engineering, Master of Science degree in electronics engineering, and doctoral degree in power electronics from the Technical University of Catalonia in Barcelona in 1997, 2000, and 2003, respectively. He is an outstanding professor at different universities. He's a full professor at the Department of Energy Technology of Aalborg University in Denmark since 2011, where he is responsible also for the microgrid research program. He has been the chair professor at Shandong University since 2014. He has been a distinguished guest professor at Hunan University since 2015. He also been a visiting professor fellow at Aston University in the UK and a guest professor at Nanjing University of Post and Telecommunications since 2016. He became a Willem investigator by the Willem Fonden, which supports the Center for Research on Microgrids, or CROM, at Aalborg University. And that being said, he's actually the founder and the director of CROM. His contributions to research and teaching have been invaluable to our fellow researchers and engineers. In fact, he has published more than 600 journal articles in the fields of microgrids and renewable energy systems, which are cited more than 50,000 times. His research interests include different microgrid aspects, including power electronics, distributed energy storage systems, hierarchical and cooperative control, energy management systems, smart metering, the Internet of Things for AC-DC microgrid clusters, and islanded mini-grids. He focused also especially on microgrid technologies applied to offshore wind, maritime, microgrids for electrical ships, vessels, ferries, and seaports, and even in space, space microgrids applied to nanosatellites and spacecraft. With this, in 2015, he was elevated to an IEEE Fellow for his contribution to distributed power systems and microgrids. His works are highly recognized and awarded over the years. He received the Best Paper Award of the IEEE Transactions on Energy Conversion from 2014 to 2015. Best Paper Prize of IEEE PS Power and Energy Society in 2015. He also received the Best Paper Award from the Journal of Power Electronics in 2016. During 6 consecutive years from 2014 to 2019, he was awarded by Clarivate Analytics, formerly known as Thomson Reuters, as a highly cited researcher with 50 highly cited papers. Now, he is currently an associate editor for a number of IEEE transactions. Indeed, our speaker for today is highly exceptional, and we are all lucky to have him today. So, ladies and gentlemen, all eyes and ears to our last speaker, Professor Dr. Joseph M. Guerrero.
Yes, thank you very much for the introduction. I'm going to share now my screen. I think now you can you see it.
Dr. Joseph, we're still not seeing your PowerPoint.
Okay.
I think you're using two monitor. Just swap it. That's it. Okay.
Probably will have
Last time.
to.
Okay, now it's loading. Go ahead, Dr. Joseph.
Yeah. Can you see the screen now?
Yes, vivid.
Yes, Dr. Joseph.
Okay, excellent. So I'm going to talk here about neuroscience-inspired artificial intelligence and large-scale neural networks, especially artificial intelligence. So, and then how these large-scale brain models has been impact also the space microgrids. If you want to know more about also our research on microgrids, here you can see our website, which is Chrome, ETAAUDK, or you can just drop me an email. I want to also dedicate this talk to my wife and our newborn, which is right now here with me. Until now he was sleeping, but now wake up. And also to our members, we are like 50 people working on several aspects of microgrids. Our DNA is to have research as a way of think and dream and to think out of the box. I want to start with a foreword of Santiago Ramón y Cajal, who said, as long as our brain is a mystery, the universe, the reflection of the structure of the brain, will also be a mystery. So in this talk, indeed, I wanted to merge both worlds, space and neuroscience. I hope I can do it. About the microgrids, yeah, many people is talking about electricity and energy consumption, storage, and generation very close to each other, as we have seen in other presentations. But here I want to present something else, which is thinking that it's not only energy, it's also heat, it's also data. It could also be hydrogen in the next future, like methanol and many other, not only hydrogen, because of hydrogen, but also hydrogen to produce e-methanol. So that's also something really important here. So then you can see another important thing, it's water microgrids. That means that if we think about water systems, we could have also main supply systems like electric systems, and then we can have also site treatment, storage, and consumption. Yeah. Then, if you see here the other slide, we could have also biological microgrids. That comes from another project I will explain a little bit later, in which we can produce biological microgrid systems that could, for instance, fit the astronauts that goes to future lunar base or space stations. We could think also that microgrids could work like our body cells. So having bio-inspiration, thinking that it could be energy factory, product factory, nutrient factory, and water factory, the same as the exchange that we have with our body cells. So biomimetics is becoming very, very important topic in microgrids. The other thing it's talking about blockchain and transactive energy trading. It has been many work, working on modeling and simulation. We are proud to be the first ones to implement this in hardware and make tests. This is going to be a very important topic in the future. Today also appear recently some papers. This is from a paper in the Nature related to bioenergy and wearables. So that means that the same way that we think about a microgrid in a city, for instance, it could be in our body. So thinking that we can have energy harvesting systems, we could have also energy storage systems, and those wearables that we could feed with that electricity. Yeah, I'm assuming that everyone is seeing the slides. So, and then another important thing, it's maritime microgrid. So electrification in ships. We are proud to be the first ones to participate in a project of the first hybrid electric ferry in Asia, which was placed in Taiwan. And also we are developing many electrification issues on seaports. If you have questions about this, I'm open to discuss this at the end of my presentation, because I will just be focused on more on the space. The other thing it's talking about aerospace is the aerospatial things. So regarding airports, not only seaports, but also airports are very electrical demanding. And then also we can see that the aircrafts are becoming more electric as well. We are now starting a big project with big companies here in Europe to develop a prototype of more electric aircraft. And we can see that there's many efforts going in this direction. So this is something that it's becoming more and more important to have also fuels that can fit that aircrafts that could come from, for instance, hydrogen and then processing with methanol. So we could have green methanol systems to fit in the aircrafts, but also it's going to be another important thing to have more electric systems inside the aircraft. Then the focus of today's talk, one part is going to be the space microgrid systems. So what is going to satellites, especially electric systems in satellites, how we see those as microgrids. Then the space stations, how this is becoming something very important beyond the International Space Station, which I'm going to present a little bit the electric system. And then I'm going to talk about future lunar bases that probably it's going to be translated, if possible, to Mars bases. Another very important thing also, it's that we recently translate all these, let's say, concepts also to smart medical systems. We can conceive our body as a microgrid in which the vessels are transporting the blood, a little bit like power systems, and then we have nerves as communication systems and so on. So it's really a distributed system, as I'm going to show a little bit later. So things like having digital twins for medical systems, EEGs integrated to check the health of people, maybe with wearables and so on, it's become very, very much important. Also, bio-inspired artificial intelligence is becoming something really important these days, not only for these kind of systems, electric systems, but also medical systems. So that's something really exciting. And talking about inspiration, also quantum computing, it's something very trendy. We have been published the first papers on testing algorithms on quantum computing, especially for power systems. And we are using an IBM quantum computer for do this kind of computations. Also, DNA computing is becoming very important, especially when you need to store huge amount of data. Yeah. And then, yes, talking about artificial intelligence, we talk a lot about these topics. It looks like it's an algorithm that someone made, but if we want to understand much better, we need to understand how our brain works. And indeed, our brain cannot be separated from our body. So we think about the brain, we have like 86,000 million neurons just here in the scalp. But then in our body, we have many other neurons. So we have like 40,000 neurons in our heart. And then in our digestive system, we have 500 million neurons, which is the same amount as neurons have a cat. So that's very important. that's why it's so important right now, all the research that is ongoing with macrobiotics and how what we eat affects our psychology. So indeed, everything it's really a very distributed system. We have some parts centralized, but it's really amazing. And then the other thing, it's when we look on how it looks inside, also the brain, we have several parts. One of them, for instance, this is what is called also the small brain, which is the cerebellum, in which we have automatic actions like, control the body temperature, control the heartbeats, all this that goes automatically, it's placed there. And then we have all this part, especially, let's say, the amygdala, which plays the game of, how to say, emotional brain. So that all these emotions are taking part here. Of course, there are some of them also in the heart, let's say, especially feelings and in the digestion system. We can feel this every day. So then this means that this basal ganglia part, it's connected to also movement and reward. I will show you a little bit more about this, but that limbic system we can see that is like the emotional brain. And then this other part, it's part of, let's call the rational brain, but also it's connected to all the parts that are, let's say, governing different aspects. So that's what we call also the associative parts of the brain. You can see here in this small video, two neurons communicating each other. I think it's very important to understand that our brain is not electric. Electric brains were just supposed to be used for very ancient animals. But in our case, we have brain, which it's making this communication between neurons through synapses. And what we use is neurotransmitters to activate this communication. So neurotransmitters are there, and it's our body who produces that. Another very interesting thing is to observe that ancient cultures, like for instance, Indians with chakras, they put all these chakras in places in which you have a lot of density, high density, let's say, of neurons. So that could be something really interesting to see. And then we can use, for instance, some easy bands, like I'm using here in this photo, or more complex, like 64 channels EEG bands, in which we can see the different waves of our brain very easily. So in normal adults' brain waves, what we have is, when we are awake, we have very high frequency waves between 14 and 30 hertz, which is called beta waves. And then when we are awaking, we have the alpha ones. And then sleeping, we have the theta ones. For the sleep, we have several levels. And you can see stage 1, 2, 3, 4. So, and there is only one level in which we call REM sleep, which is also called the paradoxal sleep. It's a moment in which we are producing waves that are very similar as when we are awake. That's why it's called also paradoxal. And our eyes start to move. That's why it's called REM stage, which called remote eyes movement. So that's something really interesting to see. Also, a lot of research is going to this REM stage today. The other important thing is how much we use our brains. In the past, we thought that maybe we can use 5%, 10%. If you see, for instance, a movie called Lucy, it tried to explain this old-fashioned theory, but today we know that it's not true. We are indeed using 100% of our brains. So that's amazing. We have to be very relaxed about this. The only point is that we just can use simultaneously 2%. And this is because glucose and oxygen limitation. So it's like blinking, imagine 4 watts of electricity in our brains. However, normally we know that we use similar neural network paths. That's why some people think that it's difficult to change, but today we know that it's not true. We are changing this structure the whole life. So from when we are born until the end of our days, this brain structure is changing. So it's not like a hardware in which is fixed, and then we have software that is running over it. It's software that changes the hardware. So every time we have a thought, we reinforce new synapses and connections between neurons. I will say that this is really exciting to see how this is going. This is a very old model for the brain, in which we have like 3 levels. Reptilian one, which is more about the cerebellum, more automatic control, let's say, because it's not true that only reptilians had that. And then we have the limbic brain, which is more the emotional part. And then we have the neocortex part, more developed, especially this frontal part in humans, the one who allows you to go into the future, come back to the present moment, and take decisions. Yes, so taking these 3 levels, also you can see how some specialization of learning algorithms can be also placed in these 3 domains. So if you look on this old paper from Professor Doya, you can see that cerebellum can be like supervised learning, so automatic control systems. And then we have here the basal ganglia with the thalamus. The thalamus work like a hub of connections. So all the sensations goes to this gateway, let's say, better, except the smell, which goes directly. Yeah, this explains a lot of things. And then the basal ganglia, it's the one who have the reinforcement learning. This means that when I'm doing something that is very, I like to do it very much, I will start generating dopamine. So dopamine will give me as a reward. And this reward will reinforce what I'm learning. That is called also reinforcement learning. So now you know how it works. It's basically I do something that I like, then I can learn it better and better. Of course, this is also, it has another side, which is like, if I like to see movies, I will start to generate dopamine. So I need to see more and more movies so I can be addicted. So addictions are also going to this side. We have to be very careful on this. But now you know what's reinforcement learning. Many people think, oh, it's just an algorithm. No, it's something that comes from biology, and we need to understand that doing things that you like, it's the best way to learn. And I think that's a very important message from nature. And then we have the cerebral cortex, which is more unsupervised learning. In the old times, we had something called the phrenology, in which they thought that some parts of the brain corresponds to different things, like this part maybe memory, this part friendship, etc. So just by looking at your school, they could think, okay, more or less, how is your personality? We know today that this is not true, but later on, at the beginning of the last century, Dr. Brodmann, what did is to start classifying all the different parts of the brain. So this way, especially what is the cortex, and he did this just, let's say, dividing it, but then we could see, like, we could see that indeed this brain works like something that we call also small world network. This is something that happened also with social networks. Like, imagine that I want to connect with Elon Musk. For sure, I know someone that knows someone that knows someone, just in less than 6 steps, that knows Elon Musk. So that's because social networks have small world network properties. But I will say that brain is a little bit more complex. So they have also something that we call also scale-free networks, which means that we have networks with, or nodes with a lot of connectivity. So we have both. We have small world networks inside, and we have also scale-free networks connecting the different parts. So that I will say that this gives a very exciting vision of the brain, more from the engineering and connecting with the graph theory. So everyone, let's say, that is maybe working with electric engineering or telecom engineering knows about graph theory, and they can define, let's say, the different networks as nodes, different nodes that are connected with edges. And then we have parts that could be like, imagine distribution networks, like we could divide as modules. So a little bit, the brain works like this. They are different networks interconnected. You have a lot of, let's say, communications inside and not so much outside. What you have outside is just synchronization. So thanks to that, today we know, and we have been developed some models, and you can see a little bit, this is a little bit a sketch of the process of how to do that with just taking the different bands that we have seen of the waves, theta bands, alpha bands, beta bands, and to see the coherence between those waveforms. And today, in cooperation with many universities, what is being to establish is what we call the human connectome. So this means that we will be able, in the next future, to have a total map of our brains. Today, this is possible with very simple animals, but the target is to go and have connectomics of the human brain. And then the other thing, and then the other thing, it's what we call also large-scale brain networks, because we know today that many people is using neural networks, but I will say that the really breakthrough that we can have in this research is to have large-scale networks, because this is the way that our brain really works. So it's not like having very simple systems. It's to have, for instance, one of these large-scale brain networks is what it's called also the default mode network. For instance, when I'm driving and thinking of something else, and then I arrive home and I don't remember what happened during my driving time, then it's because I was using what is called also default mode network. So, and this is really dangerous, you know. So especially people that used to make meditation, they are able to disconnect this network. But there are many others, and I think Professor Menon also made a very nice classification with 6 or from 6 to 10. It depends on how you define the functions. But we have a salience network. This one, what it's doing is to, when you are not focused, so doing something and thinking about something else, then you are able, by using the salience network, to switch to the central executive network, which is the one who allows you to focus, be focused, right? And then the other thing is that we, in this other paper, it has been also classified the emotions. People think that emotions are something strange and there's no science behind. There is indeed science. So in this paper, they could classify on different emotions like anger, disgust, fear, happiness, sadness, and surprise. And they could see that these networks, the way that the brain is working, is like a small world network. So indeed, they are able also to connect different parts of this brain, synchronize and coordinate them. So this is really an exciting thing. Some people also think that stress is not good, and I'm sorry to say, but there is an optimum. So very low levels of stress, it's not good at all, because you know, when you have some levels of stress, you are generating basically 2 important neurotransmitters. So to generate the transmission, you need, for instance, dopamine, and this one, with moderate levels of stress, you can generate, and this is the way that you have more motivation and you can learn better. The other one is the noradrenaline, which increases the alert state and attention. Of course, if you increase so much this, then you can arrive to the phenomena of burnout, anxiety, panic, anger, violence, and so on, right? So that's really interesting to see. And also the other important thing to understand is that we have different ways of processed information. Like when we have we are seeing at something, then I'm going to change the mode. then when you are looking at something, then you can have two ways of processing it. One way is what we call the wear pathway, which is the dorsal one. It's, for instance, in the bottom of your scalp. And then the other, which is in the top of your scalp, it's what we call the ventral pathway, which is the what. So we are processing where is this place, the same that he's doing when he's looking at me. Where are you and who are you? And those are different pathways, right? And then these two pathways go through the same place, which is the prefrontal part. I think that this is really exciting. And also thanks to understanding this, today we are able to make bands and to control, for instance, drones just by thinking, going up or down. And this is because we identified one part, which is the primary motor cortex, which allows us to see the different places in which our brain can control the different parts of our body. So thanks to that also, very recent research has been done also with artificial legs or arms, or even additional fingers, like a sixth finger. Yes, well, if you want to know more, maybe I will wrap that at the end. But now I need to jump to the space. So I'm going to talk a little bit how microgrids are going to the space, and then I will see how neuroscience inspiration can go there. So yes, on the one hand, in the space, I will say that we have three main ideas. One is more on nanosatellites or satellites, in which what we have indeed are microgrid systems, because they are photovoltaic panels, let's say. But these photovoltaic panels, as you don't have the atmosphere, you can receive 20 to 30% more energy than in the Earth. So this is really good because you can have more energy. The problem here is that you are being shot by electrons and protons from the sun and from the cosmic radiation. So this means that photovoltaics becomes worse and worse. Indeed, there's a drop down of efficiency, and this is not good. The other part is that we can have also higher efficiency solar cells to have triple junctions, or today we have also 4 junctions. You can see these are the different elements of an electric system of a satellite. And indeed, all the control system cannot be made by digital controllers, because cosmic radiation will also impact and will hang up computers. So a lot of analog electronics are needed here. And this is, I will say that this is really nice. And you can see also the raise of efficiencies also. In the last years, going beyond 30%. And this is really good. And the other good news are that electric vehicles are pushing lithium-ion batteries, and these are the same batteries that we are using also in space. So that's something very nice, because, you know, especially when we talk about geostationary satellites, we need to support eclipses almost every day, because we have an eclipse between, let's say, eclipsing the sun with the Earth, and the satellite is here. So we need really to support long time eclipses. And well, that's a little bit about the different topics that you can have. I will skip this. These are just details, but just keep in mind that here our problem is cosmic radiation, which is impacting photovoltaics efficiency and the electric, let's say the electric control system. Yeah, we published this also in another paper, so you can also find it. The second thing we talk about the space is the International Space Station. And we are talking about the International Space Station now because some companies are coming with ideas having private International Space Stations. Also, the Chinese are coming with the Tiangong 1 and probably Tiangong 2. So that's something really nice that you can see that is going. If you look on the ISS, the International Space Station, they have been replaced the old-fashioned batteries with lithium-ion batteries. And in the past, it was an AC system, and they have been fully changed by a DC system. So it's basically DC system working around 150, 170 volt and one direction, because efficiency is much better. You just have bidirectionality here in the batteries because you need it, but all the other converters are unidirectional, having the best efficiency possible for that. Now we move to the future lunar bases. This is another study that we made, and I think that this is really exciting because now a lot of people are talking about going to the moon and having, let's say, a base there. And we know that this is something difficult, because if you want to have long stay periods, then maybe your muscles may have problems. So still, we are not sure about these extended periods, but for sure it will be some base there to go for some periods of time. Non-polar regions are not interesting because you have dark periods of around 15 days. So you have 15 days of sun, 15 days of darkness. This means that you will need huge amount of energy storage systems, which is not good. And then the polar regions become the more attractive ones. We have on the South Pole, the Shackleton crater, which is the one maybe the most studied by NASA in the last 15 years. And it's going to be maybe one of the first moon-based. And then we have another one recently also has been studied a lot, which is the Fury crater in the North Pole. So you can see these red points are the most illuminated areas of the craters. And then you can see if we want to collect photovoltaic systems, we need to build some towers. Of course, this is very horizontal because we are in a very high or low latitude, right? And this is 1 month illumination equivalent for the Shackleton crater. So you can see here in the crown, which is very good for photovoltaic systems. Now, when we look on the lunar base system, how it's going to be used, of course, there are still people saying that they will put maybe small nuclear reactors, but I think it's really stupid to think that something that we know that in the Earth gives us a lot of problems, to put it in the moon. So definitively, solar energy is the winner, and we believe that we need to push it. No radiation, it's really light, and it's really very friendly. The same thing happens with energy storage. So lithium-ion batteries are nice, but still they are very heavy. So also to have hydrogen, especially Japanese with the JAXA agency, they studied a lot what we call also regenerative fuel cells. So they are kind of able to generate hydrogen and then use the other hydrogen to generate back electricity. So they are very nice for these applications. And then we have the crew habitats. This is really nice because here we have to generate the oxygen and remove the CO2 and generate a little bit an artificial ecosystem. I'm going to explain this. And then another important thing that is going to happen is that the moon is going to have its own internet. It's going to call LunaNet. So LunaNet is going to be the internet of the moon, and there is many research also ongoing these days. And then all about pressurized electric vehicles. Today's are very important. So you can see that in the moon or in the space, everything has to be renewable. So there is no way that we can put diesel generators or combustion engines. So I think that this is really nice photovoltaic systems, electric vehicles, and so on. It's something that will come back to the Earth someday. And so it really worth to explore this, especially to have not only single microgrids, but also multiple microgrids, as we did in our study, in which we could supply the habitats, laboratories, and charging stations with multiple, let's say, DC microgrid systems interconnected between them. And then, of course, all these are the rovers or electric vehicles. This is another very important topic. The last topic I want to show is about to create biological ecosystems. And this is a work that we did with the European Space Agency. And I think that this is really interesting because we are creating artificial ecosystems, because we need to support to the astronauts with water and food. And of course, the astronauts generate heat, CO2, respiration, urine, as everyone do, fecals, etc. So all these things we have to recycle in an ecosystem. And you can see here some of the pictures that we have here. It's the nitrification compartment, which is from giving nitrates to the photobioreactors, in which we have a number of microalgae, which generates the photosynthesis. So they take the photons from the lights, and they are able to generate oxygen, and we store this oxygen in oxygen tanks. And then we have higher plants also for our astronauts, and today our astronauts are rats, so the equivalent more or less is 40 rats, one astronaut. And maybe you think that this is a very easy system, but it has hundreds of state variables, and they are non-linear, and you have a lot of interaction between them. So our idea to control it is to realize that a closed biological ecosystem works like a microgrid. So you can see that these kind of closed ecosystems, when you have light, you generate oxygen the same way as photovoltaics generate electricity, and you can store this oxygen in oxygen tanks the same way that you put it in energy storage systems. And we have also microbial fuel cells that work like hydrogen fuel cells. So our idea was to implement three-level hierarchical control, the same way that we control microgrids or big power systems, or even our brains, let's say, to implement this idea for our closed ecosystem. And we generate a digital twin. And basically, these controllers are based on model predictive control, MPCs, and we had very good results. So I will just highlight the last results. You can see that when I change the light, also the oxygen production change accordingly, the same way as an photovoltaic system, and then the oxygen tank level also change very similarly as oxygen tank level as state of charge from battery systems. So we got really good results. You can see that the oxygen was fixed on 21%. If we do more, we will poison the rats. If we have less, they will die for lack of oxygen. And CO2 has to be fixed to be less of 3%. You can see that it was very good results here. So, and finally, also another interesting paper that has been appeared last year. It's about how cosmonauts that are going to be a long time in space missions, how the neural circuits are changing. And I think that this is really important, because this study was the basis for future research for how the brain changes during this future exploration. And I think that that's something that is going to be another important topic of research. Yes, thank you very much. This is all from my side. And if you have any questions, I'm happy to answer.
Okay, thank you very much, Dr. Joseph. Dr. Joseph, your topic was fantastic. Yeah, it's provide insight into what digitalization can do in our real world processes. You give some example, quantum computing, AI, digital twins, satellite communication, and of course, you give emphasis on the human brains. Thank you, Dr. Joseph. Dr. Joseph, you have someone. Yes, you're welcome. And I believe we have the youngest attendees nowadays, which is your little angels with you. That is our youngest attendees. So she's very competitive. Okay, so Master, do we have some few questions for Dr. Joseph to answer? Please ask him in our Zoom. Master, please do so while preparing. Just on hold, please on hold, Dr. Joseph, for the question which will appear in our Zoom. While waiting for the Zoom to be so Master, we're still waiting for it. Dr. Joseph, how old is your little angel?
Yeah, he's like 5 months and a half.
Wow, good. So you're not alone. We Filipinos also have your own style. We do two things. We like mother, also like father. So we have the rule also as a mother. And you are not alone. Don't mind. Okay? We are Filipino. We can do two things. So Master, please, if you are ready to flash in our question to Dr.
So,
Joseph.
Engineer Ross, there are
Yes.
still no questions in the chat box
Okay. So
regarding the presentation.
I think
Please do type in your questions in the chat box. Everyone.
I saw one of it, Dr. Jonah. Do you have one question? I saw one of it. Can I read it? This one from Internet Joey. It's if you can capture it, but anyhow, Dr. Joseph, I think if our attendees are clear enough, what are your topics? So
Perfect.
it was it's new to us, by the way. But
Yeah, thank you very much.
Yes, give us information. Don't go away. We will give you one
Okay,
more.
Engineer Ross, I think we don't have a question aside from the question of Sir Joseph.
Yes, okay, no, go ahead. Okay, 1 more minute for you, Dr. Joseph, for the presentation of our appreciation. I would like to call.
Okay, thank you.
Yes, Engineer Ronald.
Engineer Ross?
Yes. Go ahead, Engineer Donna. We can proceed for the
Engineer Ross?
Yes, go ahead, go ahead.
Okay. Engineer Ross, I think it's a very light and interesting topic, right?
Yes, it's good. So
especially because of the presence of our little cutie patootie out there.
Yeah, it was very interesting for me. Okay, AI, digital twins, digital words nowadays.
We know that we will be leading to this space. Actually, it's a trend. That's why we at the Power Electronic Society would like to help reach everybody as much as possible to understand how power and science and technology work together to provide us better living.
Yes,
Again, thank you, Dr. Joseph Guerrero, for sharing your knowledge. And congratulations to you and your wife for having your bundle of joy.
Moderators,
To award the certificate of appreciation to our resource speaker, may we call on?
yeah, sorry,
Yes.
moderators. Actually, there's a one question from Brad Joey. I just resent the question. No?
Yeah.
So, yeah.
Yes, go ahead, Engineer MP.
Yes. You wanted to
Dr.
open
Joseph,
mic
one
for Joey?
Yeah, actually, this is a question from Brad Joey. I just sent it on the chat box.
Okay.
Can someone read it? I have my hands.
Yeah. I will maybe I will send it for you, Dr. Joseph.
Or are we going to read it now?
Yes, okay. I will read it for you.
Us
Yes,
now?
I will read it.
Sir Joey.
Dr. Joseph. Here we go. Many of us
Okay, Sir Ross.
Yes.
Okay, Sir Ross. Your turn.
Yes, loud and clear. Yes, Engineer Donna, go ahead.
Oh, okay. I will read it. According to Brad Joey, many of us experiences loud snoring, which our wives or companions leave us alone in the bed. What does neuroscience can do on this bad snoring scenario?
Bad snoring. Yeah, there's a lot of research right now ongoing, especially on the bad snoring, especially devices that give you maybe some small shock during the night when they detect it. But this is let's say, very bad solution. So okay. That's a very funny question.
Yes, because
this other part, I think we cannot do anything.
Is there any solution that how we can resolve this problem?
Yes, but there's a lot of research today more on the snoring part about what happened when the companion leaves. That's nothing to do.
Because as our the one who raised the question, one answer is You have to separate with your wife during the night.
Yeah. But of course, if snoring is very, when snoring is very hard, it can give you a lot of problems. Like for instance, the apnea of the sleep. Yeah, I think it's important to have an exploration of what is the cause of that. But
yes, Dr. Joseph, if you have some the kit or equipment that can resolve this, maybe we will be a millionaire one day.
yes, maybe what he or she can do is to buy some chains, so the companion cannot leave the bed.
Okay, that's a good suggestion. No, but doing neuroscience still on the design space. So design stage. So I think there's another one, Engineer Donna.
Yes, can neural networks improve? I cannot say it. Yes, improve the control and optimization of microgrid operations, and what are the specific examples of such applications? I will say yes, especially the optimization. I don't think that about control, when you think about low levels of controls, the improvement is very small, but when you
I
think
think
about
we have another question
yes, Donna.
from the chat box.
Dr. Joseph already on it. Okay. Go ahead, Dr. Joseph. Are you?
No, it's just when you think about energy management system, to have a special neural networks for that, I think it's very good, especially if you have storage, solar, wind, then you can predict future scenarios, and then you can be able to react fast. So I will say that especially on energy management system rather than control.
Okay, thank you. That would be a great question for the one who raised it. So Donna, proceed. We have proceed to our awarding certificate to Dr. Joseph. Go ahead.
Okay, to award the certificate of appreciation to our resource speaker, may we call on Engineer Ronald O. Di Gracia, the Director for Planning and Program of IECEP KSA-ERC.
Okay, good afternoon, everyone.
Afternoon.
On behalf
Engineer
of
Ronald.
Yes.
Yes.
Can I start now?
Yes, go ahead.
Okay. On behalf of IECEP
Yes,
Power Electronics Society and IECEP KSA-ERC, it is my honor to present the certificate of appreciation, being the fifth speaker, to Professor Joseph M. Guerrero from Institute of Electronics Engineers of the Philippines Incorporated, Power Electronics Society, IECEP Incorporated, Society Accreditation Number 2. This certificate of appreciation is hereby presented to Professor and Dr. Joseph M. Guerrero in sincere acknowledgement with his invaluable contribution as a resource speaker for the third colloquium on power and clean energy with the topic Neuroscience, Inspired Artificial Intelligence and Large-Scale Brain Models for Space Microgrids. Given this 11th of February 2023, signed by the following: Engineer Christian M. Enoval, Governor of IECEP Bulacan Chapter; Engineer Gerald Jackson, Governor of IECEP Mindoro Chapter; our very own from KSA-ERC, Engineer Muhammad Ali B. Mauna, Governor of IECEP KSA-ERC Chapter; Dr. Jodelex M. Sacrelia, Governor of IECEP Cavite Chapter; Engineer Tupilo Lorenzo S. Ongkinko III, Governor of IECEP Manila; and last but not the least, Engineer Mark Philip Fernandez, IECEP Power Electronics Society.
Okay. Thank you very much, Dr. Joseph. One more time, maybe we can do it the upcoming event. Dr. Joseph, once again, we salute you. Thank you and enjoy your
Thank
family.
you.
Yes.
Thank you.
Okay. Yes, thank you very much. Now, before we move on, we will have a little topic about power electronic society updates. So there's a topic about this one. So what's PELS going on right now? I would like to call in our chairman, no other than Engineer MP Fernandez. Engineer MP, e-space is yours.
Okay. Good afternoon and thank you, DJ Bradras, and to our co-moderator, Engineer Donna Valdez, no, from Mindoro. So again, congratulations sa atin mga ka-IECEP, no. So natapos na muli tayo ngayong araw na to, no, sa ating third colloquium on power and clean energy, no. So before we move forward, palakpakan po natin ang ating mga sarili. At congratulations again sa ating lahat sa napaka-successful third colloquium. Okay. Sige, before we end this, and I'm sure iba sa inyo manonood mamaya by 7 p.m. no, tonight kay President Lyle, no, allow me to share some of the updates, no. Napaka-importante mga updates to mga ka-IECEP. So I'll be sharing my screen with the permission of our Zoom masters. Yan. Okay. Sige. Napaka-interesting topics ang mga pinagdaanan natin ngayon mga ka-IECEP, no? So as you can imagine, marami na pong ganap, no? Sabi nga, marami nang ganap na naganap na nga, no? Nitong mga nakaraang 6 na buwan mga ka-IECEP. So allow me to share yung mga updates natin mga ka-IECEP PELS, no? So nag-start tayo nung May hanggang June hanggang sa dumating tong February of 2023, no? Last year nagkaroon tayo ng mga highlights, no? Ika nga. Okay. So before that, no, balikan natin yung 5-year program roadmap natin, no. So dun sa mga sumubaybay sa atin nung nakaraang 2021 pa, no, nung May, alam naman natin nagsimula ang ating subspecialization group, no. And alam yan nila na DJ Bradras and nila Engineer Donna na itong society natin nag-start ito bilang isang subspecialization group. Yung tinatawag po nating One IECEP Solar PV System. Okay? So, sa dami kasi ng mga practitioners, no, sa ating hanay, especially sa renewable energy, sa solar, sa UPS at sa iba pa, no, napapanahon na para buuin yung tinatawag nating specialty or specialization society. Ito na nga po yung Power Electronic Society. Ngayon, balik tanaw tayo, no, yung sa 5-year program roadmap natin. Ang sabi natin, meron tayong 5-year program roadmap para masimulan at mag-jumpstart. Ika nga yung ating specialty society, no? So sabi ko nga kanina, nag-start tayo sa solar. Pero ngayon, lumawak na po tayo. Nagkaroon na po tayo ng power supplies. Nagkaroon na ng UPS. Nagkaroon na ng mga intelligent electronic devices, no? So dumami na ng dumami. Hanggang sa tumating na nga tayo actually sa space technology na. Okay? So imagine, nasa 2023 na po tayo ngayon. Nandito na po tayo ngayon, mga ka-IECEP. Sabi ko nga kanina, kung last year, magsisimula yung mag-i-start pa lang yung ating masayang journey, no? Ngayon, nasa gitna na po tayo. Can you imagine ilang buwan, ilang taon na lumipas, no? So although may isipan naman, batang-bata pa naman, no, hindi pa naman ganun katagal pa, marami pa tayong gagawin, pero nasimulan po natin ang society na napaka-exciting, no, napaka-jump pack ng mga activities, no. Of course, may mga iba po sa atin na gusto magpa-member na. Okay? So mamaya tutulungan namin kayo kung paano natin sisimulan yung journey ninyo sa pagsali sa Power Electronic Society. So as mentioned nga dito sa slide, no, nasa February of 2023 na po tayo. But sa dami na sa iksi ng panahon na to, marami na tayong nagawa para sa ating society at para sa ating organization. Okay. So balik tanaw tayo, no? Magkaroon tayo ng konting refresher mga kasama sa tinatawag po nating career progression and specialization program and credit accumulation and transfer system. O yung tinatawag natin CPSP cuts, no? Ito, pwede nyo itong kunin sa PRC website, okay? Particularly doon sa CPSP cuts menu. Hanapin ninyo yung electronics engineering po doon. Nandun yung mga importanteng dokumento patungkol dito, especially this one. Okay? So hanapin ninyo itong mga board reso na to. Napaka-importante yan, basahin nyo. But para mapabilis tayo, bibigyan ko kayo ng summary at ihiramin muna natin saglit yung mga terminologies doon sa resolutions na nabanggit. Okay. So alam naman natin ibig sabihin ng sorry dito sa acronym, no, IAPO, sorry, Integrated Accredited Professional Organization. So tayo po 'yon. Okay? Tapos ang ASEAN Qualification Reference Framework, no, it's a framework na magsasabi ito yung susundan natin towards dun sa level 8 certification para ma-recognize yung mga certification natin at yung mga specialists and experts dito sa atin patungo sa ASEAN, okay? And eventually worldwide. Okay, ano ba ibig sabihin ng career progression, no? So syempre tayo mga professionals, tuloy-tuloy yung pag-aaral natin, yung natututo tayo sa mga ginagawa natin, no? Sa totoo lang, sa matagal na panahon, matagal na mga po tayong eksperto sa mga ginagawa natin. Okay, so yan lang po ang ibig sabihin. Yung competence at yung competency, dito ngayon susukatin. Magkakaroon na tayo ng pagkakataon na ma-recognize na yung expertise natin, no. So dito dadaan tayo sa competency, no, na examination. Yung competence, of course, dito yung kung saan ka bihasa or eksperto ka, no, kagaya ng mga nagsalita kanina. So sila ay mga eksperto na sa mga kanya-kanyang fields nila. So tayo yon, electronics engineers, no, and kasama of course yung ECTs and PECEs. Equivalency, no, pag sinabing equivalency from the root word equivalent, no, may mga pinagdaanan tayo ng mga seminars, trainings, workshops, so whatever, no, na naipon natin for how many years, no. Ngayon, dumating na ngayon ang pagkakataon na kailangan natin level up, which is yun nga, yung magiging level 8 na po tayo bilang mga eksperto sa specialization natin. So sa case ngayon, yung power electronics, no? So learning outcomes, ito yung ini-expect natin. Okay? Ito yung ini-expect natin or aasahan natin kapag natuto tayo or sumali tayo sa mga specialty societies. Okay? So level alignment matrix of the table of specification, medyo mahaba lang, ano. Ibig sabihin nito, nandito yung mga evidences, ika nga, na patunay na ikaw ay specialist or expert sa ginagawa mo, no? Or dun sa specialization na sinalihan mo. So yung mga descriptors, no, yun yung mga nagbibigay ng statement, no, or patunay na ito yung mga pinagdaanan mong pag-aaral sa mahabang panahon. Lifelong learning, yan, yung of course tayo, hindi tayo tumitigil sa pag-aaral, no? Kagaya ngayon, umaattend tayo sa mga colloquiums at sa mga ibang CPD seminars. Kaya dito natin ma-appreciate, mga ka-IECEP, na dapat tayong umattend ng mga CPD seminars. Especially right now, through the leadership of our new president, no, si Engineer Lyle, very aggressive na leader ngayon, no, na pagdating sa pag-aaral at sa mga activities ng organization natin, talagang very aggressive ngayon ang IECEP. Kung aggressive na nga nung panahon ni Doc Michelle, no, nung panahon niya, mas lalo ngayon aggressive ang organization natin through our new leadership. So pathways, no, ito yung pagdadaanan natin. Kaya from the word itself, pathway, mamaya papakita ko sa inyo yung pathway na yun. Tapos yun yung ano natin, yun yung magiging guidance natin towards sa level 8. Philippine Qualification Framework, ito na yung legal framework natin para masabi na tayo ay eksperto dun sa mga ginagawa natin. Okay? So, Philippine Qualification Register, alam nyo ba na meron tayong website na dito nakastore yung databases o yung database ng lahat ng mga specialists at experts. No? So, you can search sa Google or sa internet yung Philippine Qualifications Registrar. Andun mo makikita lahat ng mga hinahanap mo, kagaya ng ECE, ECT, tsaka PECE. No? Yun, pag yun na nakikita mo doon sa website, ibig sabihin, pasok ka doon sa registry nila. Okay? So, isa kang specialist or expert sa electronics engineering, no? Particularly sa power electronics, halimbawa. So, darating yung time na malalagay yung mga specializations doon. Okay? So ito, alam naman na po natin to, RA 9292 na to, no? So ito yung saklaw. Actually, kagaya nung sa nangyari nung January 1st incident, no? Alam nyo ba na nasa RA 9292 natin 'yan. Hindi natin pwedeng pabayaan 'yan. Kaya kailangan makialam po tayo diyan. Kaya ito na yung ginawa na ng society, nakialam po sa nangyari. But in a way na, of course, we as engineers, we have the moral and ethical obligation to help the government and the nation in solving pressing issues, especially sa engineering topics, kagaya nung nangyari sa January 1st. Okay? So ito na, very common na po ito, Qualification, ito yung it refers to your formal certification. Qualified ka ba na isa ka bang specialist o expert, Ngayon, with the CPSP CATS program, i-gauge na natin ngayon yan, kung gaano ka eksperto doon sa field na hinahawakan mo ngayon. So, although syempre, by default talaga may expert na tayo lahat tayo, expert tayo sa ganito, yung iba naman expert sa ganyan, di ba? So, definitely expert na tayo lahat doon sa ginagawa natin. But of course, kailangan lang natin i-recognize through the proper regulatory body like PRC. So specialization, ito na nga po, specialized tayo in power electronics and din sa iba pang natitirang mga specializations. Marami po tayong specialization na pwedeng i-explore. Sa ngayon, tatlong specialization or societies na pwede nating salihan. Okay? So PQF QPAX, ito po siya. So kung maririnig ninyo mga kasama, meron na tayong mga ibang mga agencies na gumawa na ng sarili nilang Philippine Qualification Framework, like sa DepEd, like sa TESDA, like sa CHED, And ngayon yung sa PRC, magkakaroon na po tayo ng level 8. Yung level 8 na yun yung tinatawag na advanced PECE na. Okay? So may ECT na, may ECE, may PECE at magkakaroon na tayo ng level 8 which is advanced PECE or expert. Doon ka na sa particular specialization na yun. Okay? So ito po yung mga quick facts. So hindi ko nababasahin lahat. But ito yung qualification framework na sinasabi natin. So for the appreciation of everyone, ito yung tinatawag na Philippine Qualification Framework. So pwede nyo i-search din to sa internet. As you can see, we have 8 levels. Meron po tayo sa DepEd, sa TESDA, sa CHED. Sa PRC naman, okay, particularly sa ECE, okay, meron tayong tinatawag na professional track. Okay? So itong professional track na to, ito yung existing natin ngayon, na tinatahak natin. So mayroong ECT, ECE, tapos PECE. Ngayon, kailangan natin mag-develop ng tinatawag na table of specifications at saka yung mga professional practice outcomes para sa level 8. Okay? So, sino ang gagawa nun? Yung mga respective societies. Okay? So tayo makakaalam kung paano tayo magiging level 8 na expert, particularly doon sa power electronics, halimbawa, So since tayo mga matatagal na expert on this one, gagawa po tayo ng table specification at yung professional practice outcome. Okay? So gumawa tayo ng sariling diagram natin, no? So ang ginawa natin, nilatag natin kada swim lane, ika nga, mayroon DepEd, may TESDA, may CHED, saka yung PRC. Okay? So meron tayong equivalency, yan yung sa baccalaureate, no, sa CHED. Meron tayong mga ECEs, no, sa professional side. Pag 7 years ka na mahigit, pwede ka na mag-upgrade PECE, no? Ngayon, ito yung kailangan nating gawin, yung advanced PECE. Okay? So i-issuean tayo ng certificate na specialized tayo or expert tayo doon. Okay? So ganyan yung magiging direction. Okay, so for the updates, no, after we discuss your CPSP cuts, no, pahapyaw lang, bigyan namin kayo ng update simula nung May 2022 last year. So na-receive na nga natin yung official special na po tayo, no, accreditation. So officially accredited na tayo as one of the societies, specialty societies ng IECEP. Then nagkaroon po tayo nung July or August, July, we launched the second IECEP Colloquium on Power and Clean Energy, no? So as you can see, may mga roster tayo ng mga guest speakers, no? Doon diniscuss yung mga very important topics sa power electronics din. Last October, nagkaroon tayo ng first IECEP National Specialization Societies Conference. So we attended this one. Sa mga sa mga sponsors natin, isa sa mga initiatives natin is to have the first official visits, no, doon sa mga tinatawag po nating institutional members, no. So as you can see kanina doon sa mga list of sponsors natin, isa na po diyan si Advanced Energy. Later susunod na po natin si si ABB, no. So susunod na rin po natin sila. But still, actually ngayon, naman na sila partner na po ng IECEP. No? So after that, we visited the PELSA. No? So ginawa po natin to last October of 2022. So bumisita po tayo doon at na-meet natin yung mga high-level officials ng Philippine Space Agency. Then nagkaroon po tayo ng first ever IECEP Power Electronics Society CPD seminar na face-to-face, no? Face-to-face po ito. Kasama po yung ating mga kapartner natin sa IECEP NCR Northeast Chapter. So ang topic po nito ay solar PV system. Okay? Then noong October din, no, umattend tayo ng IECEP National, it's not 69 it should be So umattend po tayo ng IECEP National Summit. Okay? So I'll be sharing again my screen. Sorry. Okay. So umattend po tayo ng IECEP National Students Summit, no? So binigyan natin ng pagkakataon na marinig ng mga estudyante o mga teachers na umattend doon o yung mga instructors na marinig yung side natin, no, sa on the other side, no, sa ating mga hanay na mag-join sa tinatawag natin mga specialty societies, no. Of course, kasama po yung ating mga honorable chairman, no, Al Detalya, at sa ating mga BCEs din. So nagkaroon din po tayo ng first ever Christmas party last December, no. So umattend po tayo doon sa IECEP home po na headquarters natin. So doon natin ginanap yung Christmas party. Then ito na yung ito yung isa sa mga major highlights ngayon, no. So as you all know, nagkaroon tayo ng January 1st incident and fortunately nag-respond tayo doon sa call na tumulong, no, to solve those issues na technical in nature and related pa sa ECE. Okay? So umattend po tayo nung hearing last January 18, no. But before that, 1 week before, nag-release ng IECEP National statement that we are helping the government and the nation as a whole, no, in solving those issues, no. So of course in with the guidance of the Republic Act 9292. No? So we are morally obligated to help our government, no, in solving these issues. So as a duly accredited specialty or specialization society, no, we recommended some technical, recommend some mga technical evaluations, no, existing agreements na pinasukan ng government natin para makonduct yung or ma-investigate, no, magkaroon tayo ng mga audits, no, patungkol sa mga power system related failures, no. So IECEP through the Power Electronics Society offered our roster of experts, no. Kagaya kanina may mga discussion tungkol doon, no. Siyempre may mga experts na nga po tayo sa Power Electronics Society na handang tumulong at magbigay ng pro bono consultation. So as promised niya kay Chairman Romeo Acop, no, ng Committee on Transportation last January 18, handa po tayong tumulong para sa bayan, no. Okay? So ito po yung statement ng IECEP, no. So the organization likewise commends the incident responders, no, for their technical competence, including the electronics professionals involved for successfully restoring the systems amid complex constraints. Alam niyo ba mga ka-IECEP, nung pumunta po tayo doon sa facility, no, ng CAAP, may mga nai-interview tayo mga electronics engineers doon. And we commend them, no. And hopefully nandito sila ngayon sa forum na to, sa event na to. May mga ECEs po tayo doon, mga kasama. So yung CNS and air traffic management system is being managed mostly by electronics engineers, no. So we commend their untiring support and extended assistance during those holiday periods, no. So January 1 kasi yun, wala pang mga normal work days, no. So okay, so January 18, fast forward, January 18, we attended the Committee on Transportation hearing. So which is the January 1st incident, yung topic, no, on what went wrong, no, ano ba nangyari dun sa CNS ATMC service disruption. So even I believe some of our comrades are affected on this, no. So natutuwa po tayo na tayo ay nakakatulong sa nation, no, sa pag-solve ng mga issues, ng mga national issues. And lastly, no, mga IECEP, no, ito yung pinaka-importante part sa lahat, yung forensic investigation. So for now, tuloy-tuloy pa rin yung investigation, no. We don't want to preempt the proper agency that should release this official statement, no. But what we can share is that IECEP is in the forefront of this investigation, and hindi po, of course, pahuhuli yung kabilang organization din, no. But mostly sila yung muna magtitingin yan, and for now we just give our own observations lang muna. Okay, so but still we need to do some oversight din, tsaka yung mga participation din, no, sa nangyari. Okay, so we are proud to announce that we are one of the multi-agency and organizational forensic investigation, no, ng power system issue na nangyari last January 1st. And lastly, okay, we would like to thank, no, yung ating mga partners for this evening's presentation, no. So I would like to thank our sponsors and partners, no, for making this event a possible or a reality. So thank you very much sa mga sponsors po natin at sa mga iba pang partners natin. Okay, so that's basically the update, no, for our society. So if you have any questions or any inquiries or clarifications, please, we can now open this forum for our questions, no, sa mga ka-IECEP natin. Back to you, DJ Bradras and Engineer Donna, our moderators. Thank you.
Yes, thank you very much, Engineer MB, for the nice update of what's happening in our society. Okay, so I think I saw from the University of Adamson. My fellow student, can you please type Y if you are right now here, still with us, please. Okay, I still see, shout out to Jason, he said Y, yes, yes, okay, I think we have more than that Y in this chapter. Thank you, my fellow student. Anyhow, you will be with us in the near future. So first, you have to graduate. Right away, take your board exam, okay? So that you'll be qualified as an ECE or electronic engineer. And also to my fellow professionals who are ECE right now, I would like to encourage you to level up for the PECE. You know, after PECE, we have another upgrade, a specialization. So this is our way that we can say that we are special in a certain thing, even though we are in number of years working in our field, but we cannot justify that we are specialized because of this, without this documentation. Okay, without further ado, I would like to call Engineer Erwin, our Vice Chair of the Society, for the awarding of certificate to our technical speakers. Engineer Erwin, e-space is yours.
Good evening, moderator, Sir Ross. Awarding or closing remarks, am I right? You're muted, Sir Ross. Hello?
Yes, go ahead. I think we have, yes, Engineer Donna, go ahead.
Engineer Erwin, it's an
Yes,
awarding
yes,
for certificate of appreciation for
can
our
you-
IECEP chapters.
Can you show the slide, moderator?
So Master, please do so to read our presentation. While waiting for that, Engineer Erwin, so we have at least 1, 2, 3, 4, 5 chapters that make this colloquium possible. Okay, and with the help of the sponsor. So Master, are we ready? Okay, so Bulacan, IECEP Cavite, ERC, Manila, and Mindoro. So we have to give them a certificate of appreciation.
Can we show the slide?
Yeah, I think they're still preparing the slide, Engineer Elwin. Zoom Master, so you can give some short message, Engineer Elwin, while doing the preparation.
As like the
I think
chairman.
Engineer Tony has a technical problem.
Okay.
Can we wait for a while, Engineer Erwin?
It's okay, ma'am. Like our chairman mentioned, so the journey of
Okay, it's here. Okay, Engineer Erwin, e-space is yours.
To award the certificate of appreciation to the partner chapter of the Power Electronics Society, the Institute of Electronics Engineers of the Philippines Incorporated, Power Electronics Society, certificate of appreciation. This is hereby presented to IECEP Bulacan chapter in the sincere appreciation with the chapter's invaluable contribution in supporting the third colloquium on power and clean energy, given this 11th of February 2023. Signed by Engineer Mark Philip G. Fernandez, PECE, the Chair of the Power Electronics Society, Engineer Erwin Aliasar, the Vice Chair of Power Electronics Society, and the Secretary of Power Electronics Society, Engineer Antonio L. Disha, Engineer IECEP Bulacan Chapter. And also, same citation is hereby awarded to IECEP Cavite Chapter. And also as well as to IECEP KSA-ERC Chapter. And of course to IECEP Manila Chapter. Thank you very much to those chapters that has been always here to support us in our endeavors. And sana sa susunod, huwag kayong magsawang sumuporta sa society natin. And of course, with the other accredited society also.
Okay.
Back to the moderator.
Yes, thank you very much, Engineer Erwin. Engineer Donna, back to you.
Okay, thank you, Engineer Erwin. I think before we have our Zoom picture taking, let's have an announcement from Power Electronics Society. I think this will be flashed on the screen.
Yes, Engineer Donna. Go ahead, Engineer Donna, for the announcement.
Okay, we have our upcoming MidCon 2023, the 73rd IECEP Mid-Year Convention, Masterpiece, showcasing engineering ingenuity in electronics and emerging technologies. This will be held in Puerto Princesa City, Palawan on June 1 to 3, 2023. So for our ECEs and PECEs, I think it's open also in the My IECEP. You can register on the MidCom 2023. Okay, are you ready now for our souvenir photo for this event? So I think we have to prepare ourselves and show our big smile. So you can open your camera, everyone. Engineer Ross, will you taking the picture?
Who will take
Hello, Engineer Russ. Lester here.
Yes, go ahead, Engineer Lester.
I'll take charge in the taking of photo opportunity. So we have 7 slides. So just raise your hand and one to signify one IECEP. Now taking the first group, 1, 2, 3.
Keep smiling, guys. Keep smiling. We don't know which frame are you in.
There you go.
First,
Hold
second.
on for a second. Sorry.
Second slide.
Not
Keep
yet. Not
smiling.
yet.
Not yet.
First slide. I'm still
First
doing
slide.
the
First slide. Yes. Let's go. First slide. One IECEP.
Yes.
Keep smiling.
First
say
slide.
cheese. Okay.
Smile.
Second slide.
Second slide.
Okay. Second slide.
Second slide. Keep smiling. So.
Okay.
Joy.
Third slide.
Cause I can't sleep without you, no.
Fourth slide.
Sleep without you, no.
Fifth slide.
Cause I can't sleep without you, no.
Sixth slide.
Cause I can't sleep without you, no.
And last is last slide. Okay, thank you very much.
Thank you.
Engineer Donna, please do so.
Okay. Thank
Okay,
you.
so the final word muna mga
Okay.
kasama kay
Engineer Ross, back to you.
final word muna tayo kay Vice
Yes,
Chair.
it's on our list. Don't worry. Okay, before we have everything is set already for our 5 topics for today with additional one for our upset. So now we will have a closing remark. Okay, so closing remark will be presented by our very own Vice Chair of the Society, Engineer Erwin. Once again, e-space is yours.
Okay, on behalf of the Power Electronics Society, we would like to give thanks to all the participants of the concluded third colloquium on the power and clean energy, especially on our local and international experts who serve as our speakers. The partner chapter, IECEP Cavite, IECEP KSA-ERC, IECEP Manila, IECEP Mindoro, and IECEP Bulacan. This colloquium is one of the activities of societies which serves to unite electronics engineering professionals who are engaged, aligned, or have interest on power electronics. As one of the officially IECEP accredited society, the Power Electronics Society are aligned to the IECEP NSS, or also known as National Specialization Society, under IECEP National, towards the level 8 of PQF, or the Philippine Qualification Framework of PRC, as mentioned by our chairman earlier. From the last year interim volunteers of Power Electronic Society members, the 5-year milestones are on track and in the right direction, with some to mention like involvement of BPS-DTI, TC91 or Philippine Standardization, working group in IEC in International Electrochemical Mechanical, the presentation to the forensic investigation in CAAP last January incident, and the House Committee of Transportation hearing and our strategic partnership with various partners like ABB, Adamson, PILSA, AEI, and other stakeholders. For those who are interested to become a member of the IECEP Power Electronic Society, you may send an email with a formal letter of intent to our PLS email address, iecep.pels@gmail.com, iecep.pels@gmail.com. And like also our official FB page, IECEP Power Electronic Society. In the outset, we are looking forward in the next quarter for our next colloquium and the other endeavors of Power Electronic Society. The third colloquium on Power and Clean Energy 2023, theme, IECEP PELS, bringing forth advances in energy and breakthrough technologies towards a sustainable future, are now concluded. Thank you very much.
Thank you, Engineer Erwin. Again, thank you everyone for the most important part of this event. Please do not forget to answer our evaluation form. I think our technical team will be posting the link in the chat box and also on the screen. So please do not forget to answer the evaluation form for this afternoon event.
Yeah, yes. That
Again,
would
the
be a
Power
great-
Electronic Society would like to sincerely thank our speakers, sponsors, and all our participants for today. Engineer Ross,
Yes.
do you have something to say?
Yeah, yes, it's very important for the evaluation team. Please do so for your certificate as message. So I have a simple and a concluding message to everyone. In a storytelling or a novel should always start with an opening and a happy ending. So we are in a happy ending right now. In this very moment, the third colloquium is now come to an
Technical team, please.
Yes, technical team. So we're very
Please
thankful
put
for
on the
our
screen
attendees.
the evaluation form link.
Well, thank you very much for our attendees for being with us, lending us your heart, ears, and spirit to
Yes,
capture
thank you very
information.
much.
Thank you very much. We salute you, everyone, our technical
We
speaker.
hope you could join us again on our next activities.
Yes, yeah.
Let us
We're
spread
still
the power
coming.
for a brighter future. Thank you very much for joining us this event.
So the link is already in our chat box. Please do so. It's very important for us, for everyone, to have your certificate. So if you have some
And
messages,
advance happy Valentine's to everyone.
Happy Valentine's, everyone.
Yes, happy Valentine's pala.
Happy Valentine's. Oo, Sir Ross, happy Valentine's.
Yes, happy Valentine's dyan sa inyo. Dito sa amin, alauna pa. Siguro gabi na dyan sa inyo. I think it's already 7, almost 7. Okay, evaluation thing. I think we're good. So for the student,
I think we're done.
ECEs,
Let us spread the power for a brighter future, PL.
Yes, thank you very much.
So please do visit our official Facebook page, no? IECEP Power Electronic Society, and you can also join in our Facebook group, IECEP Power Electronic Society.
Oh, we're still 140, 41, 140. So countdown, moving down. 39, so they don't want to leave anyway.
Yeah, patunay lang na talagang ang IECEP ay talaga matagumpay sa ating mga specialization societies, no? So salamat ng marami mga ka-IECEP.
And
Mabuhay po
Engineer
tayo
MP, just an announcement also. This coming April, they will have also a same parallel, a same symposium or a talk or technical talk this coming April for the Telecommunication Society. Okay.
Yes.
Was
Go
this
ahead.
coming April.
Yeah, go ahead, Brad. DJ.
Yes, I would like to catch your attention this coming April. The Telecommunication Society, IECEP, we will conduct our first technical symposium. Of course, it will be probably in April 1st, a tentative schedule. And of course, your speaker is yours truly. So I will be discussing about outside plant. As we know, outside plant is very common in the telecommunication society. It's one of the infrastructure. So hopefully you can attend. Just go to our web page, IECEP Telecommunication Society. So everyone is welcome. So any more announcement from the group? So congratulations once again to our society. So we work together as one.
Thank you. Thank you very
We're
much.
still 100 plus in our Zoom. So
everyone.
yeah.
Congrats, everyone.
From
Thank
Miguel
you po.
Fernando, welcome. William Thompson, Richard
Congratulations
Gab,
po. Keep safe po. God bless. Thank you.
Thank you. You're welcome. Sige, it's open mic. You can do whatever you relay a message. Go ahead, everyone.
Music ulit.
Thank you,
Engineer
Ross.
Ross, music.
Music. Next time gagawa ko ng
Congratulations,
mahaba.
Power
Yeah,
Electronic
Engineer Joey,
Society.
message, Engineer Joey. Go ahead.
Hello, good evening dyan sa Manila, Philippines. At ito na may magsi-6 at mag-2 o'clock na rito sa Manila. So, congratulations to our third colloquium for clean energy. I congratulate everybody and people behind the scene, and to our speakers for today. But really, I'm amazed, and I just want to know what happened to Kaap. So, congratulations. Happy Valentine's, as Dr. Donna has said. So wala kami ka-Valentine's dito ni Brother Rasan. Si Brother Rasan meron eh.
Meron ako rito. Nandito si Commander.
Kami wala. Kagabi wala akong ka-partner doon sa pinuntahan namin Valentine's gala.
Anyhow, every day is Valentine's.
Tutulog na lang daw po, Sir Joey.
Tulog na lang. So kailangan lumabas tayo eh. Natutulog, baka madali ang alam.
Basta wag kayong mag-snore kasi wala pang magawa ang neuroscience.